Welcome everyone, it's Firefly with something new and exciting. So some of you might know me from other live streaming channels like AngelDust Live, where I play AngelDust. It's a video game for macOS and some other platforms like Windows and Linux. But I tried something new with these channels. I'm going to live stream development, graphics design and other activities that I would like to do in my life. And it's a new journey for me, so welcome everyone. I'm not sure if we've got many viewers, doesn't really matter. This video should also serve as like a nice guide for software development, game development and programming later on. So you will find them on YouTube and on Twitch in the video on demand archives. We've got Gaston over here and we've got the Outrider task force already visiting us. So that's pretty cool. What we're going to do today is creating and developing, modifying some PBR shaders. So PBR stands for physically based renderer. That's kind of like a recent, more modern technique for graphics rendering for video games and interactive applications, where instead of having like pre-cooked textures and like a fixed kind of like pipeline rendering thingamajig going on, you define the materials and you have a shader program which runs on the GPU. So that's kind of like a tiny program that runs for every pixel on the screen. So instead of having like fixed textures and baked lighting, you just supply all of the material properties to the engine, the render engine, and then the GPU renders it with like physically accurate rendering. So I've got this video game that already has an OpenGL shader pipeline, and we're going to take a look today at where I'm already at with the physically based renderer pipeline with the fragment shader that I came up with. And we're going to make some improvements. Hopefully we'll be able to add some very cool looking stuff. And I wanted to share that with you on this video, on this first like development video. The man's looking good. Thank you, Gaston, and everyone, welcome as well. So like I said, most of you might know me from AngelDust, that video game that I made. Coincidentally, we will be working on that video game at this in this video. Hello there, hello Angelio. We're going to work on Angelio. We're going to work on AngelDust in this video. But it's, let me open up the project here. But it's, like in the future I hope to work on different projects and show you all kinds of things that are involved in software development, game development and graphics design. So as for today, like I said, we're going to take a look at this PBR shader that I wrote. It's again physically based renderer, so material properties, like everything is already up and running, so the game works, the shader is working. But there's a few things that can be better. The game comes from a very different pipeline. If you look at the current version of the game, it uses actually OpenGL 1, which is a fixed function pipeline without any advanced shaders. I did make an intermediate version with OpenGL shaders, so that's way more flexible already. But we can take it up one notch more. We're going with physically based rendering, which is good. Sure, looking good. The black clothes fit me. It's actually blue. It's blue. Come on, it's a blue shirt. Anyway, here we go. So yeah, we're going to do coding today. It's like the game engine itself is written in C++. It's a custom engine that I wrote for this game. The graphics rendering is done via OpenGL. So we're going to be writing some. Is it HLSL or GLSL? OpenGL shading language shaders. Let's see what it says here at the top. It's version 3.3 core. Yeah, and like everything you see on screen is copyrighted by me, so please don't copy it. Okay, so here we go. So you might see that this is kind of like the base of a like PBR shader that you will see everywhere on the internet. It's got this GGX Schlick Smith thingamajig. So these are probably very famous people. Maybe they work for Disney. I think this is kind of inspired by a Disney shader, but it's all good. We're going to use the base that I have, and it's about 400 lines of code, this thing. And I'm going to show you what it looks like first. So I'm going to disable texturing at the moment. So let's type here the local material color XYZ. So this is the RGB channels is a vector 3 1.0. So I'm going to show you what, typing is kind of hard today. I'm going to show you what it looks like initially without any texturing and shading going on, and then we'll gradually work our way through adding new features to this. So, oh, you dare to copy strike you? Yeah, I might not. This is AngelDust 2, no, it's actually AngelDust 5 working title. Oh, I made a typo, of course, because Local material color is undefined. Of course, texture color is what I meant. It's like this is my first coding live stream. This is usually what I do during the daytime, but hey, don't worry about it. So as you can see, players familiar with the game already know kind of like what this dude likes in the current version of the game. But take a look at the, especially the metal rendering. So these buttons on his shirt are metal, and these side trims on his shirt are also metallic. And just take a look at like the fidelity and the colors that are going on here. I also have some proper dudes like these. Instantly you can see like the material differences between this dude and this dude. It's the same dude, but it's with different materials. So check it out. And this fighter man with the sword and the shield, he's got a metallic armor. So take a look at the reflections on this. It looks pretty spiffy, but we can do even better. At least this looks pretty good, but we can do even better. But let's hop into the game world for a moment here, and just take a look at all of like the different material shaders. So players familiar with the game know that like the current version of the game doesn't look anything like this because it doesn't have dynamic lighting. So we have dynamic shadows going on like this. You can see all of the individual tree leaves just moving in the shadow, and it looks pretty good. All of the materials have like their own roughness and their own specularity and their metallic property set. But the thing that we're going to be looking at today is improving the artificial lighting. So these are actually lanterns. They look a little bit abstract right now because they don't have texturing going on. These are actually lanterns, and we kind of want to make them look good, and we want to make them like give off light just like the sun does. So if you look at the sun, and if you take a look at the reflection here on the grass, you can actually see that the sun is reflecting off of the grass, and the grass is kind of like glossy, so it does have this nice reflection to it. The pavement, for instance, is a little bit less glossy, so you don't see as much of a highlight there as you do on the grass. But as you can see, none of these lanterns, these are lanterns too, none of these give off light currently. And in the current engine, so in the fixed function pipeline rendering, the engine takes care of rendering the light. It just passes over the lighting information via vertex colors to OpenGL. And this shader-based renderer doesn't do that just yet. But as you can see, the grass is looking pretty spiffy, the shadows are pretty nice. And like some of you might already know that the game has a time-lapse mode, so if you enable that, we can fly around with the camera and you can see the shadows just moving across the landscape. But pay close attention to the shading of all of the materials. So you can see the sun actually passing by from left to right there. So this already looks pretty good. I tweaked some of the colors and some of the shading yesterday to make it look even better than it was before. I'm also streaming and developing this on a pretty old MacBook, so please bear with me if the frame rate isn't that high, but don't worry about that. It's all about the visuals here. Also we're running in debug mode, so the code is not optimized. It's not running an optimized binary or anything. But again, take a look at the metallic like buttons on this model. You can see the reflection of like the horizon and the skybox in there. Let's wait for the sun to pass by. Here we go. So you can actually tell the sun position by the reflection in the buttons. It's pretty cool. I will teleport around in the world for a moment so we can see different terrains and kind of different material shading properties. So this is a savanna, as you can see. The water rendering is currently, like the water is cool looking, but the texturing is disabled, so you don't really see like any wobbles in the water at the moment. This is water. This is going to be water, so don't worry about that one at the moment. Oh, you're new to the game, Aesthetic Mind says. Okay, so the game, maybe you can read the title bar at the top of the screen. Angel Dust it's called. You can get the current version of the game at playangeldust.com. Like I said, it looks a bit different than this. Like the world is comparable and like everything that's built, it's the same world. But we're going to like take this to the next level and make this a proper 2022 title, and it's going to look amazing. But we're going to have to do some work. But again, like this is physically based rendering now, so pay close attention to the way the shadows, for instance, change the shading on these materials. You can definitely see some of the sky reflection come in. And you can kind of like judge the wetness and kind of like the roughness and the properties of this material just by looking at the shadow and the highlighted parts. So even though this is like untextured and this is like a very rough shading or a very rough version of the world, you can already see that like the shading looks pretty convincing. One thing that I like to do, to even show you another trick, let's open up the game world renderer here. And we can even like disable rendering of some of the smaller details. So small foliage, that's the kind of the grass blades that are standing up, we can disable those. Block decorations, that's like the small rocks that you see scattered around. If we remove those, the landscape instantly becomes a lot cleaner, and you can like see the material shading and effect much better. So people familiar with the game, hey, where's the grass? The grass is gone, but you can still see like the bottom layer that the grass stands on. So check this out, very smooth shading on the landscape. Let's hop into the world a bit more. So here we are in one of the like more special areas in the game with floating rocks, marble rocks they are. And as you can see, the marble has got this high gloss on it. The marble is very glossy. And you can see those highlights just going along with the rocks. This is blue marble, it's like, it's a magical world, right? So this is blue marble, we've got some cool grass over here, and as you can see, like this rock, the sun is over there in the sky. So this grassy knoll, kind of, it's got this nice gloss on it. So you can now actually see this specular highlight much better than before, because we disabled all of those in between grass blades. Everyone says I was always in doubt about how the shadows would act in a wonder filled with lanterns, like Versby for example. Yeah, that's exactly what I want to tweak, everyone, because right now the engine only does dynamic lighting, like this specular lighting for the sun, and as you can see it looks pretty good. But there's lots of like artificial light sources that you can, because this game is a voxel game. Yeah, I'm talking about the game first because we kind of like have to establish what we're working with here. So you can build anywhere, you can place those blocks. It looks a bit like another game, but don't worry, we have like a way more cool building system with stairs, thin blocks, but we have organic materials and like these pyramidal shaped blocks. I will show you some wonders in a few moments that players have built in the game, and then you can say like, okay, this game is totally different. Totally different. The gameplay itself is also different. So here we have some jelly. This is some moving jelly. As you can see, it's very very jelly-ish. You jelly bro. And that's cool, but it should give off light. So this is actually a mass of blobs, sort of, that should give off purple light. And as you can see at the moment, it doesn't give off light. But again, like the landscape is very cool. This floating rock also casts a shadow on the landscape. So as you can see, this is the shadow of the floating rock. And just as the sun goes by, like as the day goes by, the sun moves and the shadows just drift over the landscape. It's all dynamic rendering now, and it's just so much more beautiful than what we have currently in the game. Here we have the dude walking around. Model needs to load in. There we go. So casting the dynamic shadows like this. Anyway, so that's kind of like what we're working with here at the moment, in the beginning. One moment, please. Yeah, so people who know me from the other live stream might know I've got a little cold, so sometimes I need a bit of time in between takes. Anyway, let's move to one more area in the world. Let's see where we end up. This is kind of like a random teleportation feature. So here we are in the snow. One thing I did, the game does have ambient occlusion as well in the occluded areas. Sorry. And I removed some of the like dramatic ambient occlusion when layers of blocks connect to each other. So you get these very nice, very like smooth looking hills like this. You wouldn't see this in the current version of the game, because it does have this like very dramatic ambient occlusion effect when the layers of blocks like connect to each other. So this is one vertical layer sort of, and this block is one layer above that. And there used to be like a very hefty ambient occlusion effect. You can still see some of the ambient occlusion, so there's a little bit of light occlusion here, but it's all it's much better now, much smoother. So without the grass and without the rocks to distract you, you can now finally see like all of the material shading. It took a long time to get to this point, but it's looking good. It's looking fine and online, and we're going to make it look even better. So my goal is, let's talk about that. My goal is to add this artificial lighting. It's already in the engine, so the engine can already compute the lighting that is like kind of like hanging around each place, thanks to the artificial lighting system thingamajig. But what I want to do is add reflections for all of the lights. So most render engines, they are bound to like maybe 8 lights tops, maybe 16 if the devs are feeling fancy. What I want to do is support unlimited lights. Boom! So everywhere you place a lantern, it will actually reflect off of the blocks, and you will have these very nice like highlights coming in from all sides, feeling like you're actually there. I don't think there are many games that pull off unlimited lights, but we can do it, I believe. It sounds a bit complicated and it sounds a bit like far-fetched, but we're going to reach for the skies here, for the stars. What smells like soap, Kontara? What smells like soap? What are you talking about? Anyway, so yeah, this is the PBR shader, the basics. So we have like the entire framework up and running, which is cool. We can check out some wonders in the game as well. Let's do that in a few moments. But here's a few more like different materials. These are actually crystals that should give off red light, but they don't, because we don't have the artificial light going on at the moment. But check out like the reflections and like how the skybox reflects on this. It's pretty cool. It actually looks like a glossy crystalline thing. It sounds complicated. I will explain how we're going to approach this, and I think we can do it today. And otherwise we'll have to like spread it out over multiple live streams or dev streams. But I think we can make a very good beginning, because the engine already supports the artificial lights and already does like light propagation. We can just expand it, but seriously, it's going to look amazing if it actually works out. Okay, so check out this cool shadow from the tree over there. Yeah, so let's check out some wonders to see the material rendering in action, and then we'll be off to actually start developing. Oh yeah, my firefly wall. I'm going to allow this to connect to the game server. Let's see. It can connect forever to the Let's go. Sure. Okay, here we are actually in the online game. This is where people actually build and where you can do cool stuff like fly on a dragon like this. Check it out. I bet $33 you can do it in 30 minutes. Okay, that's about a minute per dollar, or a dollar per minute. Like my spawn in this on this account is very close to one of the wonders, the City of Heroes. Let's go over there so you can actually see like some of these domes are built with metallic materials like copper and gold. Check it out. I love gold. The look of it, the smell of it. That's looking pretty good, and I think these this like plaza below us is made out of just regular stone and some marble. Here's a bridge. So again, without the block decorations, things look a little bit more clean. But check out the smooth lighting on the grassy bank that we're approaching right here. Just check out the very nice and smooth shading on this. It looks pretty good. Yeah, I will break things. We will break things, but we'll like gradually work our way towards infinite lights. Again, these are lanterns, as you can see. The lanterns, they are pretty cool. Oh, here you can see a very good difference between the materials. So this is grey marble, which is actually pretty glossy, and there's patina, which is kind of like a rusted version of copper next to it. But just check out the difference in shading. So this is kind of like what the PBR thing does. Metallic materials, they look like a lot different compared to non-metallics. It has something to do with like their surface properties in real life. Someone figured this all out, and we can just make use of their expertise. This is a marble plaza again, so as you can see, very glossy. You can see this very nice specular highlight here on the ground. And I love just flying around with this PBR style. It just looks so good and it feels so very natural. But this bunny is made out of anodized steel, so it's got a purple color to it. Metal blocks have reflection when it's inside a building. Yeah, at the moment they do. I don't really do a dynamic like reflection box at the moment. So it kind of like the engine only reflects the skybox. So metals definitely look best when outside. So check this out in the time-lapse mode. This is a metal bunny with purple anodized steel, and check out the reflection as it moves across the daytime. That looks pretty spiffy. I like it. It's very cool. There's also a metallic lion next to it, so yeah, we're looking at the backside. Can't help it. Anyway, so how cool would it be if those metals also gave off a reflection for nearby lights? For instance, we have a lantern over here. So what I want to do is to make it that this lantern, the one right here, the one I'm zooming in on, like this one, enhance. This lantern. How cool would it be if you could actually see it reflect in this piece of metal over here? And that this lantern over there would reflect in that like bit of metal over there. And so on and so forth. So that would be really cool, right? I want to make it like that. I'm not sure if it's actually like going to work like super duper perfect, but I do have a plan and I think it can actually work. And no, it's not scripted, I haven't tried this before, so we're going to do this interactively. So let's open up one of the wonders, let's see where we end up randomly. Wonder is like a player built construction in this game. Oh, this is the Dragon's Nest spaceport, it's one of the newer ones. Unfortunately this uses a lot of alpha transparency, so these are all like alpha transparent metal girders. All the way up to the horizon, so it kind of like taxes my poor GPU at the moment, so please please don't mind the lower frame rate at the moment. But this UFO, this is kind of like a UFO that a player has built. Rob has built this. It's all made of metal, and we might be able to catch some cool reflections off of this. Yeah, check it out. So you can definitely see that this UFO is made out of metal. It's pretty metal, bruh. There's also some red metal over here. There's another like UFO in the distance there with purple and some silver coloring going on. Anyway, let's not spend too much time on on the in-game stuff. Let's improve the game. This is the Cinnabon village. We actually have another player here, I think. Yeah, this is another player. We can't tell what their name is because our textures are disabled. But hey, that's how it goes. Anyway, we're walking through this and as you can see, nice dynamic shadows and just nice lighting overall. You can definitely tell the difference between what is grass, what is like stone and what is a different material, especially here in the shade. And Ruan says, just another Tuesday, I'm having to build with minimum view distance. Yeah, that's... Hopefully once this is optimized you will be able to play with the entire view distance, like all of the view distances. Yeah, I think some NPC is trying to tell me something. Yeah, sorry NPC, I don't speak untextured text at the moment. But here's another nice house, so let's see if we can go inside and see what happens.
And now we found the loot and we're happy.
Oh, here we have someone. Hey bro, what's up? Yeah, okay, so these textures used to have color and they used to have some definition. Doesn't really work at the moment without texturing going on. I think this is, as you can see, it is kind of a reflective thing on this, whatever you might call it. It kind of looks like a television or so. Maybe it's a painting, we don't know, we can't really tell. The coins shine too, yeah, sure. At least they have reflection, check it out. This one is in the shadow, so it doesn't really have like that much of a reflection.
Like that. New
but like working on the 3D models is for a future episode. Picking up some coins and maybe checking out one more wonder. This is Valesi. I think this was built by Ruan, who is actually in the chat at the moment. So okay, we don't have texturing going on, but you can still tell that this is a pretty huge castle over here. And here we have another, like a city street or a village street. Just take a look at like the shadowing of these roofs on the boxes. So definitely different materials going on here as well. Let's see if we can catch somewhere where there's a bit more sun. But anyway, so this is the start. This is where we start from today. And now we want to kind of like improve the artificial lighting.
For this.
I'm not sure how we're going to do it, or I do have a plan. I'm not sure if it's going to work. But again, check out these lanterns. So the lanterns do not give off any light. How cool would it be if they would give off light and you would actually see like a reflection in these, like in these, all of these stones. It would be so good. But like we've got a good base. So let's work from this. Here we go. we're going to exit the game. It looks good, by the way. So also if we do a time lapse here, let's see if we move up into the sky. Oh, check this out. This is what I meant. So you can see all of the shadows just move independently. And again, this is running on a very low spec MacBook. It's an older model. So if it runs well on this device, it's going to run well on your gaming PC. But I like this. I like the coloring and like the way that this is lit. It's pretty lit, bro. Alright, so let's stop that demo for now. So back to the shader, let's see. If I enable texturing, so this actually uses the textures that are currently in the game, but we're going to retexture the entire game. I'm going to tell you this in advance. In future episodes we're going to retexture everything. Because right now textures are being applied to the albedo channel of the materials. And albedo is kind of like the color of the material. But the current textures, they're more like flattened with ambient occlusion baked in. And a bit of albedo and a bit of like the metallic property in there. So the current textures are just flat textures that used to be applied to the material. They don't really work well for this PBR style. So that's going to change in the future. So you're already up to speed on that. Sorry. And as you can see, some of the color saturation is gone now because these textures, they are mostly black and white. And they kind of drag the saturation and the color of the materials down. But still, you can see that the shading is pretty good. The shading itself is good, so you can see this highlight on this rolling hill over here. The hills themselves are very smooth. But like the textures are gonna change. I have a few surprises in store there for long-time players of the game as well, so that's going to be very cool. Let's see if we can get like more of a snowy landscape. This is semi-snowy. But well, you can see what I mean, like the shading is pretty cool, the shading is good, the materials still work even with these like non-proper textures. So we've got a good base, but we're going to focus on the artificial light today. So we're going to hack the shader and we're going to hack the game engine to support infinite artificial lights. Is everyone ready? I'm ready. I never did this before, so like I'm new to these kind of like hacking and programming videos. Let me know if you can read the text on screen, if I should change like the text to be bigger or even smaller. We'll make the most of it. We'll make the most of it. And you want this on your phone? I think it will run on your phone. Like earlier versions of this engine run perfectly fine on the phone, and you have less pixels on the phone, so it doesn't strain the GPU as much. So what I want to show you is we do have, because this is actually a changed version of the shader already. So if I take a look at, let's re-enable, yeah, we can re-enable the grass and the rocks. So what I did, of course, I disabled texturing again, but the other changes are, so I used to actually, like we do calculate the light color from light sources. We do actually calculate it already in linear color space. So that's actually being calculated right here. Like I said, the engine already provides the lighting information to the shaders. But what I used to do in this PBR shader is just like add, as you can see, we add the light color from the sources to the irradiance, which is kind of like the diffuse lighting and the ambient lighting. And we also add it to the specular component of the like light skirting objects. It works kind of, but it doesn't really achieve what I want to achieve, because it doesn't really give you the specular look and like the directional look to lighting that you want to see. So as a debug functionality, we can kind of like show you what the artificial light information is at the moment. So I'm going to copy one of these debug statements and we're going to use it somewhere around here. So instead of like doing all of the shading and actually showing you what everything looks like, we're going to just use the light colors from the sources. Let's see, with full alpha. And let's call this artificial light color. So everything where no artificial light is touching will be black, and everything where artificial light is actually touching will be the color of the light. So here you go. As you can see, the lanterns, they actually are this yellowish color, so it does have this artificial light baked into it. And as you can see, this is perfectly acceptable. This is kind of like the lighting model that the current version of the game uses. It's kind of like a flood fill algorithm. And as you can see, it just spreads along the voxels, and if there's something blocking the light, it will not let the light through. If there's something not... What? Oh. If there's no... if there's nothing blocking, it will let the light through like full force. And as you can see, it looks fine. It's pretty cool. And you could actually say like, hey, maybe the light should be a little bit stronger or maybe less strong, whatever. But we can use this term, so we can use this calculation for kind of like diffuse artificial light. So we can actually use this later on to make things look good. So to kind of like fill out some of the ambient light. Maybe like the irradiance part, maybe what we already had isn't that bad. So let's see what that looks like. If we switch back to like, we don't do this, so we don't show it as is, but we actually add it to the diffuse light like this. Boop. So we have irradiance, and the irradiance is currently okay. The light color from the sky, which is good. That's kind of like your secondary light source. And then we add the color from the sources. I like it. Let's see what that looks like. I think it is a bit too strong.
Oh, no time to waste. Let's go.
But maybe it's not too strong. So you can now kind of see, it's very subtle, but you can see that there's a little bit of yellowish light, like combating this shadow over here. But if we go to nighttime, it will look a little bit better. So maybe this is exactly what we want as a starting term. So a little bit of light filling up the shadows. As you can see, like these are bluish shadows. These are actually blue. There's no artificial light like being spread around here. And these are a little bit more yellow. It's very subtle, I will admit as much. It's a very subtle effect, but at nighttime you will be able to see the difference much better. So let's switch over to the time lapse. Here we go. And let's see what this like this ambient kind of like term looks like at nighttime. Here we go. It's going to get darker and darker, like that. Okay. You actually don't notice that it's nighttime, so it has actually a pretty not subtle effect. Let's take a bit of a step back. Let's see what happens. Night's going to fall. Yeah, you can definitely see it's subtle. I will admit as much. It's subtle, but you can definitely see that there's some light still being like applied from these light sources. Yeah, you think that stronger light would be nice, but that's not what you actually want. What you want is to actually have this light reflect off of surfaces. So you'd expect this light, like this lamp, to kind of like bounce off of this, like this this hill over here, or this like bump over here, into your eye. So just like the sun does. As you can see, the sun is now here on the ground. This is, and it moves along with the camera, so this highlight. And you want every light to have this kind of highlight. And that's what I want to make today. Try at least. Anyway, so I think we have, like, we can make it even less subtle. Let's say like, okay, instead of like having the light color as it is, we multiply it by 2. So 2 times as strong. Gaston, here we go. Because we...
no time to waste, let's go.
And now you can see there's way more light coming in even. So you can now actually see that this entire wall is being lit up like that. Like, I can dig it, you can see that like this entire shadow is being like negated by this lamp over here. This is kind of like what you would expect. Again here, this rock is actually being lit. And this grass as well, like diffusely from that lamp. So I can imagine that you say like, oh, this is what we want, this is actually what we want. And I can even make it even less subtle. Here we go, 4 times the light. Boom!
No time to waste, let's go.
Check it out, wow! And now you can actually see that it's actually starting to glow a lot. So the grass is now very light over here. And we can actually place lanterns in the game, of course. So let's try that. Here, a big lantern block. Observe the difference. Boom! Whoa! Boom! And it's daytime at the moment. So, like my opinion is that this is way too strong. The entire wall is light, yeah. You can definitely see that there's light here. And I will give you as much, like there is actually light coming off of these lanterns now, but it's way too strong, and we're not looking to make this like the entire lighting effect. What we want is something different. So I think maybe even the 1.0 version, like the single for diffuse lighting, for the
time to
diffuse
waste, let's
effect. I think that's like very nice. It just takes the it takes a bit of the harshness out of the shadow, because you can see, like, let's try it out with this. Check it out. There's going to be, like, here we have the shadow of the tree. If we place a lantern in this, see, it actually kind of lights up the shadow. But it's subtle, it's subtle. This is about the diffuse lighting, so I think this is about right. You might say, like, okay, it might need to be like 1.5 or 2 times as strong. But you can already see, like, during daytime, it will take away some of the shadowing. I think that's like as much as you can hope for. But maybe, okay, 2.0, I can dig it. Let's put parentheses around this. It's better.
Oh, no time to waste, let's
So
go.
I think 4 was a bit too strong. And this is like the reason we do this live stream, because you can immediately give feedback, like what looks good, what looks good. This is with a 2 times multiplier. I can live with this as well, but I think it's a bit too strong for the daytime lighting at least. So maybe 1.5 is the way to go. And maybe we shouldn't spend too much time on this part and then move on to the actual,
Oh, no time to waste, let's go.
like, other part that I wanted to do. So 1.5, maybe let's run with this for a moment. Too bright, definitely the first one, okay. This is 1.5, this is kind of in between. I can live with this or with the 1.0. It's like up for grabs. Maybe let's just run with 1.0, let's just straight add it. And then maybe let's move the entire diffuse calculation, like from here to this part. So we say the irradiance is the local light color from the zenith plus the local light color from sources. There we go. And then the diffuse factor becomes irradiance times albedo. 1.0 is better? Okay, thanks for the
no
feedback.
time to waste,
That's
let's
cool.
go.
Again, it's very subtle, but it's supposed to be subtle. Let's see what this looks like in Wonders, because we have Wonders have like lighting,
let's go.
consistent lighting throughout. Let's see what it looks like there. Maybe we'll get some... Okay, so here we have some red lighting coming in. Red lighting and some other colors, like that purple. This is very colorful. It's a very good test case. This was made by a Leyenda. She builds like very colorful things. So let's take a look. Does the lighting feel off, too strong at the moment? It should be subtle, but you can definitely see some like light coming in on this wooden pole here. Like I'm gauging these materials by eye. And we'll have to wait and see what happens if we move to nighttime for this. But for the daytime, I feel that the light isn't being overpowering at the moment. I feel it's pretty good. I can live with this. Very colorful, very colorful. Let's move to the next one. Just check that in 2 places. This is Electrode by Angelio. Let's wait for some parts to load in. Here we are inside, so this is, or near inside. Things are a bit darker, lots of shadows going on. These guards are just standing, well, guard. Okay, here we have some red light going on, so you can definitely feel, it feels like there's red light in this room. And I might even say that it feels too strong already. Like considering the fact that it's only diffuse lighting, but for now I can live with it. But you can definitely feel the glow, like people who know the game and who know the colors of the game, the coloring and the shading. It kind of feels like a lot of red already. So maybe the red light is too strong, maybe that's the conclusion, we have no idea. But we can tweak this later on. For now I feel very comfortable with this 1.0 multiplier. I definitely don't want to go like to 4. 4 was way too high. 2 might have been already a bit too much. And 1.5 is just splitting hairs, it feels like, so this is good. Let's time-lapse for a moment, let's see what this looks like at nighttime. Low frame rates. Okay, during nighttime it doesn't get too dark, it doesn't feel too overpowered by the lights or the lamps. And we're going to add like a major source of lighting right now. So here we go. The red one is too strong. Okay, we can like tweak the aesthetics later on. This is what we're running with for now. So as you could already see, we do have, let's debug one more time. This is like a very strong representation of the lighting in places. So let's go to a wonder. I'm not sure, is this the Terror Halloween build? I think it is. So again, what you see now is purely the lighting information. So no other colors, just the lighting. So you can see dudes move around. This is the Lord of Darkness. I could tell as much. Yeah, okay. I definitely feel that like the regular lamps could be a little bit more powerful, but it looks pretty good. You're scared? Don't be. I'll take you through this. Don't worry about it. So as you can see, some yeah, we have lighting everywhere, and I feel this is like very good lighting information to start working with. So what do we want to do? Like, yeah, if you take a look at this, definitely feel that you could make the regular lighting a bit more powerful. And right here we have lots of lights coming together. So we have a red lamp and I think a regular lamp and a purple lamp coming together. It's just a lot. And here we have the purple, pink, red district. But okay, we do have lighting information, which is good. So now what we want to do is to give this the same treatment as the sun. So the sun has got this directional lighting to it, so that you can actually see like the light bounce off of things. We're going to assume that the light color from sources, we calculate that and it's good. It's absolutely perfect. We know that the world is being lit that way. Disabling texturing, I want to run with that for now. We moved the irradiance to this term over here, and we removed it from the pre-filtered color. Yeah, so this is kind of like still up for debate. So this pre-filtered color is actually, if you take a look at this, I will show you. Hey, good morning, Obi, welcome. Obi, I'm not sure if you can rewind. Today we're doing PBR lighting, so physically based rendering lighting in the game. I already showed a lot of demos. What we're going to work towards now is to support an infinite amount of light sources that actually reflect off of things. So I already toured like what the new shaders look like. I already toured like the lighting information that we have at places. I can run one more time because Obi is kind of like a special visitor here. So this is visualization of what we think the light, like artificial light, looks like in places. So you can definitely see that lanterns have light and that tapers off. And now what we want to do is to make this like reflect as well. So let me quickly do one more demo for the people,
Oh, no time to waste, let's go.
So we have dynamic lighting. You already know this from the 4.0 beta, but this version has a few more tricks and we do a completely different rendering path. So you can see that the sun reflects off of the grass here. Maybe we can go into the world for a better demonstration. Like you see the sun reflecting off of the grass. And what I want to do now is to make all of the artificial lights reflect as well, so that you can see these highlights from all of the lanterns in the game and all of the other light sources. No game engine currently does this, I think, so infinite amount of lights, no game engine does it. We're going to try and do it, and it's going to be amazing. But just take a look at the shading and like the way the landscape looks. Yeah, reflections for all of the lights, that's what I want to do. That's what I want to do. Shadowing is going to be a lot harder because that's practically impossible, at least given the current state of the engine. But I think we can do reflections for all of the lights. And it's going to be so amazing just walking through the village and having all of these things reflect. If it's going to work. I have no idea if it's going to work. That's like a bit of a problem. No idea if it's going to work. But we can at least try to like make it look good. But anyway, this is like the PBR rendering pipeline. We already went through a few wonders, visited parts in the world where we can like definitely see differences. But just the way the materials are shaded and like what the game world looks like, it's so much better. I also disabled the I can do it one more time. Now, I disabled the grass and the rocks in the world so that it looks a bit more smooth as well. But don't worry about it, we're just going to hack on things now. Not even real life has got reflections from all of the lights. Not sure about that. So the idea that I have, and we're going to talk about it, I think, right now. Yeah, so, oh yeah, the one thing that I was looking at, like, do we want to have the lighting term inside of this reflection term? Pre-filtered color stands for, like, yeah, it says here the IBL, it's indirect whatever lighting, I think. This is kind of like an approximation of the reflections that fall onto the material. And it does interesting things. Now, interesting isn't like usually the word that you want to hear, but it's cool. Check this out. So if we select the gold material, I love gold. This is a golden slate, so let's see if we can find the sun. The sun is over there. Okay, here we go. Like the sun is now on this golden thing. And if I choose patina, like this, see the difference between these materials? So gold and patina. See the size of the reflection and like the way that it's concentrated in there. Yeah, so metals especially, so let's get a fighter model in here. Boop. Metals especially have this kind of like rim lighting and rim reflection thing going on. That pre-filtered color is actually the reflection color. So you could say like if there's a light around, it like a metal would probably reflect some of that. Sounds pretty like a pretty decent assumption. Oh, what? Oh, huh? So what if we spawn this fighter near this lantern? So this is actually what you could like ask questions about. This fighter is near the lantern, but it doesn't reflect the light at all. It's actually as if the lantern isn't there at all. Let's get it even closer to the lamp. Boop. So you will see some parts that are like not metal. So for instance, this armor, these like grayish armor pieces under the metal, they are affected by the lamp, and his face is, but the metals aren't. So the question is, like, do we kind of want to simulate that effect by using the light color from the sources in the pre-filtered color as well? So we can say pre-filtered color plus is local light color from sources, like this, and then it will kind of like take that light into account when reflecting metals. So let's put a dude right next to the lamp. Boop. Hello, sir. And now you can see that, the metals actually start to pick up some of that light. It's a bit too strong, so now the coloring of the metal is entirely off. Yeah, it will fix dark metal next to lights, but it's going to get even better. With the dynamic reflections for all the lights, your metals will already start reflecting lights. Oh yes, oh yes! So I think it's a bit too strong, but life is already better. Well, don't get too excited just yet. Maybe we just like halve this. Usually when finding values for aesthetics, it's best to double or either halve them.
Let's go.
So you, it's like a binary search to find the optimal thing, and if it's an in-between value, you can always tweak that later on. So this is somewhere in between. I think it's a little bit too strong still. I think it's just a bit too strong still. Also, his face is starting to get a little bit blown out. See that? What happened to your face, bro? Hey, but this can happen when you're next to a lamp. Let's go with a quarter.
Oh, no time
Yeah,
to waste.
I showed the game with textures, but the textures don't really fit with this rendering style because they affect the albedo channel, so it affects the material color instead of like having actual material influence. Okay, okay, there's still a little bit of this lighting going on the model, but now it's very subtle. And maybe very subtle is what we want. We already deduced that with the other lighting. So let's see a time lapse. Let's see what this looks like at evening time. It just picks up a little bit of this this lamp. Maybe it's a bit too subtle. Maybe we should go with 0.4 or 0.3. Maybe too subtle? Okay, let's try 0.4 then. I can show you with textures, but it wouldn't be too good. Wouldn't be too nice. And let's put another dude next to it. Alright, so I feel like the shadowing, as far as you can like speak of shadowing, is gone too much now. So 2.5 is too low, 0.4 is too high. So let's go with a third. Yeah, that's what I was thinking, Obi. Let's go with a third then.
No time to waste, let's go.
There aren't many numbers in between these. And it feels good to have like these regular Yeah, this is perfect. This is exactly what we wanted. You can see some of the like the off gray coloring. Yeah, this is exactly what we wanted. It's perfect. And Gaston says 0.25. I think 0.25 was a bit too dark. Then you don't really see the effect. But maybe we'll end up with 0.25. But for now, let's go with this. So let's pretend that we actually do this. So let's compare with the old version. Okay, we disable texturing. We can enable it for OB. We move the irradiance to this term, which is good because we use the sky color from the zenith. So that's like the top part of the skybox. We use that color for like ambiently spreading around a bit of light. A little bit of the local light sources. That's good. Just a very subtle. We can remove this line because we don't have to debug that anymore. So a little bit of like local light source. It's good. It's kind of like similar to what we did, except we didn't do that like that, whatever. And we still add like artificial light. It's not a specular term, but add. Okay, okay. Like I said, getting used to this. So let's say add artificial light to reflection color. So here we are calculating the reflection of the skybox, and we soften it based on the roughness of the material, and then we add a little bit of light, and maybe the roughness should actually play part in this. So what if we actually multiply by the material roughness instead? Because the rougher a material is, the less light it will like pick up concentratedly. Does that make sense? Does this still work? What are we doing? Like, does it make sense to use a constant here? Thank you, Loveface. How did you define the roughness for each material? Just another binary search for the correct values for every material. I kind of like, I can show you. This is, yo, we got a bot, yeah. I'm on the live chat. I like it, the Loveface, but I am going to give you a timeout for a moment. Put user in the timeout. I appreciate your interaction, but hey. So there's actually a code generation phase. This defines all of the things that are shared between the server, the client, the website. And like I have different material values that I kind of like just based on intuition and kind of like what they look like. So if you take a look at metal, for instance, like gold is 0.05. Obi, shall I time out you as well? Time you out as well. These are just constants throughout they're in an array, but they're also like, this gets defined as a constant. So I just throw these in and they all get defined as constants. So for instance, steel is 0.15. I'm not sure if this color scheme is the best, but if I switch my color scheme to like colors, if I don't invert them, it's not hip anymore. So, but it does make a nice difference with the other one, but it's not hip anymore. Does it matter that we're not hip? I have no idea. But anyway, these might be hard to read, these very dark bluish ones. But this is where they're defined, and then I use a code, or I run the code generation, and it spits out like all of this for use in the C++ code. So I think it's called material properties shading, material shading values.hpp. So as you can see, in C it gets flattened down to a U and 8. So this is an unsigned byte value. So for instance, the steel corroded or metal steel is 38 out of 255. You want hip? Okay, you get hip. That's what I do, baby. You ask for it, you get it. So anyway, I'm not sure if we should actually use like the roughness here. Does it make sense? Because we do use the roughness in the in like the reflection calculation here. But does it make sense to make this, like the rougher a material is, the less it will reflect light, right? So it should actually be the reverse of the roughness. So if it's very rough, it doesn't pick up that much light, and if it's not rough,
Oh, no time.
yeah, this softens the reflection. This is exactly what we want, if I'm not mistaken. So the fighter has got this like very not rough metal, and now it reflects a lot. So like in that sense, it doesn't make sense, because you actually want to have the rough materials rely on the direct reflection and not the indirect reflection. I'm not sure if we should be spending a lot of time on this at the moment. Like we could even multiply this by the 0.4 or so and then run with it, but we would have no idea
Oh, no
why
time to
it
waste.
is like that. So like it still lights up the grass, that's good. And like the effect is now subtle, but it's still here on the fighter, so it does pick up some of that light. But can we explain this to our future selves? It's like in 2 years, if we revisit this code base and it says add artificial light to the reflection color, does this make any sense at all? Maybe we should first work with the reflections and then see what happens. Like this is all PBR, standard PBR stuff. If you want, let me show you in a browser. If you want to know where these come from, it's learnopengl.com. Yeah, I allow you to visit that site. Don't worry about it. So this website contains a lot of like OpenGL rendering tips and tricks. And if you go to advanced lighting, or PBR here, sorry, you can read some of the theory. You can see like shading in their engine. And like I said, there's a lot of science behind this. People have done the science, and they came up with different models to express like physically based rendering. And if you go through these tutorials, there's also like other topics like, let's see, gamma correction, shadowing. There's all kinds of things that you can learn here. And it's a pretty good site. There's also a book, I think, made out of the website. So if you want to learn more about it, Learn OpenGL is a very good starting point. And you will see that like my shader has many similarities to the one described there, because I read the math and I like made my own shader based on that. Obi, quickly before we actually dive into the hard stuff, check this out. This is with the textures that we currently have in the game. But as you can see, it doesn't really work because the textures define the albedo, so the material color, and the shading is actually sort of applied on top of that. So it looks a bit like plastic wrapped or something. It's not really the effect that you want. It's not really what you want. But okay, it still looks pretty good with the textures on there. But the materials are a bit more muted because the color gets sucked out. Because they get darker. So this is not what you want. As you can see, it looks a bit bland, a little bit grayish. So we're going to improve the textures. I already spoiled a few moments ago. We're going to retexture the entire game on this live stream. Well, not this episode, but in the future we're going to retexture everything to make it work with the PBR pipeline. But okay, like in the distance you can kind of see that it works for the grass. It's fun to see the grass have a bit of shading to it. But for now we're going to work with the raw material like model instead of using the textures, because textures will only distract us from the way the shading actually looks. So I'm not sure if we're going to do this thing at the moment, this pre-filtered color. Like, let's focus for now on getting the artificial light going. So let's remove this term. And I can live with the irradiance. I think that's a good idea, to have a little bit of diffuse light always be spread around.
Oh, no
We
time
saw
to waste,
in
let's go.
Angelios Wonder that the red light kind of like filled up the room. That was a very nice effect. It might be a bit too strong. Like, again, I think that it's a bit too strong here as well, so maybe we tone it down already. Let's see. Local light, let's tone this down to 0.5. See what it looks like. Because it's daytime and I don't want to make the lights too overpowering. Okay, definitely less glow in there. And just a bit of light here on the walls. So you can argue like what it should look like. You can argue about this. I don't know. Maybe it should be, maybe one was good, because shadows can be displaced by a lamp.
Oh, no time to waste, let's
Because
go.
otherwise, why would you have a lamp? And again, like the wall has got a bit of like coloring to it. Yeah, maybe this is good. Maybe this is good. Check it out. So the lighting effect isn't too strong. It's there. It's not too strong. Let's see what it looks like up on this. Up on this. So see here, there's just a bit of light coming in from the lamps on the wooden planks here. And what does it look like here? Yeah, just a bit of light coming off of. Don't mind the seam here. That's a artifact of the way this is rendered at the moment. Yeah, just a little bit of glow in the dark areas. It's good, it's good. And you can see here, like the lamps have a little bit of glow to them. We can tweak this later. Looks fine to me, looks fine to me too. Okay, so now what we want to do is the following. As you can see, let's try to find a clear area here. And we'll also want to, yeah, I'm going to disable the grass and the rocks, because they're just in the way here. Foliage decoration, let's turn them off. Here we go.
Oh, no time
So
to
Obi,
waste,
you
let's
might
go.
not have seen this, but this is what we looked at earlier. So no grass, like decorations, no rocks, entirely smooth. I like this look for now. Oh, this is not the area we want to be in at the moment. So we're going to look at like the sun. Where's the sun? Over there. So you can see the sun has got this specular highlight. That's what we call this like glossy thing on the materials, this. The sun has got that, and that's really cool. And now we want to have a similar effect for the artificial lights. So how are we going to do that? It's like the idea that I have is the following. Like you see this effect right on the brown material here. It's the sun just moving along, and as the sun moves, let's go to the time-lapse mode. As the sun moves around, that gloss kind of like follows us around the entire way. So let's move with the sun here. You can see that glossy spot, it's just covering different areas. So my idea, and I'm not sure if it's going to work, my idea for this is the following. Let's go back to the village.
Oh, no time to waste, let's go.
So we do this algorithmic flood fill kind of. We spread out the light. This is what we looked at in debug mode a few moments ago. We have this concept of where light is falling or is being radiated. It doesn't have a direction, so that's why we're using it for the diffuse reflection at the moment, because this light is supposedly everywhere that it touches. It's a subtle effect, but as you can see, like a light should kind of light up the areas around it. That's kind of like the way the way the game assumes light works, and that's the way players currently build buildings. Like you place a lamp and it will light up the area around it. That's very logical. That's very like what you want. So we might not be able to go to like a perfect physical model, because then everything will look too dark or the lighting will be odd. So we will always have to have like this kind of like diffuse lighting up areas. But now what we can do is to enhance the lighting effect to make it directional. So that's like the step that we're going to try and add directional lighting for this. So just as the sun only has the specular light like on the grass right in front of me, and it doesn't have that specular light on this grass because the sun is actually behind me, so it doesn't like reflect off of this grass back into my eyes. We can try to make the lighting information that we do have in the shader and in the engine try to give a bit of a direction. So what we can do is we have these light values that say like, okay, here's yellow light, here's yellow light, here's yellow light. Let me use the block picker here to point. So here's a lot of yellow light, here's a bit less yellow light, here's some less yellow light, but here's also a bit of yellow light. On this spot is a bit of yellow light, and it's all coming from this lamp. So we can try to add directional information to these like vertices. So every vertex we can say like, okay, the light is coming, the artificial light that we have is coming from this lamp. So we kind of want to add a vector, which is a three-dimensional vector in our case, because we're in a three-dimensional world. We want to have a vector that's kind of like where I'm standing right now, pointing towards this lamp, saying like, light that is in this spot where I'm standing currently is coming from this lamp. I don't want to make it so that we can have like every light affect every pixel or every vertex. We're just running with the closest lamp towards the spot and see what that looks like. Because we have to push all of this data, we have to wrap it into render buffers, push it towards the graphics card, and then like when we're rendering, we're going to take a look and like, hey, is this lamp, or like is the light on this spot coming from that lamp going to hit our eye? That's what we're going to add. Yeah, just the closest. But here's the thing, if you take a look at the village, like the closest lamp will always be like the lamp that is providing the lighting. There will be like wonders that have a lot of lamps, and I mean that you can always do this. You could build something like this, like, whoa, the super Lampotron Wonder 3000 or building or whatever. But then still, like, is this lamp, are you going to really notice that this lamp isn't going to be reflecting in this block? Or whatever, we're going to see what it looks like. Maybe it doesn't make sense, maybe it looks very ugly and we will have wasted a few live streams on this. Doesn't matter, it's what I want to try, because it's the best I can come up with at the moment. So we do the flood fill. What happens if two lamps are at the same distance away? Then one will take precedence. And maybe we can come up with some good heuristics. So there's already things that I can think of that would make it much better. But let's first get an initial thing going, and then we can refine it. So we already have this lighting information, which is cool. We already know where light is being spread. We don't really have to change that. We're calculating the light inside of the shader already, so that's this part. We have vertex lighting. It's a vector with 4 elements. We have X, Y, and Z. The X component, the first component, is for the ambient occlusion that it receives, I think. The Y component is for the artificial light, so that's the yellow light that you see. The Z component, which is the third element, is for the red lightings, so the red light that we have. And then we have violet, which is kind of like the purple light, ultraviolet is called. It uses W, so this is a vertex lighting. It's got X, Y, Z, W. That's kind of like the components to that vector, or if you use RGBA, that's the same. So it's 4 channels of information, and we don't have to touch that because we can actually calculate the RGB color of the light at that exact point from all of the information that we already have. And we use vertex lighting.x. Let's look it up. .x. Yeah, that's the shadow factor. Okay, so it's not ambient occlusion, but it's the shadow factor. It's what we use, or what we use for distant shadows. Because the game engine, the old version, did shadowing like in vertex colors. So distant lighting, like this is dynamic lighting. This is like actually rendered from the geometry. Very distant lighting. I'm not sure if we have some here. We'll use an approximation that's baked into the vertices, kind of like the current version of the engine. But since you're mostly up close and personal with like geometry right next to you, you don't really notice this. Now I see why there's no other colors. There you go. What we could do in this engine is pass a RGB light information to the shader from the engine. But that's for the future thing. But this is like we could make flickering lights, but that wasn't possible without shaders. Hey, thank you everyone. Thanks for being here. Maybe you'll find, maybe you've learned something from this. I hope so at least. But now we're going to get to the interesting part. But make the most of your day. Hope to see you tomorrow on the regular live stream. Okay, so here's the plan. What I want to do is add directional information to the shading information. So if you take a look at what the information we have per vertex, shader inputs from the vertex shader, we have the vertex lighting, vertex material, material map coordinates, normal maps, the fog. So we kind of want to add a new vector here, which we would call like vertex lighting direction. I think I want to use like 4 elements for this, because 3 elements is just very inefficient for packing. But maybe shader optimizers can work with a vector of 3. So we only need x, y, z. Hey, oh, but yeah, that's the prevented division by 0. That's almost in every tutorial that you see, because we're dividing. It's kind of big brain. Yeah, it is. It kind of like makes the results a bit less accurate, but there's another one that I have to add, because the water, maybe you already saw it in this file that I showed you with all of the material definitions. Let's open it up again. The roughness of the water is actually 0.0. So there's a division by 0 going on somewhere in the shader with that as well. So there's another place that I kind of like have to truncate that to a 0.001 or so. It's not much, but just slightly below or above 0, because otherwise you're dividing by 0. It's called epsilon. It's usually like epsilon for floating point inaccuracies. Okay, so we kind of want to add this sort of thing, vertex lighting direction. But let's fake it first. That's what I learned. We're going to fake it first. So we're going to take our shader that works. We're not going to add anything just yet.
Oh, no time to waste, let's go.
Because let me draw a quick diagram here. Let's open up text editor. It's not hip. Sorry, the color scheme is black on white here. But this is an overview of how the rendering engine works. Yeah, the problem is this gets rounded down to a byte value, unsigned byte. So you always end up with byte value 0, even if you use very low values as a floating point thing. So what do we have? So we have the game, right? This is where we start. The game, it's got a rendering engine. And the rendering engine, this is kind of a very high level overview of what we're going to do here. The rendering engine. The rendering engine has got client, let's delete, client chunks. These are 32 by 32 by 32 parts of the game world. The rendering engine has access to these client chunks. And they are kind of like these cubes inside of the world containing the geometry, but also they track like what entities are there, what blocks are going to change, what's happening, did we read them from disk yet, are we going to write them to disk? So all of the cells, kind of like the information, the voxel information is stored in these client chunks. And this is actually called a client chunk in the C++ code, so let's go with that. And this is actually called the render engine, so that's pretty cool. But let's keep it a high level overview in English terms. So client chunks. These client chunks, they have like these render buffers. And the render buffers contain render vertex instances. So let's call this a standard vector of render vertex. That's what a render buffer is. These render buffers are generated from geometry. So these are whatever, like geometry meshes. I'm not sure if these should be the other way around. So yeah, let's say the client chunk, it's got geometry, or it gets meshed, and that's a series of model vertices. So that's a vector of model vertices. Those get converted to like render buffers with render vertices. That goes to the GPU. That goes to the vertex shader, and that goes to the fragment shader. And you are here. This is what we've been looking at the entire time, the fragment shader. So this is ultimately what pixels look like on screen. There's a lot of things, a lot of steps that happen before this. So we're going to have to change all of these steps, or at least up until the geometry, I think. And there will be other parts as well. So the geometry gets meshed, and that gets it's a concept I call beautifying. So we generate mesh and then beautify the mesh. And beautifying is kind of like the process where we calculate the in-game world properties of a vertex, set them in the model vertex thing, and that gets converted, or like that gets shoveled to the GPU en masse. So we're going to have to do all of these things in a different way now, because we want to have directional lighting in the fragment shader, so it has to be supplied from the vertex shader. This GPU thing, let's just call this GPU vertex shader, GPU fragment shader. And let's remove this step. So we have to get that information, the information all the way from about here to here. So we're going to have to change about 7 steps or so in the game engine and in the entire pipeline. But we're going to get there. What we're going to do is to stub out these values. So we're going to fake everything at each like higher level. So we start here. We're still going to start with the fragment shader, the part that we've been editing this entire live stream so far. We start there and we just start with fixed values. We're going to emulate that the light is actually coming in right from the top, as if like every like photon coming in from these artificial light sources is coming in from the top. Just like the sun has got its position, every like bit of light is coming in from the top, right? Then we can actually see what it looks like in real life. Like what is the effect kind of like going to look like, even though it's not perfect. And then like all the way down, we're going to start calculating the actual values, the actual directions of the light. And then because everything so far, like everything at the bottom is already working up and running, we'll gradually see things improve up to the point where we say like, bam, this is it, this is perfect, we're going to run with this. So this is kind of like what we're going to do. The game, we're probably not going to touch too much. The render engine, we have to touch just a few parts because we have to shovel a bit more data left and right. Client chunks, we're going to have to change some of the lighting information that's stored there, because right now it only contains the light values at all spots, but not the direction of the light. So we're going to have to actually do that. While rendering the meshes, like generating and beautifying, we're going to have to take this lighting information and push it inside of these model vertices. So that's what it's going to result in. Then we'll have to do a bit of work in the render bufferings, render buffer structure thingamajig, to make sure that these render vertices include this new lighting information and actually calculate it and contain it in the right way. And then we're going to start with these vertex and fragment shaders. Actually, the vertex shader kind of ties into the render engine because this communicates with that. So if you take it like this, boop, it's kind of like this hierarchy, and of course the game is like the topmost hierarchy. So it's kind of like the render engine. Yeah, this is sort of like the hierarchy of things. Should I save this, or are we just happy that it looks like this and we're going to just work our way from this all the way up to the top? I hope it makes sense. Again, we already have the lighting information here, so we're going to fake data all the way up the stack until we're up and running again. So I'm going to close this. We happy? Okay. We're not going to save it. Starting off with a fragment shader. So instead of adding a new thing already, we're just going to work with what we have. We're going to fake a lighting direction right here, right now. This is where the sun is being calculated. So this is the reflectance equation. Look up the PBR thing on Learn OpenGL. It tells you what this is. And this LO, I'm not exactly sure anymore what it stands for, LO or L0. It's actually like the reflecting light that's coming into the light source. And you can actually add terms to this. So this used to be a loop. This used to be a for loop for int light index is 0, light index is smaller than light count, light index plus plus. So this is kind of like what the loop would look like. And then for every light, it would calculate these values and add them up. So that's the entirety of the direct light that's coming in on the light source, or sorry, in on the material, going towards the eye of the viewer. So that's cool. What we're now going to have to do is to, like, we're not going to loop this because we can't, we don't really have multiple lights, but we do have a loop count of 2, but with fixed inputs. So we kind of have to duplicate this entire section. So this is the reflectance equation. Let's call it the sun reflectance equation. Let's copy this entire thing. And now the artificial light reflection. We already have LO, so we're not going to do anything with LO here. We're just going to add at the end of this. So this should compile and run, but this should kind of like double the light coming in from the sun, because we do the sun calculation twice. Already you can see this dude is now over bright.
No time to waste, let's go.
The grass is over bright, but at least you can see, yeah, the sun is definitely working and it's not doing anything else. It's compiling, it works, so that's cool. Okay, so here it says calculate the per light radiance. It's actually not true, so let's calculate the sun radiance here. And right here, calculate the artificial light radiance. That's actually what we want to do. So L is the direction where the light is located, which is cool. But we're going to fix this at the moment, so we're going to make this a vector of 3. 0 on the x-axis, 0 on the y-axis, and is this the direction to the light or from the light? We're going to have to see. So it's a normalized vector this way. We're going to say like it's coming in entirely like straight from the top. Z is up in this engine. Let's see what that looks like.
Let's go.
So we now should have 2 suns, sort of, because we have the actual sun and the fake sun. And one of the light sources should be looking as if it's coming like straight from the top. But does it? That's the big question. Like, is one coming straight from the top? So that should always be right below us. And you can actually see there is a light actually right below us. See this? This white spot? It actually follows us around. Wouldn't it be a bit hard to see reflections coming straight from the top? Not if you look down. Not if you look down. It isn't. Oh, sorry. You can sort of. One moment. So yeah, I looked up my cheat sheet. No, I didn't. But you can see, like, there is definitely a light source straight above us. Now to double check, we're going to say the light is coming straight below us, from straight below us. Nice thumbnail. Oh, it's cool. It's pretty cool.
Oh, no time
so now
to
we
waste,
shouldn't
let's
see that. Like, the sun is back to normal, as you can see. Sun is right back to normal. And now there's a light source right below us, but it will never hit because we can't see faces that are not in the shadow where light will fall. No, I think it's impossible to see at the moment. So we should disable shadowing, but I think this is just working perfectly fine. Saying the light is coming straight from the top.
Oh, no time to waste, let's
and
go.
the farther something is away from you, because here's the trick. The farther that something is away from you, the more light will still come into your eyes. Even if the light is coming in straight from the top, because things will reflect right into your eye. Let's see if we have this spot on the ground again. Yeah, so definitely light coming in from the top. I'm not sure if it's like it's a very small spot. It's still here. You can kind of see it moving around. I'm not sure if it's tied to the camera or... We're going to have to do a bit of debugging on this. Hey Alexi, how are you doing? But this is what I wanted to say. Okay, let's say light is coming in straight from the top. Then it normalizes a view vector. So view vector is V. It's the vertex position in the world. Or on the main screen it is facing right towards you. Okay, that looks good. That looks good. It's there for sure. Yeah, we can also always multiply this and say like, okay, let's fire up the sun a bit more. Okay, and then the radiance. It says it's the scale of the radiance, which is just kind of like a sun scaling factor. So maybe we should rename this. Where is it? Scale PBR sun. Let's call this sun, like this. And let's make sure we only do it for the sun. So that's kind of like the scale of the intensity of the sun. And right now we're going to just tweak with this, and let's say, okay, we want to debug this, so let's make this 8.0 even brighter than the sun. The color itself is not the color of the sun, because that's not what we want. We want this to be the local artificial light color. So it looks like we're going to have to calculate that a little bit earlier here. Like this. So artificial light reflectance equation is it's all good, but let's calculate the artificial light first. So we're going to use that color. So for now, like in the village, it's going to be all yellow sort of. And we don't have to remove light if it's in the shadow. So this kind of already determines, hey, if it's in the shadow, we have less light coming in. But since we don't shadow per light, we're just going to make these always light. And you see this in commercial engines as well. Not all of these dynamic, so kind of like dynamic lights, have proper shadowing. So for now I can live with this. We're going to do that like super duper geometry calculation on the roughness and on the metallicness here. It uses the normal in the world. This doesn't change for the sun or for the light source. It doesn't change that. Age is based on that. Roughness is still the same. So I think these calculations are the same, be it for the sun or be it for the artificial light. This just calculates those things. Normal in world, normal in world. This doesn't change anything. This is cool, this is cool. Metallic doesn't change, local in world. The albedo, specular, radiance, n.l. I think all of these other terms, like all of this other calculation stuff going on, like this part, it's actually the same for all of the lights. The only thing that changes per light is the direction the light is coming in from, then the bounce into the eye, and then the color of the light. So I think we're good. I think we're Gucci with this. Let's see what this looks like.
Oh, no time to waste. Let's go.
So. Okay. I can see some artificial light here on this grass coming in from the top. Yeah, I'm using this a scope. This is a scope, so I'm using curly braces as a scope so that KD doesn't leak out of this, and you can reuse these variable names. It's to like make sure that every variable has got as tight of a scope as it can have. So maybe we can even disable the sun. How is that? We disable the sun, we make the artificial light a lot stronger. Hey, how are you looking without this sun?
No time to waste. Let's go.
So, okay, artificial light is always coming in from the top. So how does it affect the vector to the view? Let's see. You can definitely see that there is artificial light being cast. Okay, and like the closer we get, the more intense it is. I do have a nagging suspicion that there's somewhat of an offset to it, so it's not exactly straight down. Feels like, but you can definitely see like this lamp is reflecting here. And is this lamp? Yeah, this lamp is reflecting here. Check this out. See it? And of course you see it mostly now because we are actually right next to the lamp and it's coming, the light is supposedly coming from straight up. Yeah, it is. It is very subtle though. It is very subtle. So can we see the same here on these stones? You can see it working. You can see it working. Like every light Because this is the cool thing. You see, every individual light now has this reflection thing going on. It's subtle, I will admit as much, and it's not like this is not the final version. It wasn't supposed to be the final version. So let's fire it up even more. Let's make it even brighter.
Oh, no time to waste. Let's go.
But you can definitely see, yeah, you can definitely see the highlight moving around. It doesn't, like, making the light brighter doesn't actually make it easier to see. It just makes it, like, brighter. I was wondering, like, nowhere in the world, nowhere in the game world are artificial lights. Oh yeah, we do have artificial lights in the world. Come on. We just need to hit one of those more magical areas. Let's see. Here we go. There's some crystals over there with red lighting. It's there for sure now. Yeah, sure. Okay, so that's step number 1. What are you doing, step bro? This red light doesn't really reflect too well off of these surfaces. But we can actually stand on top of these. Maybe we can find some of those purple ones. Let's teleport around a bit. There should be purple ones somewhere around here. Yeah, here we go. Very bright, very bright. Yeah, you can definitely see this highlight right below my feet. It's definitely there. But again, I have this suspicion that it's offset a little bit. Like it's to like the top of my screen. If I look this way, it's to the right of me and to the left. Maybe that's because of the way the hill angles. Maybe we can find another angle. So right here it's to the bottom. Now it's to the right again. Yeah, so it's kind of like dependent, and it makes sense. It is dependent on the angle of the thing that you're looking at. So again, here we should have like these highlights. This is it. Here, these are the highlights we're looking for, and they're near the lamp. So it's not perfect, of course. And as you can see, the lamp itself, this object itself, is casting light on itself. So that's why it's got this specular highlight on it. But all of these specular highlights that you see, they are now coming from the lamp. So this is supposedly fake light coming in from the top, from a lamp that you can't see. But it's something, hey, we gotta start somewhere. You can definitely see it very well on these, this very shiny marble. And you can see it's actually already dependent on the angle to the camera as well. Alright, so that assumption, the assumption holds true. Like we do have lighting going on. Now to add the directionality and do it fast. How are we going to do this? I have no idea. Maybe can we debug this? Let's say local fragment color .xyz. Let's make this a vector 4. And then we use the F0 1.0 return. Does this work? I want to debug this vec4 local fragment color like this. It doesn't work. Oh, it's called fragment color. There we go. Fragment color. And that's already defined, I think.
Oh, no time to waste. Let's go.
Yeah, this is much better. This is exactly what I wanted to do. Why is this not working? We have no idea. Doesn't matter. We have something up and running. Let's run with that.
Oh, no time to waste. Let's go.
Okay, we disabled shadows. And we disabled the sun, we disabled shadows, and we're purely looking at the like incidental light now. So it is entirely like, come on, it's entirely possible. Yeah, I broke reality. It's entirely convincing that if the light from this lamp, like suppose this is a very large spotlight, I'm going to tell you why this is a good thing, why things are actually working the way we want them to work. Suppose this is a very large lamp, shining a very big spotlight shining down from the sky, like this. It is going to cast somewhat of a light thing that looks like this, right? So you can see the lighting is actually offset by a little bit, so we might want to do some centering or something on this, because this corner is definitely brighter than this corner. So there's a bit of a grid shift going on there. You would expect the light to be inside of the box, like centered inside of the box, so and not shifted towards one corner. So maybe there are some other gains to be had here. But we can debug this in a later stream and we can make it perfect. For now we want to work on the directionality, right? So imagine a spotlight shining down down from the sky. It would actually it would actually brighten up an area like this, just like this. If we take a very shiny material, is this gold? Is this gold? Does this look like gold to you? Hello? Oh yeah, this looks like gold. Check it out. This would also mean that if there's no lamp around, here, there's no lamp around, no thing. There's a bit of a lamp. See it? See the lamp fade out? See the lamp fade out? It actually works per vertex as well. This is that lamp, I think. I'm pretty sure that it's that lamp influencing this block. No way, Jose. Check it out, it actually gets brighter. The spotlight gets brighter the closer we get to the lamp. So, see? It's kind of what we want, but now we need to add directionality. So if you're standing here, you would see the reflection of that lamp over there. So you would expect it to reflect somewhere here, like from there to there. So I think the theory holds. I'm even amazed that the lamp, like the effect is measurable up until here. Like when doing the visualization earlier, you didn't really see the light stretch all the way to here, but apparently it does. But that's good. That will give some very nice and very long range lighting effects. Maybe it's too strong, but we can always tweak. I mean, this is about how many blocks? 1, 2, 3, 4, 5, 6, 7, 8 or so blocks. And then it's also down a block, so it's about 10 blocks away. Ortho, linearly, whatever. Anyway. So add directionality and we're done. Also check out the top of the wooden poles. They are very well lit by this thing. The lamp itself too. Okay, we're golden, we're golden. This works. This works. We have a fixed light direction. So now we're going to make this dynamic. How do we make this dynamic? Good question. We add the normal direction here. So let's say an in. Do we use a effect 3 or effect 4? Like these normals, they only have let's use the smallest amount of data possible. Let's say vertex lighting direction. And then we have to agree that it's the direction towards the light. First we cry. No, we don't cry. We don't have to cry. Vertex lighting direction. Alright, so we're going to make it dynamic now and say the light direction is now vertex lighting direction. Sounds cool, right? This won't compile because it doesn't link the inputs together. So now we're going to have to open up the vertex shader. So let's open up our project. Let's go to artwork. Shaders, OpenGL 3.3, vertex shaders, the generic vertex shader. And we're going to output something, and it's same as the input. We also have the basic frag still here, but forget about that one. I forgot about it. So let's output the vertex. So remember the diagram, so the vertex shader passes data towards the fragment shader. the vertex shader is kind of like the thing that runs for every vertex in the input, and then the fragment shader runs for every pixel in the output. All right, so we supposedly export a vector here, so lighting a material. So now we're going to say vertex lighting direction is a vector 3 of 0, 0, 1. This should compile, this should run. But now at least we moved the fixed definition over to the vertex shader. So we're passing along more data and it still works. See, it still works. So we're Gucci with that. Now we want to pass this over to the engine. So instead of like having it fixed inside of the vertex shader, we now move it to the render buffers inside of the game engine, and that's going to be a bit of a heftier change. We're going to see what that entails. So far, what are our changes? I'm going to revert this change of the grass and the stone, because the smaller we keep this diff, the smaller we keep the changes towards the existing code base, the better. Again, it works. We now also have the grass blades and the stones here, so don't worry about those too much. It's about the lighting that we see in this block, in these blocks. Okay, so that's cool. What else did we change? So the fragment shader, that's cool. We're happy with these changes. Maybe we can re-enable the sun already because it's good. And maybe not. It's all good, don't worry about that. So the fragment shader. Vertex shader, alright, so we're now going to have to make an input for these values. Let's make some room here. And I think right before we dive into the game engine, I want to take a small break. I need to get some more water. The grass blades and stones, everything will reflect all of these artificial light sources. It's going to be glorious. You haven't seen anything like this before ever. It's going to be so cool, you won't know what you're seeing. Seriously, it's going to be that cool. I hope. One thing, while live streaming, one thing that I considered was like, will models reflect all of the light sources? That's going to be a different story. But like the entire game world so far, yes, that's what I'm looking forward to adding. So from the shader inputs, we get a position, color, texture coordinates, normal. Let's keep it simple. We're going with the vec3 here as well. We can optimize this later on as well. Let's call it lighting direction. Lighting direction, that's what we get from the buffers. And then we just pass that along. So this is simply passing this along.
Oh, no time to waste, let's go.
Now it doesn't work because we actually don't receive the input, so this value probably gets stopped to 0. So we don't see it anymore, and we're going to work on getting that value inside of the vertex. Yeah, this is a shader constant. We use it for fog calculations, I think. Yeah, it does an e to the power of minus log 2. It's exactly what you ever wanted, what you always wanted. I'm going to take a very short break. It's not broken, it's just like we are passing a value that's not there. So we're going to work on getting this buffer lighting direction filled from the engine in a few moments. I'm going to take a very short break, give me like, what shall we say, 5 minutes tops, but that's like super tops. I'm probably back in 2 minutes, but I'll see you in a few seconds. Be right back. Yo, it's as simple as that. Here we are again. More water and we're ready to go. I'm not sure how long that was, but it was probably less than 5 minutes. Alright, so we were at the stage of getting the lighting direction into the vertex shader. So that's kind of like the second bottom step, second to last step. What we're going to do is we're going to teach the render engine how to get this information into the shader. What? Hey. Let's open up the render engine, OpenGL. Here we go. And let's take a look. So I think we're going to have to add some of these vertex attribute arrays. And where are they defined? And let's see what do we do with them. This is all complicated render engine stuff. Feel free to take a look around, but we're going to have to take a look at these are all. Right, here we have them. So this is the position. Let's open up a assistant view here. And let's open up the render vertex definition in the right screen. So okay, here we go. Does this make sense? This is like the data we're sending over to the GPU. Here on the left side we are actually sending the commands to say like, okay, this is what you're going to get. You're going to get these vertex attributes. And here you have the definition of those. So we have 4 unsigned shorts or signed shorts with the position shader flags. Per render vertex we've got 4 bytes for the colors. We've got 4 bytes in total for texture coordinates. Then we send over the normals as we're going to send another set of these normals as the lighting direction. So this is what we're going to add. We have shadow factor, artificial light. This is kind of like the same deal that we saw in the fragment shader. This is the X, Y, Z, W lighting components. Metallic factor, roughness factor, unused, so we have a few bits left. Ambient occlusion factor, and then a material map and a normal map. So those are unused at the moment, but the engine kind of supports them already. So we want to add lighting direction, and this is the light coloring stuff. So let's see if we can kind of like make it nicely aligned. Hey yo, welcome back everyone. We're at the stage of adding directional lighting information from the engine to the vertex shader. So I made a diagram of steps. Maybe I should have saved it, but we're here. We're doing this. So we're going to add 4 more bytes here, and let's call them lighting direction X, lighting direction Y, lighting direction Z, and then we have another unused at the moment. We're not going to pass that to the vertex shader, but it's going to be unused. So the vertex size changes. We now have a 4 times 1, 4 times 1, 4 times 1. So there's another term here, 4 times 1, that we're going to have to supply to the thing. It's still we can still divide it by 4, we can still divide it by 2, and of course we can still divide it by 1. That's always possible. We're not going to set stuff on it just yet. That's going to be the second step. So our render vertex structure itself, or the data, because it's actually just a flat array of data, now should support more of this stuff. I think some offsets have changed, so we might have to update the render vertex CPP. We can take the easy way out. Let's take the easy way out instead, shouldn't we? Should I just move this to the bottom of the structure? We can, like, it would make the math over here a bit easier, because lighting, material, what did we change? Lighting is unchanged. Prelit factor, that's stored in the normals, that is not unchanged. Material, so the material is now on 1 index higher. The material map is also 1 index higher, and the normal map is also 1 index higher. So our we can make a setter already. Render set lighting direction, and then we want a const int. We use int 80s here. So we're going to This allows like external code to set up these vertices and the direction of the lighting from outside. No, we don't bottom it. We don't bottom it. It's good as is. I like to keep the code consistent, so we can copy the definition. Set lighting direction const x, y, z. That's cool. And this should set up this U32 6. It is. Does that make sense? 6. Let's count, because this is all manual. In my world, this is 1, or this is 0, 1, 2, 3, 4, 5, 6. Yeah, it's correct. And we have to store these in network order. It's just the way everything works. Maybe we can copy the thing from the normals, because why not? Store lighting direction. And it's not at 16 then. If the normal starts at 16, this is 16 plus 0. Then this is 17, 18, 19. This is 20, 21, 22, 23, 24. So we start at 24 here. It's a bit like, yeah, you're working with rough, like raw data here. It is what it is. It is what it is. Okay, so we can now set the lighting direction on render vertices. This should compile, so let's set this to counterparts here because it's the same file. Let's compile. We have to compile a few hundred files, so let's wait a moment. Ooh, drinking is hard as well. And again, I'm now... You're doing some additions in there? Yeah, this is offset, so this is pointer moth, sort of, or it's an index into the structure. So 24 plus 0 is just like, this is at 24 element, or like byte 24 of this array, and this is 24 plus 1, but it makes it simpler to see the base address. So I feel the code like this is a trick. The longer you are in the industry, the more tricks you learn. You could do this. You could do this, but it's like if you copy it, you can't, like, I just had to turn these 16s into 24s, and then the offset still works inside. Yeah, this is the way I do it. This is the way I do it, and I like it. I wouldn't have it any other way. Okay, so it compiles. Why not do the sum yourself? Because this way it's more instantly adaptable to other stuff.
Oh, no time to
So
wait.
it shouldn't work because we're not setting the value just yet, and we're not supplying it to the vertex shader, but it compiles and other things still do good. So that's pretty good, except things aren't as good as we think. So render engine, OpenGL. A few things have now switched around, right? So we need to tell a few parts that we're sending over another attribute array. So that's now 9 things. 1, 2, 3, 4. Yeah, it's 9 things, of course. Let's open up the render vertex for reference. So 9 things in total. Position is 0. So 1 thing, 2 things, 3 things, 4 things, 5 things, 6 things, 7, 8, 9. Okay, so this is 9 groups of properties that we're sending over. So we enable 9 groups of properties in the render engine. The compiler takes care of those probably, so it doesn't sum a million times. No, indeed, that gets flattened to constants. It's a bad thing to optimize, sort of. Alright, so the attributes themselves. Position hasn't changed, then here you get the same thing, Obi, by the way. Here you get the exact same thing. Position is unchanged, the color is unchanged. This is attribute 1 for parts. Texture coordinates are the same, the normals are the same. Lighting information, that's this one if I'm not mistaken, is the same. And then we get another set, like GLexec. Yeah, it's way more readable, I think. And the compiler takes care of like doing everything else. ADGLexec, that's a wrapper that calls an OpenGL call and does instant error checking on it. So if there's any OpenGL error, it will print it to the screen, program will just halt, and you will know what's wrong. So we have a new attribute at position 5, it says. And let's see, 0, it's actually 6. So 0, 1, 2, 3, 4, 5. It's actually correct. It consists of 3 elements. We're sending over bytes, because each of these components is a signed byte. So it's a byte. Do we want to normalize them? That's the thing. Do we want to normalize these? I think we'll normalize them ourselves, but let's. It's probably free. Let's normalize them. They're render vertex size apart, and they start at, it's a void pointer. Yeah, this is kind of like OpenGL syntax, and we start at what the previous one started at. It's 24. And then this one is attribute number 6, starting at 28. Then this is 7 starting at 32. And then this is 8, starting at 36. I think that's good. Let's compare, just to make sure. Okay, we enable one more attribute array. And we are changing number 5. That's now 3 elements, bytes, normalized at offset 24, which was what it was before. I think all of the groups are 4 bytes, give or take, because either we have 2 shorts or we have 4 bytes. So that's cool. So 7 doesn't change. That's, yeah, these are both texture coordinate sets, so these are actually equal. So yeah, I think this is good. Looks good. The render vertex has changed. We inserted 4 bytes here, we added 4 bytes to the size, and we added a set lighting direction call. We changed a few offsets for the later parts, so yeah, that looks good. And we are at 24 plus 0, I believe that's correct, because 7 times 4 is 28, so this is actually 1. Alright, looking good. Let's see if we run what it looks like. Here we are. I'm not sure if things are actually okay, because take a look at the shading of the builder. Take a look at the shading. It's actually something is amiss here.
Oh, no time to
I
waste.
think
Let's
some
go.
of the things are broken now. Like this shouldn't look. There's definitely something funky going on with the materials, but probably because we haven't told OpenGL that we have changed our data layout just yet. So we are actually supplying the right data. It's actually compiling, it's actually rendering and working. But what we now need to do is to make sure that, I think it's the render state manager, OpenGL, that this guy knows about all of our properties. So let's see. Yeah, here we go. We have the attributes here. So buffer position, sound familiar? They sound familiar. So we're going to insert another one here at position 5, lighting direction, because it was using the old indices. So let's call this one 8. There we go. And we add, and we make sure, okay, so we actually check these as well. So let's make sure that OpenGL and we are on the same page. Lighting direction. So we also pass in some uniforms and stuff, but that's not interesting. So we added our attributes like in the communication with the vertex shader as well. And now things should look good again. Yeah, so we definitely have our metallic buttons again. We have our builder looking good.
No time to waste. Let's go.
Okay, we don't look like a sea of stuff here. We actually... Is this a fluke? Because we're not setting the value of this lighting direction at all. And it is working at the moment. So what's up with that? How come this works? Anyone know? It is pretty sus. I'm very sussy of this because we didn't set up anything and it's actually working. But maybe it's... maybe the value is 0 or so. It's sussy. It's working, but it shouldn't work. So that's another nice thing to render vertex. Let's see. Let's open it up. How are we initializing this? We're not initializing it at all. Okay, so that's cool. Let's go to the render buffer class. So this is the class that converts model vertices into. Did you forget to replace vec No, I didn't. If we take a look at the generic vertex shader, the vertex lighting direction is being copied from the buffer lighting direction. Buffer lighting direction is coming from, let's see, buffer lighting direction is actually coming from outside. And in the fragment shader, so let's open up the PBR fragment shader, we actually say like light color from sources, and the direction is the vertex lighting. So I'm pretty sure it's actually set to 0, 0, 0, 0, 0, and that might look the same. So let's go into the render buffer here. This is the guy, the dude that, let me show the counterpart here. This actually is the class where you pass in model vertices. So you can say like, I want to add a quad consisting of model vertices. That's kind of like the glue between the engine and the rendering pipeline. And this one converts those model vertices to render vertices and kind of like tries to reuse them if possible. So what we're going to do is we're going to store the vertex color, we set the texture coordinate, normal, lighting. So here we are going to say render vertex. Here we're going to hard code it, set lighting direction 0, 0, and then int 8 max. So now we're going to set it up. It should look the same, and then we can start testing from the code. So instead of this being in the shader, it's now actually in the engine, which is where we want it. So okay, it looks similar, but I think it's got way more power to it. So I think previously it was set to 0, 0, 0. Let's check. It's not a normalized vector, so maybe OpenGL does something funky with this. It should actually say like, hey, can't divide by 0. What are you trying to do, Firefly?
Let's go.
It's gone. So we are actually passing this value. Somehow there was junk in there. Maybe if you use junk, it will just work still. Like if this is 1, 1, 1, it will get normalized to a different like vector.
Oh, no time to waste, let's go.
And you will actually see it. So maybe you always see something. But as you can see, it's smaller now. So it's actually coming in from a different angle, it thinks. Alright. Now, in the back of my mind, I'm thinking, is this going to work at all? Is this actually going to work? Because, as you can see, like any value we put in, sort of works. So, and when you look straight down, you can see it. So, is this going to work at all? Like how before we actually make this entire feature, how are we going to test if it's going to work eventually? Because I like doing stuff, but I also like preventing doing stuff that's not going to work anyway. It is reassuring though that if you put in like the vector from the top, that you actually see something, and it's actually a way bigger highlight. So this makes sense. What happens if you pass some other value than just straight down? Yeah, that's what I just did. I did the 1, 1, 1. So that's like from the top, from X positive, from Y positive. So that's, if you take a look at the map, from Y positive. Oh yeah, take a look at the map. Great idea, Firefly. You disable texturing so you don't actually see something. But coming in, this is from the north and from the east. So northeast, top northeast would be like the way light would come in. So if we take a look at the northeast. Okay, that's northeast. So the idea is that the light would then come from that side. So let's go with, let's maybe just denormalize this thing. Int 8 max, int 8 max, int 8. The idea being that the light now comes in from the northeast and the top at Hey, this is actually, it's working. See, the light is actually coming in. It's actually coming in from the northeast, from the left and to the back of us. See it? It's actually coming in from the northeast. So now everything is lit as if there's a sun to the northeast. So it is going to work. Of course, because this is exactly as changing the sun position. Remember, we used the sun position code. So we should see a reflection kind of like at this angle. Maybe I'm not sure if we can get the camera angle to be just correct. So maybe we need to place down a bit more golden stuff. We should be able to get the sun It's correct. It's actually working. And the entire system is going to work. It's going to work. Don't worry about it. But now I don't see it anymore. Oh, also we need to be close to the lamp. So we need to be close to the lamp and it needs to be at the northeast. This is impossible. Does anyone see a highlight? I don't see it. Like, it is actually straight up along this diagonal, and it's also 45 degrees inside of the air, and we need to be near the lamp, and we need to hope that this is actually the gold material. So this is debugging using blocks. This is my life now. But hey, it's science, right? It's science. Oh, oops, wrong menu. Like, I think we should see something in that corner, but anyway, so we're kind of like faking a sun here, and it only affects where there's a lamp, so that's also, you can't see it everywhere, it's only where a lamp is present. But when a lamp is present, you can see like the northeast corner, so exactly as foretold. The northeast corner is lit, and the southwest corner is not lit. So it does have its directionality tied to it now. I'm not sure like why we're not seeing it here. Maybe we should, like, this is debugging with blocks. It should work. We should be able to see something pop up at least. Closer to the lamp. So exactly in that corner at 45 degrees angle. But hey, why are these blocks, they aren't shaded anyway at all? See, it's as if there's actually no light coming into these at all. What's up with that? If I place this block, see? It gets lit everywhere. Maybe we're looking at it from the wrong angle. Maybe this is the way to go, stacking them higher and higher. You would expect something to reflect in here, but I'm not seeing anything. It is a golden grade block, so it is a golden material that we're using here. Maybe use patina. Patina is a bit more glossy. Or maybe we just broke something with the metallics, that's also a possibility. Where's the light? Tell me, I don't see the light. Meanwhile the sun is just going everywhere. I have no idea. I have no idea why we're not seeing anything. Should we debug this first? I feel... Hey! These have it. See? The clumps have it. But that's more of a... No, that's a reflection, I think. I feel. Is that just a sun reflection? I'm making a new wonder. Yeah, this is a very wonderful build in the game. Anyway. Okay, so clumps show something. Let's see. Let's then do the clumps.
Oh, no time to waste.
The clumps should now have their lighting come up from the top, straight from the top. Yeah, that works. See? And we also have this gloss thing back on the block itself. So why does it not work if we use it like different values for this? Maybe make it not as angled. Let's see.
Oh, no time to waste. Let's go.
Here, there you go. Now you can clearly see it's over there, right? So my theory is this is going to work because the light is coming in from that direction. That will always be the case, like for this lamp. This is almost as perfect of a replica as you can get, right? So check out this block right here, this one, this. Check out that block, seriously. So Supposedly, let's like the alignment isn't perfect, but suppose this is it's about working, like it's going to work. The theory holds. We can go on constructing things. Don't mind me, I'm just removing some blocks here. Anyway, back to the program. Okay, so we actually set the lighting direction, and we do this in the render buffer now. But now we're going to copy this from the model vertex. So instead of hard coding it in the render vertex, we're going to pass it. Yeah, I'm not sure why 111 doesn't work. It should work, and I think the thing like this should definitely work. Maybe the sun is too high. Maybe we can't see it because it's too high. But the clumps show it. The clumps show it. But the sun is very faint, so maybe it's not normalized. We should look up the documentation then. Let's open up render engine OpenGL. Render engine OpenGL. We use GL attrib pointer, something like that. GL vertex attrib pointer. Here we go. So maybe it says like, is the data already normalized, instead of like, do you want to normalize it? Right, so it says, is it normalized or not? And we're passing in true, saying like it's normalized, but we don't normalize it. Yeah, I want this converted, so it's the wrong way around. I told the thing I wanted it to be normalized, but it's like now it's going to work. It's going to work immediately. So it's a good bug fix because we had to fix this eventually. See, now the lighting is identical. It's 111, but the lighting is now actually working. But let's see if we can get the reflection going. Like on the clumps it should work at least. So see, and the light is actually intense again. So it's a good bug fix. It's a good bug fix because we were setting this to not normalize, but we want it to be normalized. It's just the other way around. So let's close it. There we go. So thank you, Obi. Pair programming is always the best. Next up, we're going to do the model vertex. So let me show you what the class definition looks like. The model vertex is kind of like the same as the render vertex, but instead of being a gigantic struct of bytes that are addressed in different ways, it actually has human readable properties. So as you can see, this actually defines a material pointer, and it has a position. It's got like proper color factors. It also has like artificial light factors. So instead of like a vector of x, y, z, w with lighting information, this actually has human named things. And this is where we want to add our lighting direction as well. And that's going to be similar to the normal that we have here. So I kind of want to try and pack this sort of tightly. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, there's no way this is going to align nicely. So maybe we just like, do we just cram it in there? Or do we keep it near the lighting information? I think I'm just going to cram the big stuff in here. It's going to be a decimal byte 3. This is a normalized vector with just bytes as their components. And we're going to call it lighting direction. Looks good, sounds good. Now we just have to get the C++ file and make sure that we set this. So these are all initializers. Here we have reset properties. We don't have to reset the vector because the vector is already 0 initializing, if I'm not mistaken. But let's check. I think this has a default constructor. So let's see, decimal byte. It's a vector 3 and vector initializes by default to 0. So that's good. And let's see, the only thing that we do have to do here is model vertex CPP. Oh. Here we go. We have this huge comparison operator and we have to add like a term here. So this is not going to look pretty. And if anyone knows a better way to do this, let me know. but it's the way it is currently. So this compares like all of the data in the struct, so we can sort it and use it in maps, for instance. It's not pretty. It works. It works though. It should compile like this. And we also check if they're equal in the same way. So let's add the lighting direction here as well. Like comparing render vertices is way more efficient because you can do a mem compare, mem comp. Okay, like it says compare model vertices ignoring any assigned indices. We compare vector 3's loss to try and speed this up a bit. It's a lie because the vector 3's are actually here right in front. So this comment should probably go sometime. We have to recompile the entire program because, or at least very large portions of the program. It's not insane. It's just like comparing every single data point in the model vertex. It's the way that I do it currently, so don't worry about it. Alright, let's wait for a bit. And once we have this data in the model vertex, we can actually use the data from the model vertex in the render vertex. My poor computer. This is probably the last big recompile that we have to do because this is changing the fundamental data structures that are used everywhere. And once this builds, and we're already done. Alright, we're good. I mean, at least it's worst case scenario that it goes through every bit. Yeah, that's true. But like a mem compare would be so much more efficient. But yeah, this is just the way that it is at the moment. I can't really do much about it. But it's not a problem either. So similar code is running in the current version of the game, and it's like no one is complaining about performance that much. that much. Okay, so we're now passing it over from the model vertex. So let's say model vertex.lighting direction. And we probably want to, yeah, we need to use these individual components here. So we're going to pass the X, the Y, and the Z component. There you go. It compiles and it should run, but now the lighting should be gone, or it should be completely wacko because we have a zero vector. So as you can see, the lighting is now completely gone because there's a zero vector. It doesn't radiate anywhere. The light doesn't come from anywhere. It comes from within the light itself. So the light is now completely gone. You only see a bit of the diffuse reflection here, and that's not entirely what we were going for, or at least that's what we already have. So as you can see, no lighting information anywhere, and it's oh, you can see the effect of the lamp here on the builder pretty well. So that's coolio. Now to the hard part, or at least the interesting part. Now we need to set up these model vertex values, because if we open up model vertex, you can see if we actually reset properties, if we actually do hard code a value here. So let's say this, what does the definition look like? Model vertex HPP, material position normal, material position. Okay, so let's do it below. It's just a hack here, but don't worry about it. So let's say lighting direction is a decimal byte 300 int 8 max. There you go. So we now get the lighting back if all goes well.
Oh, no time to waste, let's go.
There you go. So it's way more pronounced. So we did actually fix that bug that we saw earlier where light is coming in from the top. So you can now actually see that it is now different because we have this huge spotlight or whatever. But hey, see, it is not changing depending on the view angle. So this is something that we have to fix. This is something that we need to tweak in the fragment shader. So this is actually a very good test. Why is this different? Why is this different? If we hard code it in render vertex, what is happening? What is happening? See, because the light is much brighter now, you can definitely see a huge difference compared to what we had before. And you would expect these lights, or at least the reflection, to move based on our eye position. So if this is what it's going to look like previously it moves with our eye position, right? If we look down, it moves with our eye position because the light would be reflecting straight up into our eyes. But now it's fixed. There's something weird going on. So what are the differences that we have in this file? Let's see. Why does it work if we render buffer? So why does it work if we set it to a fixed value here, but why does it not work when we copy it from the vector that we already have? Because if I make this 0, 0, int 8 max, we should get the other behavior, but that was before normalization.
Oh, no time to
so
waste. Let's go.
a lot of things have changed. What is it doing? What's happening? Someone tell me. Are we check one more time. Because now this looks pretty sus. If we put in a normalized vector, I'm pretty sure it looks okay.
Oh, no time to waste. Let's go.
Yeah. See this? Put in a normalized vector, it works. Put in a normalized vector and it gets completely blown out. Or does it? Or does it? This is what we want it to look like. Let's see one more time. GL vertex at trip pointer. What is that? Not first, not the second, third, but the fourth argument about normalization. Normalized. For GL vertex at trip pointer specifies whether fixed point data values should be normalized or converted directly as fixed point values when they are accessed. Yeah, I think we do want the normalization. I think it was correct the first time, but there was another bug, probably, most likely. Either way, this should still look good. No, this should not look good.
Oh, no
the light should be very faint now. Yeah, the light is very faint. Because we're actually putting in a 0, 0, 1, so now we scale it back to int 8 max. Normalization in OpenGL is independent of normalization in our engine. Yeah, here's what's up. I figured it out. Here's what's up. We pass in a GL byte. So we pass in a GL byte to OpenGL. What this means, this normalization pass is not based on the normalization of the entire vector. So that's not based on all three elements. This is based on normalization of the individual values. So if you pass in a byte, can range from minus 127 to plus 128, give or take. Yeah, so here's what happened. So if you say I want it normalized, this will convert values from like minus 127 to plus 128. It will convert that entire range to minus 1 to plus 1. That's what this means. Do you want this conversion to minus 1 to plus 1? We want that. If you pass in 127 otherwise, you get 127, which is a huge value. That's not like a directional vector magnitude that you want to have. So we want to have this as floating point values ranging from minus 1 to plus 1. The normalization itself, though, that we have to do in the engine, so if you pass in this 0, 0, 1, this 1 becomes a very small floating point value because it's only 1 out of 128 sort of, and because OpenGL doesn't do or does do normalization now. So if you pass in 1 without normalization, it becomes 1 because it's actually the floating point value 1. If you pass in 2, it becomes 2, but that's larger than 1, so it's not a normalized vector anymore. It's pretty complex, but if you pass in 128 or 27 or whatever int 8 max is exactly, you get this huge value for that vector, and it does normalize it. If you don't normalize it, it becomes 127 instead of 1. So what we want to do is make sure that our vector is at least normalized. So that's what's wrong. So we pass in the straight data from the model vertex, but we make sure that the model vertex itself, where we reset this thing, this is decimal by 3 normalize. So that's what we want to do. We want to get this thing normalized. If I'm not mistaken.
No time to waste, let's go.
Right, is this what we want? What does normalize do? It calculates the magnitude, then it divides everything. No, that's not what we want. We want, it's going to be more complicated. Decimal by 3 normal, this is from decimal. There is a convenience method that I made for this, for having an always normalized thing. Let's see. What is it called? Decimal byte? Normalized factor from. There we go. Normalized factor from, and then we use a decimal 3 for that. And then we don't normalize it. There we go. So this is a bit of a custom data type in this engine. You shouldn't make a decimal by 3 yourself. You should always make a normalized factor from a full-sized factor. So this is going to work.
Oh, no time to waste, let's go.
Now it's Gucci, check it out. Now we have the actual correct light. We have a way of getting it into the engine or like into the render buffers. It's coming from the top, it's not blown out. It's normalized in OpenGL and it's normalized in our engine. So we need to make sure that we set lighting direction in the engine, in the model vertex, to a normalized factor from a bigger factor. This is actually the way we're going to do it, so it's not a problem. This is actually what we want to do. But it was just a bit of an artifact. I was constructing this myself, decimal by 3 from this, and that's not going to work. Now we're happy. Now we found the loot and we're happy. Okay, so we're going to remove it. The lighting will be gone now, so there will be no artificial light coming in from any direction. See this? Okay, that's cool. One thing that we can check is make sure that if we choose this, the southeast horizon thing again, that it actually comes in from the southeast, that the coordinate systems are identical, and indeed lighting is now coming in from the southeast like that. But check out like what artificial lighting can do. This is directional artificial lighting and localized, so check it out what it could look like. Just the way that it kind of like spreads the light. So you don't get it on this opposite side of the grass blades, and it just adds so much more flavor to the lighting in the world. If you were to enable the sun, you would have like 2 light sources simultaneously, and that's exactly what we're shooting for. So let's not set this up. So it's going to be the responsibility of the rest of the engine to fill in the lighting direction. So we have many parts working already. It's really sad that I threw away the diagram. So what we now have to do is to make sure that the geometry mesher, so the part of the engine that creates the geometry for the entire game world and makes the client chunks and renders the client chunks, we have to make sure that that has access to lighting directional information. And that's going to be a pretty complex topic, I think. We have to store that somewhere. So for every bit of lighting information that we have to store where the light is coming from eventually. So let's open up the client chunk. Like I said, this stores all kinds of things about client chunks. So these are portions of the game world that are to be rendered. They also contain render buffers. I think, yeah, they have render buffers for some like active geometry and for some visible stuff. That's all cool, and we're going to have to expand these. We have lighting information stored here somewhere. Yeah, we have light values and we have light data. So we have a data hole and we have data itself. How many times does it store lighting info per block? So there's, for every type of light source, there's lighting information. So as you can see, we have light source none and count. It's an enumeration, light sources. We have artificial light, infrared, which is the red light, ultraviolet, which is the pink light, and there's 3 light sources. So it stores 3 sets of data, or at least the hull. The hull is light coming in from other chunks, so from neighboring chunks. So we'll probably have to go and make another hull containing the direction from other chunks, light coming in from other chunks. And we have a light data struct here. And light data is a byte, apparently, that contains the actual light values. So we have a bit that says is shadow calculated, a bit that says is it shadowed, and then 2 bits per channel. Yeah, 2 bits per channel, so that's 4 values, 4 possible values per light in intensity. Okay, and the light values that come in from other chunks, those are actual bytes, so that those have a bit more resolution, because this gets used to calculate this, so this is more higher resolution or higher fidelity than this. So sort of what we want, and bear with me, this is going to be a little bit opaque because you have no idea what I'm talking about and no idea what I'm doing. Yeah, this is why there are no different light colors at the moment. But I could never really tell or never show you why, but this is why there's different light colors. Like they are. Wait, one moment. Sorry. So we kind of want to track where light is coming from, and that's a cool idea. But we're going to have to track that either in light data or in light values, or in both actually. Yeah, this is the way the game is programmed. So at first we only had artificial light, 1 source, and now there's 3 sources, which is a bit more already, but let's see. So basically what we want, and we don't have to optimize it right now. We can add another data hull containing cell coordinates, 3D cell coordinates, and it would be called light source, light positions. Okay, shall we call it light positions? And we'll do 1 per light source, because why not? So that's the hull. So maybe we should separate these. That's the hull. And then internally we should also store where light is coming from. And that's just like this. That's client chunk 3D data. And we store cell coordinates as well. Light data positions. Sure, it makes sense. Like maybe we should call these light hull positions and light hull values. Since now we're going to expand this, I think it would make more sense like that. Light hull positions, light hull values, light data positions. That's cool, but let's try to get some symmetry in here. So light hull values, light hull positions. That's not alphabetically, it should be like this. Okay, so let's not spend too much time on that. I think client chunk 3D data gets initialized automatically. Yeah, it calls clear and it just it mem sets everything, all the things. Okay. That's cool. No, we're not going to spend some time here. This is exactly what we want, but this is the mechanism we are going to use. This is the mechanism we're going to use for, like, because once we know the positions of the light where it's coming from, we know the position where we're rendering from, and we can calculate the vector. So what alphabetical variable, or it sometimes makes sense, but like then data should be above hull. But you get what I'm saying. Know what I'm saying? Yeah, it doesn't make sense to have it alphabetically. So we have light hull values, we have light hull positions, we have light data, and we have light data positions. And it's actually not positions, it's coordinates. Light data coordinates. So it's more like source coordinates, light hull source coordinate. But this is what we're going to be working with. Let's see if I didn't mess up the formatting here. But so far we have a very small diff, so it doesn't do anything yet, but it's a very small diff. But if it's going to work eventually, it's going to be amazing. It's going to be awesome. It shouldn't compile anymore. We're probably going to get some errors because we renamed these variables. And let's just update our code where we see it. No member named light values in client chunk. So get light values, return the desired light values, this light values, light source. Okay, so this is the hull. But what is a hull? Is it just a 2D data X? Okay, this is actually a hull. I agree, this is a hull. Light hull values. Maybe we'll find some more bugs in here. We're just digging deep. We're trying to get it to compile first. It's not going to compile. It can't compile. The fact that it compiles means that we use light hull values only in one location. And we had to rename it there. Okay, light hull coordinates, we're not using this just yet. We didn't rename this. And this is cool. Okay, so it compiles. It's all good. It should run. It should run. No problems.
Oh, no
it
time
runs,
to waste.
no
Let's
problems. Okay, so we're Gucci. Once more. Or still. Which kind of makes me wonder if we should actually rename this one. But it is the whole, so I can live with this. And where are we using get light values? Let's do a search for this. If we have a chunk, return light value for the requested coordinate. If we don't have a chunk, in chunk coordinate to include get light values, light source, get in chunk coordinate, okay. Client cell data provider lookup, okay, that's cool. And this is the actual light renderer. Store light data for chunk hole along X sides, Y sides, Z sides, okay. I'm not sure about this one. I'm not sure about this one. But it's cool. We're focusing. We added the hull. And we are now also, let's open up the light value tracker. Okay, that's cool. The light value tracker. This thing is something. This thing updates cell contents based on the new light value, as you can see. One short moment here. Yeah, we're back. Okay, so this thing updates light values for coordinates. So if you, this is probably only called in one location, 2 locations. Okay, so we render chunk light value render. We render light value, let's see, render light values, render, okay, so these are delegated. We only use this in 2 places. So propagate light if possible, and this is about propagating light for a single light source. That's cool. And this is setting up light origins. Okay, so that's all cool. So this is exactly what we want. The light value tracker thing that we just had is exactly the place where we want to patch this. Let me open it up. Oh yeah, there we go. So this is exactly what we want. And if we remove the header definition here, so we never darken light. So we request the old light value in the light values for the in chunk coordinate. That's exactly logical. That's entirely cool. If the new light value is smaller or equal to the old light value, we stop. That makes sense, right? This is very simple. So if we have 2 lights of equal brightness, this OBS is kind of like what you said, like what if there's 2 equidistant lights, if they have the same distance to the cell or to the vertex, then we just have like one of them. The one that is earlier, the one that is propagated earlier is the one that gets precedence. We insert a coordinate for the new light value. Okay, so in chunk coordinate, the new light value, push back in. Okay, so this is actually the brightest. We track it by light level here. That's what I was wondering about. So maybe a comment here would be nice, but we check all light levels. We have a huge vector by light level and all inch coordinates that are at that light level. So we take the brightest level and then we spread that light out over the chunk. Then we take the second brightest level and spread that out over. So that way the brightest lights propagate over the most dark lights. It's logical. I haven't touched this code in years. So because this is very old code and this has been working perfectly fine for since close to forever. But this is exactly what we want to do. So the old light value, we get that one. And if it's brighter than the new light value, we return. We insert the coordinate for the new light value and we update the light value. That's super cool, except we now have to track that light origin from here. So instead of just having this, we also want to okay, we have light values, which is a pointer into our client chunk 3D data. That's cool. That's entirely cool, but we have to expand this. We also have to track the origins here. So not only it's a client chunk 3D data uint8 pointer. Client chunk. Here we go. I need to do a bit of back and forth to see what we actually want to store there. So we have this kind of structure with uint8ts. And I think it's something custom to the light value tracker mechanism. So where do we construct these? In the value renderer. Okay, so we make a new one and we do it based on the light values. And that's actually light values array light source. Okay, I can dig it. It's getting a bit more complicated. This is Xcode, yeah. It's what I develop on macOS, and Xcode is like my go-to thing. It works well for me. It says, yeah, so about Xcode. It's actually Xcode. Maybe I can do the super duper zoom thing. Let's see if this works. Xcode. Can you see this? Xcode. I'm not sure if it messes up the entire screen. But it works fine for me. It's not the most advanced or schmancy IDE, but it's perfectly serviceable. Especially for C++. Or Objective-C. Right, okay, so let's stay focused. Render all the light values for a chunk. That's cool. We get a light values array. And the light values array comes from... Where does this get called? Chunk rendering thread, okay. Light values array. Where do we get it from? We just make one. Okay, that's simple. We just make one. So we also can make one for the... We can actually tie it to the chunk. One moment. We can actually tie it to the chunk directly. But supposedly a chunk can change contents, so we cannot reuse, we might not want to reuse existing data. Or do we? Because if you remove a light, you do not want to like retain the light position at that, like the light direction at that position. That's not what you want. So we should clear those when we re-render a chunk. See you everyone. It's a bit of a different live stream than you're used to, but hey, we make the most of it. How are we going to do this in a smart fashion? Let's start with the basics. We render light values. And we render them per light source. That's all well and good. We track in-chunk coordinates per light value. That's cool. That's exactly what we want. We want this light value tracker, but we want the light value tracker to also keep in mind the source position of the lights. So instead of just having light values like this, we want like at the same In the same fashion, we want to have client chunk 3D data, cell coordinate 3D, light coordinates. And this one says tie it to the light values array. But I'm not seeing that one. Why does it need to be at a higher level? What do we do with the light values? We render light values. Oh, and then we render the light data from that. Okay, which is basically probably copying stuff. Yeah, we just copy it into the chunk. Okay, we can do that. We can do that later on. So I'm not sure if we actually need that over here. We do want to have it per light, so let's just copy it. Client chunk data 3D data, cell coordinate 3D, light coordinate array, and then per light as well. Boom, like that, don't worry. So instead of just tracking the light intensity, we're just copying the exact same mechanism and we're copying it to the coordinates. And the coordinates mean the source of the light, where it's actually coming from. So we're going to provide that, like we have the light values array and we also pass in the light coordinates array. There we go. Then light value renderer. Render light values. That's exactly what we want to change. So instead of just taking the light values, we also say, whoop, you can take a cell coordinate 3D light coordinates array, like this. And that probably takes care of the compilation error here. Let's see, go back to the chunk rendering thread. Let's just open it manually, chunk rendering thread. Right, that works. Yeah, we're storing the source of the lightest light that we can find, or we store the source of the lightest light that's shining on us. And once we start rendering, then we calculate the direction from the actual vertex, so not the cell, but the vertex to the center of the coordinate where the light is coming from. So it's kind of like a two-stage approach. We indeed do it chunk light value renderer, one moment. So yeah, I want to track like the source where the light is coming from. The light is the brightest light that we receive in a cell. So here we go, the definition of this has changed, which is cool. And then we pass it to the render light values thing, because this will actually store it there. Not the closest light, but the brightest closest is kind of like the same thing. It's the same thing. Now the real problem now becomes, or will become, like, which should we flatten this immediately? Does it matter which kind of light source brings the light? Because I don't want to do it per channel, so we can only have one closest light, and we have 3 types of light sources. I can imagine in real life that a yellow light that's a bit farther away makes more impact than a closer red light. And those pink lights are very bright. So maybe there's some kind of like heuristic we should apply there. And maybe we should not, like what I'm about to do right now is, should we just always give artificial precedence and then red and then ultraviolet light, sort of, depending on their brightness. So you can see artificial fades a bit faster than infrared and ultraviolet. So I think it makes sense that if we have artificial light close by, that we give that precedence. And we only have to track, like I'm now passing in an array of arrays, but that's not actually necessary. We can stick like with one light coordinates array, so we can stick with that. Maybe do the equal for all first to make it work, then add that. Yeah, I think we can stick with one set of coordinates. We don't have to have like the brightest light artificial, the brightest light red, and the brightest light pink. We could do that, of course. We could totally do that, but then you have to calculate 3 lights in the fragment shader. I think just mixing the light and then assigning it to the closest light that we have, or the brightest light. Yeah, that's it. We're talking about brightest light, right? So it makes sense to have the brightest light, and the brightest light is eventually the one that's close by with the highest light value. I think it makes sense to have just like one coordinate that we track throughout. So let's move it up here. So light coordinates array, and we change the type. So we pass in just a single client chunk data light. So let's maybe make this a reference, because we want it and we'll always have it like this. And then we just pass the same thing around. We just track one brightest lamp light coordinate, regardless of which light we're calculating. Yeah, we can tweak the aesthetics. We can tweak those as well. So we're not stuck with anything. Let's first try to get something working. Let's call it light coordinates, because we don't have any more, or we don't have an array of them. So we pass those in like as a single thing. So each of the lights can just check like, hey, if I'm brighter, yeah, that's a nice idea, Firefly. But we check the light channels independently, and then we assign light coordinates. We have no idea what the brightness of this light was. Why'd you have to go and make things so complicated? We are going to pass in an array. It's what we want, and then we'll flatten it. Don't worry about it. We'll flatten it in the end. I think we can do it. We eventually check if any of these are brighter. Let's keep things simple. So let's move this back to an array. Light coordinates array, it's good. That's what we pass in. And then we just pass in light coordinates array. No. It will take care of that for us. So we are actually calculating the coordinates of each of the individual lights. Yeah, that's what we now can do, Obi. We can see like which light is the brightest, what type is it, and what do we want to do with that. This should compile. Okay, we're compiling. So we created data storage in the chunk rendering thread, which is kind of like the overarching thing. Once it starts like creating the geometry for a chunk, we now can track per lighting type. So per lighting type, which is artificial, red, violet, and none is nothing, of course. So per one of the 3 lights, we track the coordinate of the brightest light at a certain position. At least we have data storage for that now. So we pass it into render light values here. Then we need to make sure that we get the correct entry here, which is client chunk data 3D, cell coordinate 3D. Let's make it a pointer light coordinates, and that is the light coordinates array light source. Light source. And it doesn't like this because it's an array of pointers. No, it's not an array of pointers. We want the address of this, or we can reference it like this. Make it a reference. That's cool. Okay, now we end up with this problem. This is what we created earlier, but that's not what we want anymore, so that can go. So we now have this light coordinates map. It's entirely blank when we start rendering the chunk. That's good. And we want to use it in setup light origins, because the light origins should set like every It's not baked into some brightness value. You need to check the, yeah, it's going to work. It's going to work. It's going to be pretty cool. Set up light origins. We have a light source, cell data provider, client chunk, light value tracker, light fade. How does this know the light values? We're not passing in the light values. Oh, it's passed in the constructor of light value tracker. Okay, so then we do the same thing. We change the light value tracker. We can do this. Oop. And we're going to supply you with not only light values, but we also have a client chunk 3D data, cell coordinate 3D, reference, light coordinates. There we go. That's going to be in the constructor, and then we also have like a reference to that here. So cell coordinate 3D, reference light coordinates, and let's separate these now. And we can't actually assign it because it's a reference, so we'll have to use a light coordinates initializer list like this. Okay. Okay. And then we initialize it, the light value with the light coordinates. There we go. It compiles. Okay, so far so good. Trying to understand how the lighting works. Yeah, all will be revealed. So what we're now going to do is we tracked the brightest light value of every cell in a chunk, and we do a flood fill to kind of like propagate the light. And now we have created storage to not only store the light value, but also the source of the light. So the original source, the original like cell coordinate in the game world where the light is coming from. And this is going to be handy to determine, like, for every other cell, where is my light actually coming from, which direction. So the light value tracker takes care of that. As we saw, it has an update lighting at a certain position. We set up the light origins. That sounds like a very nice thing where we want to initially set the position of our light. We calculate the base chunk cell coordinate. I think we can make the code a bit bigger here. Artificial light originates from all cells that are its light sources. Yeah, this kind of like holds for everything. And we do this per light value, per light source. Yeah, that's good. So that's light source means artificial, red or violet. Short circuit if we don't know what cell is there. Non-solid photon blocks don't give off light. That's true. Add maximum light value if we're a light source. Yeah, so here we go. Light value tracker update in chunk coordinate uint 8 max. That's cool. We have this in chunk coordinate. And I actually want it to be a full coordinate. So we have to go back and add the base into that. So we're going to change light value tracker. This update method, we're going to include not only the new light value, but also a cell coordinate 3D, new light source coordinate. And it's kind of like source coordinate. This is. Now what I want to do, because we're updating this, I like to use const a lot. So let's const these up so we can't actually change them from within the feature. Const means that this value is fixed, can't change. So we never darken light, that's good. And if we would darken light, we don't have to update the light origin, sort of. Shall we call it origins? New light origin. That's a pretty good term, I think. So let's call these, instead of light coordinates, let's call it light origins. It's a way better name. Light origins, there you go. And let's also do that in all of the other pieces. Light origins array. There are two hard problems in computer science: caching and naming things. And we're actually seeing one of them in action here. So light origins. light origins. It's light origins array. And it makes sense because you already see that it's a coordinate because it's called cell coordinate 3D. So light origins. What's that emoji? What is it? A mouse? I have no idea what it is. It's not a mouse, I think. Okay, light origins. There we go. Light origins. That's entirely what we want. And we might even want to rename them in the client chunk as well. Light hull values, light hull origins. There we go. And light data origins. We could even call this light origins like this. So we have hull origins and but let's call it light data origins. I can live with that for now. Let's build this already because there's a few things that need to be rebuilt. No. Light value tracker. Here we are again. Okay, so once we read once we reach this part of the code, we know that we have a newer and lighter. Yeah. Okay, we need to update some calls. That's entirely cool. That's coming in a few seconds. So we filter out light that is darker than what we already have. But if light is lighter than what we have, we push that coordinate to our light value tracker. And that's cool, but that's not all that we want to do. What we want to do too is we not only want to update our light values, but we also want to update our light origins. So we set, and here we run into the problem that we are storing in chunk coordinates, and that's not what we want. We actually want the base coordinate here. So if we massage this, so that is actually, let me use the fancy rename tool. Oh, yeah, that's not the fancy rename tool. I have no idea what I just started. That's not it's command control E. Yeah, command control E. So let's turn this into a chunk coordinate, and then we make a const cell coordinate 3D in chunk. Yeah, so let's not do this. Let's rename it like this. Const cell coordinate 3D in chunk coordinate. And it's not a chunk coordinate, it's a cell coordinate. It's just this coordinate, like this. And we do that like cell coordinate 3D to in chunk, to in client chunk. Yeah, that's exactly what I wanted. I don't want it in. Yeah, multiple cursors are very nice to have. Okay, why is this not working? Is it a method on the thing? Is this how it works? Sure, I can live with this. So we have an intro coordinate, and then in the light origins we said it is an in-chunk coordinate that we want to set, and we want to set it to the actual coordinate value. No. What am I thinking? I'm doing this wrong. Revert. The light origins, we set the in-chunk coordinate to the new light coordinate. And new light coordinate is actually renamed falsely. It's new light origin now. New light origin. Okay, that's good. And then insert coordinate for the new light value. That's cool. Yeah, delete everything. That's how you do it. Just delete everything, start over. Yeah, we don't build at the moment because we just changed this. Now I'm wondering, do we have to store one more thing? Because we are updating the light value and the light origin, but how do we get the origin here? We need to track the light origin, I think. because instead of getting like the in-chunk coordinates for a certain light level, we can always query the origin here, of course. Maybe we can make this work. Let's see. So if we're setting light origins, if we're initializing the light origins, we're setting the like inside of our data structure at the exact coordinate, we're setting it to a new light value with a new origin. So we initialize it with a 255, a full byte, and the exact cell location of itself. That's yeah, super chunk origins. This is exactly like that video game, you know? That's cool. This is entirely cool. Now we go back to the light value renderer. Yes. Chunk man. Origins. He's pretty chunky. And we go to the setup light origins. There's a lot of compilation errors here, but we're going to fix them, all of them. But we want setup light origins. Yeah, exactly. This is what we want. This is where we set up the initial values. So we know the origin of this. So we do cell coordinate 3D const the origin, that is the base x plus x, base y plus y, base z plus z. Because as you can see here, we are looping through like the size of a chunk, which is the world cells per chunk axis. That's actually 32 for players of the game who don't know this. So we're looping through from 0 to 31, and we have the base coordinate of our chunk in base. So we can just calculate base plus x, base x plus x, base y plus y, and base z plus z. And I'm a bit of a parentheses dude, so let's add these around it. So that's the origin, and we now pass in the origin, which is actually for like setting up the light origins. It was actually already called that, so that's pretty telling. So we set up the origin plus the maximal light value at each of the cells that has a light source. And we do the same. We do the same here. We mix in light from all of the chunk neighbors left. Okay. This is going to be a bit harder to get right, but with a bit of math we can get it right. I'm pretty sure that this call is correct. So this is entirely okay. We can live with this. We could stub out all of the other calls. So there's a lot of propagating light from other chunks and into the chunk, within the chunk. We could probably like do something with that, but we could already compile this and see what happens. I too often add a bunch of parentheses where they're not really needed. Yeah, I've found this code base is pretty massive, and I'm pretty allergic to not having parentheses, for instance, around these terms. It helps my brain relax. It says like, okay, once you've seen this closing parenthesis, you know, like this is closed, this is done, you can forget about this, and then you start this. And I feel if there's no parentheses like this, it just like jumbles together, and I get paranoid because I'm like, okay, which gets added to which and what gets multiplied by what? You can relate? Cool. If we get this right once, we get it right everywhere. See this? Base x minus 1. Okay, we have a neighbor coordinate. That's cool. Do we have a coordinate for ourselves? Yeah, okay, we have a coordinate for ourselves. So here we are. Here we're actually mixing in the light from other chunks. It eases the mind, yeah. I find it like the more you can relax while reading code, the better. We're updating the in-chunk coordinate with the propagated light value from our neighbor. And now we just need to know where the light came from our neighbor. So we get the propagated light value. All right, it already fades this out. I can see this. If we still have light left, then we update it. Okay, so and then we need to ask our neighbor where their light came from. And how are we going to ask our neighbor where their light came from? That's a good question, Firefly. The answer probably lies in get propagated light value. So that's probably like below this somewhere. Or not, don't worry about it, or not. We have a cell data provider. Okay, we get the neighbor coordinate and then we know what kind of cell it is. We know the light value because we have a cell data provider for getting the light value. Okay, so now what we want is to ask the same thing in chunk coordinate. That's cool. And now we want to have a const cell coordinate 3D light origin, and that's cell data provider get light origin light source neighbor coordinate. Make sense? Makes sense. The only thing I do not get is some of this math. Like there's base x plus x, y is just raw, but y is being incremented somewhere else, probably. What? Cell coordinate x, y is base dot. What? This doesn't make sense. Why is the type is a cell coordinate x and it's called y? Like I can dig it. I'm like completely on board with this, but just leave it be. Yeah, this is not what we're going to fix today. So let's find the first call towards this. Okay, we're doing it from the left. Okay, so this makes sense. X is base x, y is y, z is z. Okay, so that's probably something I need to change in the original. So make a note. Make a note. The data types in a chunk light value renderer. Let's write this down. Data types. Types chunk light value renderer. This doesn't make sense. We need to make a mental note of this. Yeah, past Frank made it work indeed, but it's it doesn't look good. It looks bad even. Okay, so we're going to try to get the light origin for this light source from our neighbor. Now the problem is that our neighbor, like, and then we're going to pass it into this. So as long as this compiles, this will compile. And in fact, this should probably, like, we can just copy this over everywhere. Because it doesn't matter where the light comes from which slice, we just want to have it. And this is code that's going to like query the hull. It's entirely good. Light origin. So see, this is all of the same stuff. We propagate light from our neighbor to the left, to the right, to the front, to the back, to the bottom, and to the top. It's what we do. So now we need to create cell data provider get light origin. And I think this is going to like access that hull property, and then that's going to be condensed. That's going to be condensed for like every light value, but is that a problem? It's still the brightest light, and it's still the origin of a light, and it's what we're going to use internally anyway in the end. So I don't think that's going to be a problem. So now we need to open up the cell data provider. Cell data provider, because it needs to tell us what the light origin is. Counterparts. Get light values, get light data. Which one were we using? Get light values? Get light values, yes. Get light values there and there. And why are we using that? We have no idea. client cell data provider. Okay, so this is a virtual class. So we have a few implementations of this. Get light values. Light source, cell coordinate. That's cool. And now we kind of want the same thing in virtual cell coordinate 3D. Get light origin. And we might even leave out the light source because we're not going to store that. Or are we? What difference will it make if we track the origin of lower intensity lights? They will always fizzle out to higher intensity lights in the neighborhood. So I think we're good to just have a single light origin eventually. So you say like, I want to have the light origin, like the brightest light origin for this coordinate that you know of. Sounds good, right? With that virtual in place, this should all compile, but it doesn't because we dropped the light source part. So we can drop that, that's not a problem. Light origin, you just got the light origin, don't worry about it. Light origin, light origin. Okay. Why do we still have errors here? Too few function calls. Too few parameters. Obi, what do you mean? You are leaking stuff? Is there is there something wrong? Can you give a hint? Because like I can't really prevent showing stuff. And I thought everything is pretty good as is. Oh yeah, don't worry about it. Don't worry about it. It's all good. And then still, come on. Okay, so here we are propagating light if possible, and this is just because we have propagated light values and we want to yeah, nothing happened indeed. If we could fix this one, we could work on the light provider. So let's see if we can make this one work. This is where we are propagating the light within the chunk. So we can't ask external chunks. Right now we're asking external chunks for their for where the light is coming from. We can't do that here, but that's not a problem because light tracker knows, the light value tracker knows what we're doing. It knows. Loop through all the cells at this light level. That's cool. So we start with all of the light origins. Then we get the in-chunk coordinates. Okay, so we have the in-chunk coordinates of all of the actual light level things. Okay, that's cool. We loop through all of those in-chunk coordinates. First we check if it's darker than our existing value. This is kind of like what update already takes care of, but I can imagine that like sometimes this gets out of date or something. Can't hurt to check this twice. Existing light value, we get that, okay. But we should also be able to get the origin. Don't propagate light if it's too dark. Okay, if we actually end up with 0 light, we stop. That's also cool. And then we can just start propagating light if possible. To the left, to the top. Okay, so we keep this within the chunks. Okay, so we can say const cell coordinate 3D light origin is the origin of our own light. So that's light origins get in chunk coordinate. And that's what we spread out over the cells. This is exactly, this is it. We've got everything working now. We've got everything tied together. Here we go. Everything is working now. This compiles this file. We'll get some linking errors because we don't have an implementation for getting the light values. Yeah, so we should see, like, where is this? It's in the game world. Chunk, data providers, client data providers. Here we go. We have two of them, I think. We have a lookup and a cached one. So let's see if we can add the features in these files. Get light values, what did we call it? Not get light values, but get light origin. We're going to add it to the lookup. Get light values, cell coordinate 3D, get light origin, and we override it because it's a virtual. And then we implement it. And that's going to be a fun challenge. Client cell get light origin. So how do we do this? Obi, how do we do this? Or anyone else for that matter, how do we implement this? Okay, so this is the lookup provider, and let's just copy over what we do for the light values. We get the client chunk for this coordinate. That's a good starting point. Let's make this const instead, and this is const as well because we're not going to do anything with it. If we have a chunk, return. Okay, we can do this. We can do this. It's easier than you think. Get light origin, sure. If we have a chunk, return the light origin for the requested coordinate. So it's we convert it to in chunk coordinate. It's const, and then return chunk get light origin. Hey. Hey, oh. Is the bot gone? There was a bot again. That's the second part, Obi. That's the second part. Right now we need to like supply or make a client chunk supply data to the outside world. So let's add that there as well, because we have the data hull and stuff here, but we need some accessors for that. So let's say get highest blockers, get light values. Okay. So this is going to be a bit more involved because we didn't rename this one just yet. So this should be get light hull values. And let's make this const. And client chunk 3D data. Yeah, but this is going to be the cell coordinate 3D pointer. Why do we want pointers here? I have no idea. Get light data origins. Return this light data origins. Okay. And we also have the other hull thing, and that's the hull origins. And I'm not sure like how we're going to differentiate between those. We have a 3D data hull, cell coordinate 3D. it's pretty involved. Pointer, get light hull origins. And it's also not per light source, right? It is per light source. Not anymore. Because why would we want to have those separate? I don't think we want. Return the address of this light data hull origins. What? The final line? Oh yeah, that's it's entirely cool. Though I do want to get something to eat. I mean, a man's got to eat at times, right? A man has got to eat at times. We're going to have to rename a few things left and right. But I think it's a good idea because it's good to differentiate between when we're, like store light data. This is entirely cool, but we really want to make sure that we use hull where possible if we're dealing with a hull. Because this is just not going to work otherwise. Okay, get light origin. Get light origin in chunk coordinate. This should now work. There you go. Except we do have the chunk. We know that the coordinate is in the chunk, so we can get the light data origin. Get light... What? Get light data origins, get in chunk coordinate. Apparently we do not know this chunk, so what is then the light origin? We coordinate itself? Does that make sense? Yeah, I like to keep const what can be const. It has caught many a programming error already. So you can't change data that you shouldn't change. Especially in multi-threaded applications, it's pretty good to know what is being changed and what is not being changed. Okay, so if we don't know a light origin, the light is coming from the cell itself. Does it make sense, or is it like completely bonkers? I wouldn't know what a better way is. We could return an empty coordinate, of course. But then we need to make sure that the light origin is never empty. So light value tracker, we can assert here something. Assert false is new light origin is empty. Leave it like this. For now, I might do some touching up like after I'm streaming. Yeah, but I think it's good to const what you already const. So, okay, here we have the cache. The cached version of this is the same thing, except it uses a cache. Get light origin, this is what we want to add. Get light values. Oop. Just like that. Get light values, it's all cool. Cell coordinate 3D, client cell data provider local cache, get light origin, there and there, cool. It's an override, that's also cool. And we delegate this to a cell data provider. Then what do we cache? What is this caching? What is this doing? If it's just propagating this. Okay, so we cache highest blockers. We cache light data. Okay. Okay, I can dig it. but we don't cache light origin. And I can see why. So we just delegate this to the chunk, no problem. We don't have to do anything for this. We just delegate it to the cell data provider, get light origin coordinate. So fixed, solved. Except not. Client cell data provider says, I miss something. What do you miss? What are you missing, sir? Oh, we have no base definition. There we go. It's a pure virtual function. Didn't you know this? I knew this. So we should be compiling. The light value tracker should be working. It should trigger on those empty origins. So we should probably, we should let it run. We should fire it up and see if we run. And that means that we have the data available and that we can kind of like move to the second phase of this. Let's see what happens. Except it doesn't. Something is broken. We are triggering in. We are rendering a chunk. Default initializer. We are calling client chunk 3D data. Okay, that's cool. And we're calling cell coordinate 3D constructors. And we get a out of bounds. What? Because it's trying to clear internal storage. Okay, I can dig it. But at the same time it's trying to call the constructor on these cell coordinate 3D things. So then what? So then what do we do? Data. Element T data. Is this overflowing our stack maybe? Calculator. 32 by 32 by 32. And then each element has cell coordinate 3D. Each element has got, okay, so let's say that this gets down to 16 bytes. It's half a megabyte. And we make 3 of them. Yeah, okay, so maybe that's a bit much for like direct allocation. You're out of line? Yeah, it's all good, don't worry about it. Chunk rendering thread, let's, okay, then we need to make sure that we actually delete the stuff later on. But this apparently takes up, it does mean that we kind of like have to find a good way to do this, because it apparently takes up a lot of space. Pointer add, there we go. And now we need to initialize them, I think. So light origins array. 0 is new client chunk 3D data, cell coordinate 3D. This is a hack. This is a big hack, but what do you want? Let's see if we can compile and run at least. There you go. So instead of like doing a stack allocation, let's do it on the heap. Yeah, there we go. Now we can finally start it up.
No time to waste. Let's go.
We could even make them static, I think, because they're only used in that function over there. Okay, so we compile, we run. I'm not sure if we're leaking memory. I'm not entirely sure. I don't think we're leaking memory, but maybe we could possibly statically assign these and it would be all a Gucci. But we can at least now try to see light value tracker. So let's see. Are we going to do this like caveman style printf? Sure. Updated light at d to value d from origin d. Caveman. Let's see. So updated the light at in-chunk coordinate x, in-chunk coordinate y, in-chunk coordinate z to value new light value and new light origin x, new light origin y, new light origin z. How else do you debug? Indeed. So this is going to spam the log completely, but it's not a problem. Oh, look at that, it's working. Let's quit for a moment. So these are in-chunk coordinates, so these will never be like 32 or higher. And these are actually the in-world coordinates, and they look very reasonable. I think 4 is, if you say water level is 0, then I think we should check. The lanterns are probably 4 blocks high, so it's the 4th block in the lantern. 1, 2, 3, and then like this is level, let's see, there's water below these I think. So this is level 1, this is level 2, 3 and 4, so that's actually correct. And we also have some at level 7 as you can see. But the fact that we're updating multiple in-chunk coordinates with the same origin, as you can see, that's cool. And hopefully we'll see a few more different origins as well. Because if we have the same origin everywhere, that's not cool. That's not what we want. 669, 536. And you can see the value gets lower and lower. So this is actually the light from one lamp. Okay. From origin 0000. That's not exactly what we had in mind, did we? So we do assert that it's not empty, but it doesn't work because clear gets called on these. So we don't want them to be 0 either. So do we have a convenience method for that? Cell coordinate 3D, do we have is 0? We do have it for 2D. We don't have it for 3D, so let's add it for 3D as well. Of course, we'll eventually get a light at 000. I mean, don't worry about that, but it's empty. Cell coordinate 3D is 0. Then we can see like where 0 comes from. Check if all axes are empty. And 0 is this Z. Let's go back. So we don't want it to be empty and we don't want it to be 0. And empty will never trigger in this case, but maybe the code will be different in the future. So let's see where the 0 comes from. And cell coordinate gets used everywhere, so we have to recompile the entire program. Like I said, I want to get some lunch. I want to eat something. I've been streaming for about 4 hours now, or at least 3.5, give or take. So I kind of like, I'm not sure if I should make another episode, like start broadcasting again after lunch, or if I should just pause and add a timer to the screen and say like I'll be back in that amount of minutes. I think like if I have 20 minutes or so, or 30 minutes tops, I could go on. It might be nice to keep this contained in one video. Not sure if we're going to finish it today. It would be nice. It would be really cool if we could finish it today and like see it working, at least in the base, and then we could tweak and refine it and commit it in a future live stream. I'm kind of at the point where I'm like, yeah, I really want to make it work. Okay, we're propagating light from a neighbor. I kind of want to make it, get it to work, and I eventually want to eat dinner. Of course, I have to cook dinner as well, but till I finish, yeah. I thought I would be able to make this in like 3 hours or 4 hours, but it's taking a little bit longer because I probably did a long introduction this morning. But it's not a problem. Okay, so we're setting up light origins and we are propagating from the back. And apparently this cell data provider, get light origin, it doesn't know. We do have light, but oh sure, this is once we start re-rendering chunks. We are not storing the light origins just yet in the chunks. We are storing light values, but we're not storing the origins just yet. So let's fix this. Let's get it to compile. Let's get it to store the light origins, and then I'll probably like eat lunch. I think I will leave the stream just going. Like we'll have a bit of a lull in the action, and then I'll just be right back. Because I want to see it finished. I want to like wrap it up all the way from start to finish, sort of, at least in a semi-working state. So what are we going to do? Yeah, the be right back, and I'll try to add a timer to it as well. I think that's the best option. Okay, so here we are. Like we are very close to getting this stage working at least. We already did a lot of work. We already did a ton of work, even though we only touched 23 files. Okay, cool. But we're doing massive improvements left and right. Chunk rendering thread. So suppose this is all good. We actually delete this stuff, so that's cool. We changed render light values. We now pass in the light origins array, and the origins array is per light type. That's all entirely cool. So we are propagating the light. I think we are setting it up correctly because we actually saw a lot of cool stuff like swing by. And here we say store light data for the chunk hole along the x-axis. So I think what we are going to do here is we not only get the data hole for the light values, but we get the client chunk. Here's the point. I think here we are starting to like save light values. I think this is the point where we flatten everything. I believe. I think this is the point where we say, oh, we can't even. We even can't. Because we do have to do a merging pass. And we store the light data along the chunk axis. Okay, so we do low x and high x. Okay, I can dig it. With the hack you did, the hack thing you did, why did you initialize them again instead of just straight deleting them? Okay, so this is C++. So this used to be like this. So this assigns it on the stack. You have a stack and a heap in C++, and the stack is like the working area. It's pretty fast, and if you know the size of the data that you're going to use, you can just increase the stack and you have that memory reserved. The heap is a bit more involved. You have to do like memory allocation and stuff. But these arrays take up about 1.5 megabytes, and it's overflowing the stack, which is the name Stack Overflow, the website, you know. So instead of assigning them on the stack, I'm just assigning 3 pointers on the stack. So I'm saying like, okay, there are 3 pointers to data in the heap, and I want to keep those close, the pointers. But then I have to initialize each individual pointer. So I have to assign a new memory block to like the first array, the second array, and the third array. That's this. And because I'm doing like this heap allocation, I have to call new and I have to call delete on them. Instead of like if I remove this, and if it's a stack allocation, you can just remove this because it's immediately constructed and initialized on the stack, and you don't have to delete it because at the end of like this function, the stack gets rewound. So I make them. It's now an array of pointers, which only takes up like 3 times a pointer, which is most likely 64 bits on this computer. So that's 8 bytes, 24 bytes. That's a lot less than 1.5 megabytes. Just check out the stream again. Whoa, cool. Okay, so what we do have here is a client chunk 3D data hull cell coordinate 3D const chunk light origin. Welcome back, Fadi. Fadi, we're getting close to making it work entirely, but we have some ways to go. But we're getting close, we're getting close. So the easy thing to do would be to make this per light source, the chunk light origins, the hull. That's the easy thing to do. But is it what we want to do? It was not a dumb question. No, especially C++ and with like different kinds of allocations, it can make it a bit tricky to kind of like reason about. Okay, so this is a pointer. I can live with that. That's cool. But now we end up with this problem of, okay, we set the chunk light value. Okay, so we kind of overwrite this entire in chunk thing. The problem is we don't know yet. We don't know what everything is going to be. So we have to do this, except in a second pass. So storing light values in the hull, that's cool. And I'm pretty sure somewhere we're going to start saving the light data itself. In fact, that's in the... Maybe we can combine that. Yeah, render the light data. So yeah, we do need to store in the chunk hull. We need to pay close attention to that. Am I going to take lunch first? I think so. I think this is going to be a bit involved. We have to copy this, sort of, and we have to check light values. We have to check light values, and then also I think it makes sense to like stop for a while and then just do this in another. Yeah, lunchtime. I think stream has been going for quite a while now, so I need some brain juice. I need some more power. Oh, I didn't want to maximize that window. Don't worry about it. So let's see if we can get the timer going. How do we do this? Add video source, timer, text source. Timer, create new. I like it. How do you make a timer? I know you can do it. I know it's possible. Chat, read from chat. Cancel. Can anyone see the text? No. Remove the timer. Here we go. Scene, window capture, video capture. Is there an online thing that I can use? That I can abuse? Stream a web page, yeah. How do I do that? Good questions. These are all good questions. Here we go. So okay, I can dig it, but now how do we what's this +1? What does it do? Oh, okay, reset. It's the final countdown. Let's okay, let's start adding this. So add. Is it another display capture or window capture? Let's call this one timer capture. Oh, I have to crop this. Oh no. Oh no. Oh no, that's not what I want. I was gone for a while. How do... I'm still here. You can still hear me, right? Because I want to add it to this screen. Okay, okay, okay. It's pretty ghetto, but this good? Everyone happy? Everyone happy? I'll be right back. I don't have elevator music. I don't want to dabble into that just yet. But yeah, okay, so I'll leave the timer running. So I'm still here, but I'm going to eat lunch. And I will see you in about half an hour max. Hopefully we'll be able to like crunch everything and get it working. So see you there. I might be back earlier than that, but like give me half an hour tops. So see you then. Thanks for watching so far, and see you after the break. And we're back, sort of. Here we go. Let's stop the timer. Hope everyone had a good break. We had some spam. This can happen. Don't worry about it. It's all live. It's all good. But so where were we? We tested a lot of things earlier in the stream. We are at the point where we're trying to store light origin data so that we can eventually deduce where light is coming from. And I just had a few moments while having lunch thinking about, is this going to work? And I think it's going to work beautifully. Obi asked, like, how will it work? So we are in this PBR renderer, in this game engine, and we're going to try and store the direction towards the nearest light, like the most intense light, the nearest light for every vertex. And will it look like every light is giving off light? Maybe, maybe not. We're going to have to see and wait what it looks like in real life, but we'll hopefully know in a few hours, maybe even earlier. Will it work, like, from a technical standpoint? And I think so, yes, I think it will work. There will be, like, vertex data interpolation going on. So if there are two lights opposite of a box, for instance, and lights are shining on it with equal intensity, I think due to the interpolation you will actually get sort of an effect where, like, one light seems to be on the right side and one on the left side, and, like, in between will be an area where light is not, like, coming from a specific direction. I have no idea. I think it's going to work. I think it will look pretty convincing. So far the things we've seen are looking good still, but, like, there's an entire possibility that this entire stream is for nothing, but like, maybe we'll have something to salvage. So let's try to work towards completion of this, like, initial goal of storing directional information and rendering using that, and then we can decide where we want to take it next. So maybe it will look good right from the start, maybe it will not look good right from the start. I have no idea, but we will only know once we see it. Like, there's a lot of things that can go right, and it will work flawlessly. I like that. Okay, we're going to work with that theory for now. So here we go. Where were we? So we noticed we were triggering a assertion in the light value. Let me just open it up directly. Light value tracker. We said, like, okay, let's remove the debug statement. We don't need it anymore. So we don't want to have empty origins. So they don't need to be empty and they don't need to be zero. We are hitting this. And that's because we are not storing the origins just yet. Not for not outside of our immediate use of them in this function. So what I think we want to do is we don't want to touch this code because this runs per light source, and we have 3 sets of light sources, or we have 3 different light sources that we store origins and light values for. So I think we have to keep this intact, and we have to do the storing of information in the chunk rendering thread, which is the kind of, like, higher level. This is the one where we're running that. So render this chunk lighting. So we could pull these together again, like this. This is kind of like the lighting phase. We might add braces around parts of this. For instance, I think we could brace this entire part, but it's not too interesting. We're not going to do that just yet. Code formatting is something for later on. So far we've kind of stuck with the style that's surrounded this. It will work first time, 0 bugs. That's what I'm hoping for. This is the first time I do a live coding stream. I never did pair programming or like interactive programming like this before. So far I kind of like it. It forces me to get my thoughts, like, in a good shape and form to be able to implement things, and I'm liking it so far. It's also something I was really looking forward to implementing this. So the fact that I'm working on it is a win in my book at all. So let's see. We're going to pass in this. What are the data? What's the data look like? We pass it in as a pointer, and we pass that in as a pointer of pointers. Okay, I can live with that. We just pass it in the same way. And I have some very cool other things lined up. So this is not the first and only stream that I do. I hope to do these I hope to do these in the future. And there's just so, like, this is my work. If I wasn't streaming this, I would still be doing this work at this exact same moment, because I'm working on this video game and I want to release an updated version in the future. So I wanted to do this, and hopefully someone will pick up like some cool stuff that I'm doing here and say like, hey, it's cool, Firefly. So okay, we have a chunk light value renderer and we have a chunk light data renderer. And I think the data renderer is where we want to start storing data. So we pass in the light origins array. Okay, that's good. And then we open up the chunk light data renderer. So the data renderer is the thing that renders the data towards the chunk, and the value renderer is the one that like renders values that we are going to store later on. So what we add here, sorry, is a client chunk 3D data cell coordinate 3D light origins array like this. That's entirely cool. And then we also update the function here. So okay, this might be an excellent opportunity, and maybe I will do this off stream to start consting this up, because tick count will not change. I think, I'm not sure if but at least the pointer to the cell data provider will not change. The chunk pointer will not change, and so on and so forth. So I can const up a few of these. Might do some more later on. So this should at least compile. Seriously, dude, this bot report. Boop. I hope they get them to watch the live stream. Come on. Okay, so here we are. We're still building, and now we're passing in the other stuff. So we have all of the data here, and we loop through the whole chunk. Initialize new light data. Shadows will be calculated lazily when needed. Okay, that's cool. Get the light cell light values. Okay, so here we can actually start comparing like which light is the lightest one. Randomly dither the values with a slight bias to darker color. Okay, yeah. we're just going to use the values as is. So store light data. Okay, so now calculate brightest light origin. Cell coordinate 3D origin is the light origins array. So let's by default light color, light source, artificial. Let's do this alphabetically. Dot get in chunk coordinate. So we'll start off with the artificial origin, and if the artificial value is smaller than infrared, how can we do this in two comparisons? What's the best way to do this? If infrared is smaller than ultraviolet, then we store ultraviolet, else we store infrared. I think that makes sense, right? And then we also have to check if let's make it easy on ourselves. Let's make it easy on ourselves. UN32T brightest source is artificial. Yeah, there's some hints left and right. You are true. You're true. You're right. If brightest source is smaller than infrared, brightest source is infrared, and the origin becomes the source. infrared, and if brightest source is smaller than ultraviolet, then the brightest source is ultraviolet. We don't actually use this, and the origin becomes the light origins array. Ultraviolet. Okay, here we go. So we can, this assignment is dead. We start with artificial, and then we use the artificial origin always. So what do we do if we have 0 light here? That's also a interesting one. If all of them, like if the, and then we do have to do this. Check this out. So we do have to store ultraviolet. So we start with artificial. If that is 0, it will remain 0. If all are 0, it will remain 0. Otherwise, we have the brightest sources. So calculate brightest light origin. That's cool. And then we store brightest light origin if we have any light. If 0 is smaller than the brightest source, then we set the data. And how do we do this? It's pretty easy. We say light data. Where do we get light data from? Okay, that's the chunk light data. Client chunk 3D data, cell coordinate 3D, pointer light data. Origins is chunk get light data. Origins, there we go, and then we store it. Now the big question is, do we have to zero this out? Because maybe we do have to. A random thought, yeah, let's hear. So light origins, data origins set in chunk coordinate origin, and else. So if we don't have a light source, we just reset it to be empty in chunk coordinate, cell coordinate 3D. So that's why we still trigger on empty. If you're calculating the brightness already, couldn't you just take the direction from there? Well, what we're doing here is we do this flood fill, so every voxel, the direction vector size would also kind of be the brightness. Yeah and no, because the same brightness can arrive from multiple directions. So that's why if you know the value of a value, this is kind of like the remaining light. It's a flood fill. So we start with the brightest light at all of the blocks where the lights actually are, and then it floods outwards from these blocks in diminishing intensity. So if you know the intensity of a certain light somewhere, you don't know where it came from, and that's why we're tracking the origin of that light as well, so of the brightest light now. So either like we don't even have to do a comparison here. So let's say const bool has any light is 0 smaller than brightest source. So these are Yoda expressions. I use these everywhere. Some people dislike them, I like them. I do Yoda expressions everywhere. You first take the fixed value, and then you do like the variable value. This prevents you, if you're doing an if, for instance, if brightest source is 0, this will never be true because you set brightest value to 0. What you actually meant here is to say is equals. So to prevent this, to prevent any errors from mistyping this, like if you rearrange them, this you can never assign brightest source to 0. So it will only compile if you use the actual equals comparison. I use Yoda everywhere, Yoda expressions. It's my bread and butter. So if it has any light, then we store the origin, and otherwise we store an empty cell coordinate. I think that looks store brightest light origin if we have any light. I think this looks pretty good and makes it a one-liner. Okay, so now we store light data origins. Now the only thing left to do is to store the data in the hull. And how do we do that? How do we do that? how do we do that? Some good powerful quotes in the chat by Obi. Do or do not, there is no try. Except if you're using Java, then there is a try and a catch. And you have to use them. So chunk light value renderer, here we go. Mix in the light from all of the chunks, okay, but we store the hull here. Store light data for chunk hull along the x-axis. Okay, I like that. But then, why do we do this? The fact that you have to use them is horrible. Yeah, so there are languages in which such an assignment, or you can enable compiler warnings for it. The streaming in YouTube better switch. Okay, Wick, what's up? As far as I know, the stream is going well. I'm not exactly sure. Stream is healthy, has been for a few hours. Oh, the streaming is better than Twitch. Okay, that's cool. Still though, I would appreciate it if you also maybe followed on Twitch. That's also cool. Anyway, right, where were we? Okay, so we're storing this in the hull, but why? Why are we storing this in the hull? That's what I'm wondering. Store light data for the chunk hull along the x sides. That's because we don't store this data at that resolution. Okay, that's cool. I can understand. I can see why we're doing this. Which also means that it's just a straight copy from the end chunk coordinates. Because CPC AXM1 probably stands for cells per chunk axis -1. Yeah, seriously, it is. Cells per chunk axis -1. Okay, called it. Okay, so I still understand some of this code. Hey Wick, are you a game developer, or are you a developer? Are you here from the Angel Dust forum post, or the Angel Dust live stream that you usually know? So today I'm doing things a bit differently, or at least this channel is dedicated to like actual game development, programming, and showing like real game development in the real world. So feel free to ask any questions or comment on what I'm doing. Today's goal is to make the lights in the world that you place in the voxel grid, to make those like actually cast specular highlighting in the world. And we want to support an infinite amount of lights. CPC axis is not what you think it is. Okay, yeah, I can imagine. Right, so basically what we are storing here is the same as what we're storing in the other thing. So chunk light data renderer. So maybe what we want to do is to store things for the hull. So store hull lighting, light origins. And this is a bit of a weird comparison, but if x equals 0 or x equals 31, which is basically the AD-CPC, but we don't have it here right now, so I'm just going to type 31. Or y is a 0 equals 0, or y equals 31, or z equals 0, and I'm not using Yoda expressions here, or 31 is z. These are all whole cells. Let's start improving this. X, 0, Y. So these are all at the edge of the chunk. What? Oh god. What? Oh god. What's up? It's not that bad, is it? Yeah, I mixed Yoda with no Yoda, true. Is on hull. Let's make this very clear what we're doing here. I think the comment already kind of explains, but you can never be too clear. parentheses, let's be consistent in what we said. And I hope the compiler is able to deduce that we're doing something here and make it a bit better if it's on the hull. Boop. Then we want to store it in the hull. But how do we get to the hull? Here, it's easy. It's actually the first thing that we... Client, chunk, 3D data hull, cell coordinate 3D, light hull origins is chunk get light hull origins. That's pretty good. Is it a pointer? It's a pointer. Does this compile? It compiles. Okay, so if it's on the hull, then we light data light hull origins set in chunk coordinate, and then we do this differently. If false, we don't even, let's do it differently. If false, here we go. This is what I wanted to do. If the brightest source is 0, so if we have no light at all, the origin becomes empty, and then we just store the origin like this, because the origin is empty if it's if there's no light. If there is light, we have a true origin, and we can just store that same origin value here in the hull. So store brightest light origin if you have any light, store brightest light origin in chunk hull. There we go. Use multiple cursors, you must achieve ultimate speed. You will, yeah. I'm not sure what the key is for multiple cursors in Xcode. It's not the Alt key. I use the command key to actually navigate around the code. I'm not sure if it's shift. No, shift is selection. So control, no. So it's probably some weird combination. Oh, block selection. Ever use this? This is very useful. Command Alt, very useful. Okay, so supposedly we're storing the origins now in the hull and in the chunk itself. So let's fire this up, and we shouldn't hit those assertions anymore. And the first thing we do is hit the assertion. All right. Oh, oops, this is coming from the chunk light value renderer. Hey, we're back. I use a thing where you can control D and it just adds a new cursor to the next thing it finds. As a symbol. It's super useful. It sounds super useful. All right. Anyway, so we are rendering a chunk, rendering light values, the artificial ones, and then we set up the light origins. And as soon as we copy light in from the back, apparently it does work for other parts, but we do have propagated light, okay? And the light origin is, it's empty. And that's because the cell data provider getLightOrigin returns that. So the local cache did nothing. Okay, that's true. That just delegates. Apparently we don't know this chunk. So then what do we want to do? If we know that the light is coming from somewhere, I don't like the fact that we can't, like we don't know the chunk, and that's cool. I mean, get client chunk, maybe this is cached or something. Get client chunk, what does it look like? Does it only know the neighbors? Maybe it doesn't know like all of the chunks. Yeah, if we're in cached mode, it might not know all of the chunks. Who this? Why do I get the impression that these people are never gonna stop. Like, we can remove the assertion, I mean, and then it will compile, and then we will be happy. But supposedly, if we're asking for the light origin in the hull, right? Because is this based on the hull? It's based on the hull. If it's based on the hull, maybe we can just say like, okay, apparently we don't know the light origin for that piece or for that part just yet. We are storing it though. Yeah, Obi, some deep thoughts on the chatterinos. Anyway, how do we want to fix this? So we are propagating light from a neighbor, so it does have a light value, but apparently the neighbor doesn't provide a light origin for the same thing. So it kind of feels like we did run this code for that neighbor, like store all of the stuff for that neighbor, and we did that. That's entirely cool, but it looks like we never stored anything in the light data renderer. Shall we continue and see what happens? So maybe we should add a fix me here. Fix me. Let's make this very obvious that we need to do something here. Why would we return empty here? So let's, instead of an empty coordinate, let's just return the coordinate itself, in the sense that we hope to, like, the light is still coming from that direction, that general direction, right, seen from ourselves. See, and we're still hitting something. So apparently that was not the problem at all. Although it says light origin here. But where is this coming from? The local cache delegates this to the cell data provider. Okay, that's cool. And then we end up in this lookup. Okay, so it's not coming from this place, or at least not immediately. So let's revert this. Let's say that this can return an empty. Okay. But then apparently we are just not storing the correct values. Chunk light data renderer. It's a bit of a mess that we're untangling here. So apparently we're hitting this then. Store the brightest light origin if we have any light. So maybe this is a bad idea. Like if I make this 0, 0, 0, 0, 0, then we're probably hitting a 0 as an assertion, is my guess. Yeah, so instead of empty, it's now 0. It's not really reassuring, but it's something. We at least know what we're triggering. So we have a spot in our chunk that doesn't have a brightest light source, that is actually storing a light value. No, empty is like max values. That's how you can empty is more like -1, sort of. It wraps around to the other side. So that's how you can distinguish between them. Because 0, 0, 0 is actually a very very usable and very representative coordinate in the game world. It's actually the origin of the world. 0, 0, 0. So max, 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 sort of, if you wrap around, max, max, max is the empty one without a value set. 0, 0, 0 is actually like a perfectly fine coordinate. It's just 0. Time to print, yeah, maybe. Store the light data. Okay, so is there any continue here? No, we are always doing this. We are always going through the entire chunk, so that's good. But still, we get the brightest source. It's artificial. And that's like the actual value that we have. There's no reason to doubt these. This has been working for years. If the brightest source isn't as bright as the infrared, the brightest source becomes infrared, and we update the origins. The origin, that's cool. And if the brightest source is less intense than the ultraviolet channel, then we become ultraviolet. That's also cool, and the origin becomes the ultraviolet origin. That's cool. But then still, like, if we don't have an origin, we want to send it to 0. We want to set it to 0. That's... Well, the chunk hole looks good. So do we know? Like, it's time to caveman this, printf. Let's print this. Origin was origin X, origin Y, origin Z, and afterwards is let's see what happens. It does take a while, as you can see, before it now crashes, so we are actually doing something. Okay, the origin was empty and then it becomes 0, so that's completely useless. That's completely useless. Here it was something, and then we overwrite it with nothing. Why? Yeah, this is the best way to debug. Brightest sources are artificial. Okay. So that's between 0 and 255. That's entirely cool. Oh, wait. Here we are dithering values and things. Check this out. Okay, so I think it's time. It might be time to const these up. There we go. And then we turn these into const copies. Or we could call these like raw. Right, I don't like this. What did I miss? Everything. Everything. So let's see, and then instead of using the dithered version, we start using the actual bytes that we have. So maybe that will change something. It probably will not, but hey, you can never be too sure, right? So I think this was the problem. We weren't comparing the direct values from 0 to 255, but randomized things, randomized and dithered things. So that's not going to work. So this is probably how it should be. So we're not hitting the assertion, not yet at least.
Oh, no time to waste, let's go.
So I believe everything works, but it was just a dumb... This is why you const things up and you never reuse a variable with like after you've changed it. So OB, another win for consting up things. So Hum, what did you miss? Today is PBR-Shader Hacking, so I showed the game with a physically based renderer, PBR-Shader, and we took a look at some like rendering options that it has and how materials render in this new setup. And what we're doing right now is trying to make all artificial light sources, so all of the light sources that you can place in the world, like lanterns, but also like the crystals and other things. Try to have all of those render specular highlights on materials, so that you not only have the sun like as a light source that casts specular highlights and specular lighting in the world, but we also take like the nearest lantern for every position and render a specular highlight for that. It's going to look spectacular, kind of sounds similar like specular. So what we're doing right now, the point where we're at right now is that we are storing not only the light values at every location in the game world, but also the light direction, or at least the origin of the light. And now what is left is we have to calculate the light direction and store it inside the model vertices, or the vertices that get sent to the GPU. So we did all of the fragment shader, vertex shader, render buffer pipeline, OpenGL render engine. All of those have been upgraded already. We tested along the way with fixed light direction from the top, so that worked perfectly fine. We fixed a few normalization and data problem bugs already. We are now tracking, like the lighting algorithm is sort of a 3D flood fill in the grid of all of the voxels. So we take the light locations, like the light origins themselves, mark them as like intensity 255, and then just propagate the light outwards from there. We now also track the light origin for each of those propagations, and what's left now is using that data at the moment of rendering, or at least when we make the geometry. So this is working. We have some very strict assertions in the light value tracker. Let's see, light value tracker. So none of the origins that we are currently propagating or updating are either empty or zero. So that means we have correct data for every, like when the light is not off, when there's a little bit of light striking somewhere, we always have like a proper origin saved. And I think the fact that the game is now running without like crashing on that is good, or at least asserting on that. And I think as soon as like chunks start to re-render, so maybe we should try the online mode instead of the offline mode. Like if everything re-renders correctly, I'm pretty sure that like everything is ready, that we have the correct data everywhere. There we go. So in the online mode, something trips up. And it trips up because our in-chunk coordinate is out of bounds, it seems. We are at a different location in the world. So x is 11, y is 3, and z is /f. That's what? Tell me, what is it? What is that? And why is it not working? Yeah, it's an out of bounds. Okay, I can dig it, but like what's /f? Is that at least within our data range? Does it always crash on this? It's a form feed. Yeah, okay, so
no time to waste, let's go.
I can understand, but what is the ASCII value of form feed, and why does it display as a here it says z is 02, so that's just the value 2. Why? X is 25, Y is 17, and Z is hexadecimal 2. Okay, so this is all perfectly normal. We're in light source infrared, so maybe that's the problem. Maybe we are writing in wrong memory. Did we make a mistake here? The light origins is the light origins array for that light source. Because we never tested with infrared light sources. That's at least not offline, so let's try offline first. To keep things simple.
No time to waste, let's go.
Red lantern, where is it? You don't have the block Firefly because it's special and you can't have the block. Where is it? I think they used to be like somewhere around here, not? Network connection provider standalone, network connection standalone, standalone, network standalone, client connection standalone, I can dig it. Do we specifically not give you the thing or what? Yeah, we specifically do not give you this. Let's see. The lantern blocks, there we go. I deleted it, yes, that's how I roll.
Oh, no time to waste, let's go.
You specifically don't get these, so that you have to play the online mode. Okay, crash please, crash. You can do it, crash, 1, 2, 3. You know you want to. Please? No? Then there is no pleasing you. Okay, okay, then... Oh. Okay, things are crashing, and that's good. That's good. Let's see. Because I think once you remove a light, we never update the values again, so it's all finicky at the moment. Maybe let's concentrate on one thing at the same time.
Oh, no time to waste, let's go.
Oh, my lanterns are gone, and that's the way you want it. So unfortunately, Hum, you came in at a quite unfortunate time, because now things are falling apart slightly. So far we had been doing really well, and right now we have a few problems, a few more problems than we can take care of at the moment. But it's all good. We'll work through this. So where to start? If we play offline and we don't remove any lights, and if we play like from here, apparently our values are all cool, and it propagates light, I think, or I believe at least. And we have the origin set up. There are no origins that are out of bounds or empty or 000. So that's a good base. We could actually like try to render what we have offline. Oh, it's usually when you get called. Okay, cool. But yeah, you've missed kind of the part leading up to this, so you might not have a direct clue where the problem is at the moment. But hey, join the club. I don't either. But it's all cool. So let's see. Where do we go from here? Maybe we just start like using the data, rendering with it, so that we can at least see if it's worth perfecting. Because if it looks like if it doesn't look good, we don't even have to spend any time on this. So then what we want to do is we want to look at the client light color provider. Apparently. This is what it gets called for every vertex in the game world, and vertices in the game world get called with the nice version of this, and we also have a fast version of this. Yeah, that's what, well, if it doesn't look good, like maybe there's even more bugs that we'll uncover while building upon this data. But for now, let's just make it work, and then we can decide where we'll take it. I think that's the best approach to this. So we want to update the lighting nice, this thing, and it gets called on a vertex, and we have a cell data provider. Sounds familiar. And I think this is only called in the item interaction interface. Yeah, user interface, draw frame. Yeah, okay, that's for the user interface, so we don't have to worry about get applied light color nice, because this is actually what we do in the fragment shader. Fast is also something we don't have to do just yet, because that's called for the models. So if we look at where this is called, it's in the sprite renderers and the particles. And if we look at the update lighting nice, that's called in the model vertex beautifier and in some other places where we want a bit more or a bit better lighting. So that's like the place where we want to do this. So remember the 5th of December. So this is where we interpolate light data. This is actually what we want to do, kind of, sort of. On the other hand, I can live with just simply doing a single sample at the moment and just seeing what happens from that. So our task here in this function is to update this model vertex. And remember, this vertex, model vertex, now has a lighting direction, and we use decimal byte normalized vector from. So this is what we use to... Yeah, it's seriously, this is an 8-point sampling. So if you have a cube, this is a 3D grid sampler. So you sample at 8 points at x0, y0, z0, at x1, y0, z0. So this is just the x coordinate, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1. And then you do the y's 0, 0, 1, 1, 0, 0, 1, 1. And then the z's 0, 1, 0, 1, 0, 1. So you sample all of the points around it. And again, the coordinates offsets are like that. So this is why it's called update lighting nice, because it actually samples 8. It does kind of like cubic interpolation, literally. So the lighting direction is the normalized vector from, and the vector is our destination. Like, how do we calculate the vector towards a point? It's like the light origin minus where we are. So this is kind of like origin subtract position. Position is the actual, if I'm not mistaken, the actual in-game world position. So that's cool. Yeah, so this is how we do it. And then now it's only a matter of getting origin. So const cell coordinate 3D origin. Oh, and it's not the origin itself, because this is the coordinate. Let's call it light origin. Let's just keep it empty like that for now. And we want the decimal vector from center of light origin. So this makes sense, right? We take the center of the light origin, which is what we've calculated from the flood fill. We take our vertex position, and then we subtract our position from the light origin. Or is it the other way around? Yeah. If I'm doing it like this, like we can try both ways. It's simple. It's 3D programming. It doesn't have to be perfect first time. We just have to get the light origin. And how do we do it? It's the cell data provider. Cell data provider. Get light origin. And then it wants a coordinate. Okay, so yeah, this is where it gets interesting, because we kinda woulda wanna interpolate this, but let's pretend that we don't interpolate, and let's just say that we have a sample position, and that gets converted into coordinates. So let's just do this the same way. So this is going to work. This is going to work. Enjoy, and we'll see if it's worth it to debug this.
Oh, no time to waste. Let's go.
Hey. Hey, check it out, here. There we go. Boom. Hey Hum, you came at the exact right time, because it's actually working now. One moment. You actually still see the timer. One moment, I will remove the timer. Get out of here. Yeah, no, this was the moment everyone was waiting for, but it's all good. Here we go. So, hey, check this out. See? See it? See this? See this? See this? It's actually reflecting the lamp. It's working exactly as intended. The first try. See this? Wow. Check it out. Oh, okay. There might be improvements that we can do to this, but hey, okay. Like, I'm not sure what's happening here. It's probably something We can't do that, Obi, because we treat these as point lights. Everything gets treated as a point light. Check it out, you actually see this, like closer to this light. See how the light, what? See the directional lighting on these. What? I'm going crazy. I'm going crazy. Check out the directional lighting on that stuff. Seriously. Check out the lamps over here. So you also see, like, okay, so there's a bit of a sampling bias going on. We need to kind of look into that and fix that. But check it out. This will make... What? 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 This is looking like a ray tracer almost. In a way, we of course. What? Check out the lighting quality on that. So okay, the thing is laggy as a bit. Check out the light on this tree. Check it out. What? Now, like I said, I have no idea what the lighting does in between here, but hey, it's a... Whoa, check it out! It looks so good! It looks so good! It looks so good! Whoa! Alright, so this is why I wanted to push forward and try to get this working. And remember, this is without the sunlight, right? So we kind of like want to re-enable the sun, so I think the direction of the vector is the right way around, and of course it is, but there was something to be said that it might have been the other way around. We cannot always, of course, check what that looks like. Position, subtract, but I don't think this is the right way to go. This is not the way, as Ugandan tales would say.
Oh, no time to waste, let's go.
Or is it? No, because like, see, you don't actually see the reflection in this anymore. So I do not believe that this is the right way. Instead everything that isn't lit, that shouldn't be lit, is now lit. So this is, of course, it's still near the lights, but like this light, let me use my pointy stick again. This light can never affect that face because it's actually pointing away from it. So that doesn't make sense. And now you might say like, hey, but the other way around, it doesn't really light up the area, and I'm saying like, okay, that's true,
oh, no
but
time to waste. Let's
it
go.
is not realistic. This is the correct way. Oh, the directionality, it makes things so beautiful. Whoa, check this out. Just the way, what? I really like this, I really like this. Check out the way the different materials reflect. Check it out. And I'm also amazed. I'm also amazed by how good this looks. We now have an infinite amount of light sources. Like if we, I think this is a chunk boundary. Maybe the chunk boundaries are a problem. Like this is not exactly what it should look like, but this is what we get. And there's a bit of sampling bias and so going on. That's fixable. I think like the entire lighting calculations are off by one sometimes, but overall this is exactly what I wanted to shoot for. Yeah, we can try some of the lanterns. Let's see what happens. Let's place one over here, for instance. Ooh, do you see that? So yeah, this chunk doesn't get updated just yet, so maybe we add another one here. See how it affects one side of the grass and not the other one? Or at least not much of it. And that's the way we like it, yes. Oh, I had planned to do a live stream, and I had planned something else to show you, which is going to blow your mind like equally much as this. I was going to do another live stream with a different topic or a different subject, and then like right before I was going to do this stream, I think it was yesterday or yeah, so I was like, what if we What's a triangle shadow? Huh? What's a triangle shadow? You're a triangle shadow. Can you elaborate, Hum? So I'm really glad that I came up with this idea of doing it like this. And it might not be perfect, but as far as I can tell right now, it adds so much fidelity to the lighting. Do mind. I believe we're still running with the 32x multiplier on this, so we should probably investigate why we need to multiply by 32, or if we should tone it down. But check out the lighting on this. Just the way that these wooden like ceiling parts reflect. We can also do it in the time-lapse mode, of course, because that doesn't change a thing. So you'll probably see the light in front of this in a few seconds. Yeah, by the way, we're not doing the sun lighting. Did I miss anything good? Yeah, you missed the breakthrough, Loki. We're going to re-enable the sun. So let's open up the PBR fragment shader again, and now actually let's add the sun to this. Let's revise the thing at all. So let's see PBR.frag. We scale the sun by 4. That's good. What else do? We have the lighting direction. That's new, of course. We disable texturing for now. That's good. Sun reflectance, sun radiance. That's all good. All well and good. Artificial light reflectance equation. Yeah, so I'm not really happy with this times 32. Like, what happens if we scale it back? The lighting is, if it's like entirely gone, there's a different problem that we need to solve first. This is all cool, this is all cool, it's just a straight up copy. We do the zenith plus the light color source, that's already cool. That's good, and otherwise we didn't change anything. So okay, the sun should be back now.
Oh, no time to waste, let's go.
Here we go, directional shadows are working again, like this, so we have a better grasp of what lightning looks like. Here, now we actually have the sun. See, we have the sun reflect here, that's the sun, the left one, and the right one is the lamp. And the lamp is actually reflecting in the shadow of the sun, which is good, because the shadow of the sun is actually behind the lamp in the reflection. See, so that's pretty good, And let's see if we can find, like, what does this look at nighttime? It's so good. It's so good. No, seriously, Loki, we have made such a cool thing today. Every dynamic light that you see, every lamp in the game now casts specular reflection, so those highlights that you saw. So I think the lighting, the lights can be a little bit lighter, because right now you can't really see them. And I think it's cool to have them reflect even at in daytime. So let's turn up the strength a bit, turn up the sun, as they say. So 32 might have been overdoing it. Let's do the binary search thing again. We do 16 here.
Oh, no time to waste, let's go.
Do you see the sun? You can actually see the shadow from the tree there, and then in front of it the reflection from the lamp. Let's put the patina in front of that. Let's see what that looks like. Okay, a little bit of dithering due to the way the shadow works, but it's all cool. Check out! It's also on my spoon or on the shovel. Check it out. My shovel. My shovel actually reflects the light. Dude. What? See this? See this? If I take my telecharger and if I... See, this is the lamp reflecting in the telecharger. It's right behind me, right behind you. Hey, no problem, Loki. You're here at the right time. We are just having a bit of fun. Check it out. The lamp is actually reflecting in my axe as well. This is the best thing ever. Yeah, it just does so much for the realism. So let's see nighttime with this setup. So this is not 32x light power, but 16 power. Let's see during the night. The night is actually very short, so maybe I shouldn't use time-lapse, but let's just select 0 o'clock, 0 dark. Is this workable? Check out the reflection on the metals over here. I think that's actually the lamp reflecting in the metal as well. Because it only happens when we're like right above it. This seems to be the sun. It seems fine to me. But indoors, it's so moody. The lighting is so moody. Check it out. And then we move into this, whoa, check it out. It's so good. It's the moon. Yeah, okay, it's not the sun, it's the moon. You're absolutely right, it's the moon. Yeah, there's this weird bit going on there. That's something that we need to fix. I think that has something to do with going over the chunk boundary. Check out here. Here's the shadow of the builder. Dun dun dun. And here's the shadow of the lamp. But just the coloring, I really feel that this is a step up from like the AngelDust 4 beta. So you can see some light leaking through this. I'm not really too worried about it. I think the graphical fidelity is very good. So far I'm liking this. Yeah, we should probably head into the world and place some lamps. Because I'm not sure if we can actually see like the highlights working on this grass. The grass is a little bit glossy. That's true, but I'm not sure if we're going to see a lot of like glossy reflections from this. Can anyone tell me, like, do you see anything that resembles a specular highlight from this? From this? It's very hard to see if this is casting specular highlights or not. So can we catch the lamp reflection in the signpost here? Yeah, it's impossible. Impossible. Maybe on this wood we can see a bit of reflection going on. Yeah, definitely. Check out here. Check. You can see it most clearly here on this top edge. You can see the white portion move along with this. See this? There's a bit of specularity going on there. It's in the corner where the camera is closest. It's subtle, but it's there. But it's also a very rough material, so don't worry about it. Okay, so that's that. Let's see if we can head into the world. Here we go. Here we have regular grass and some other stuff. Okay, we build out again. So apparently we are storing things outside of memory. So maybe that's what this light source here is. It again infrared or ultraviolet? Ultraviolet. Okay. So we are doing some out of bounds storing here. We need to fix that. Other than that, it's looking absolutely amazing. So far.
Oh, no time to waste, let's go.
I feel. I really love this interior. Like once you go inside here, like the direction of the lighting is just amazing, I feel. The directionality of this. So we have disabled texturing because textures might, or they like mess up the look because we don't have PBR textures at the moment. But okay, we are pretty close to having something working. And how many files changed? 27 files changed. So it is a pretty hefty change, but it's also very nice to see visually. And like, if this actually works, it's really great. It's a bit weird behind the lamp, but still pretty. Okay, but like there's sampling problems left and right. I think because if you take a look at this, what was it called? Light color provider. Yeah. So we have this light color sampling offset subtraction, and I think there's a structural problem, and it works for AngelDust 3, so the AngelDust that's currently on the market. For that game version it works. I think for this engine we need to get rid of this, and we need to actually sample in a different way. There's probably an offset to this grid, and I just like naively use the existing calculations, and maybe we need to interpolate or like get the closest light origin from like all neighbors here, and then use the one that's closest. Still though, we're making good progress. So set up light origin. Yeah, let's just call it set up light origin for now. That's entirely good. We're making good progress, except there's out of bound reads and wrong writes, and we're not clearing data once you remove a lamp. Still though, I'm already pretty happy. So chunk rendering thread. What can the problem be? So we have light source non-encount. We have artificial at 0, infrared at 1, ultraviolet at 2. And we do assign 0, 1 and 2. We make new pointers for them, and we delete them afterwards. So should we run with leak check? I'm not sure if we can do a leak check run. Let's set up our profiling to be a debug build, and hopefully it will work instantly. So I'm not sure if any one of you is familiar with instruments. It's a very nice profiler and also a leak checker. So we're going to check for leaks, and then just run the game and see if there are memory leaks. So maybe I'm mistaken, and maybe I did something dumb somewhere.
Oh, no time to waste, let's go.
Every 10 seconds it will profile the heap and the stack and all of the things, so don't worry about it stopping at times. I really love this. Just the fact that you have like 2 reflections. I'm pretty sure we can get even more reflections going if you have 2 lamps that are close. I mean, that should work. Why don't we place a lamp? Yeah, that's a good question. Okay, so here you can see, yeah, here you can see there's kind of like a ghost lamp in between. So not sure how we will fix this. So there's like this ghost lamp, and it kind of like goes all over the place. So maybe don't add too many lamps to your build. So far, at least in this, yeah, okay, so it needs to update these values again. There we go. So far, it's looking pretty good, and I like the results. Okay, let's stop the profiler. Okay, there are bytes leaking in the wavefront object importer. I don't think they were there before, so I'm not exactly sure why we are leaking in this importer. Yeah, just use one lamp per 10 block radius. Now maybe there's a trick to this. Maybe we have to... it's something to think about for the future, but maybe there's a trick to this. And also, you will notice this earlier or more on metallic stuff than on non-metallics. And these lamps were pretty far out, so I'm not exactly sure why we were seeing such an overlap in rendering. We can investigate. This is weird. I haven't seen this leak before, and it's a malloc, 48 bytes, 80 bytes, 528 bytes. Why do these leak? I have no idea. I'm not sure if this is a new bug or something. We are leaking 9 bytes in scanf. Why? It's just probably only once per model. I will investigate later. So we're at least not leaking this memory. Not any memory that matters. So then the question still is, why are we writing out of bounds? Are we addressing this wrong, maybe? Should I remove this pointer here? Let's try to keep things a little bit equal here. Because I think this shouldn't be a pointer. Chunk light value renderer. Here we go. Boop. And we pass in. Let's make it easy on ourselves. Let's say this is an array and this is a pointer. Same deal with these. This is an array instead of like putting the pointer at the front. Let's try to disambiguate what we're doing. If out of bounds, then just don't. Yeah, that's good. Some good advice. That's some good advice. Oh wait, I know what we need to do. Or do I? Let's open up this thing. Diagnostics. Are we running? No, we're not running with malloc protection. Or actually, we want to do the runtime address sanitizer. There we go. Zombie objects. I'm not a fan of zombie objects. But this is, we have to recompile everything now. But now we have like better memory protection. It's going to run a lot slower, but hey, what can you do? What can you do? But I think that array we were using, maybe we were addressing it wrong. It's always tricky to get this right in C++. Or in C even. But ooh, did it look good. I was really happy with the way things looked. So hopefully we're able to like iron out the wrinkles and make sure that everything is super awesome. So we want to make this a pointer then. That's cool. And then the light value tracker, CPP, instead of taking a... Let's make this a pointer as well. There we go, just because we can. Let's const these up. Like this. Light origins, and then we use a pointer assignment thingamajig. Let's keep everything as much the same as we can. So Hum or Loki or anyone else watching, if you're more interested in fragment shader programming or the like the connection between the render engine and the shaders in OpenGL, definitely try to watch like earlier parts in the stream. Right now we're wrapping things up, getting data from the game engine into the shaded stuff. So like the shaders are working perfectly fine. The connection with OpenGL and between all of the attributes and passing data around is actually working perfectly fine. Right now we're struggling to get the game engine to properly store its internal data. And it's weird because that sounds like the most high level part where you can't make any mistakes or that can't go wrong. But hey,
no
things are going wrong. Okay, so now we're running with the address sanitizer. As you can see, the game world loads in a lot slower because it's doing way more checks on all of the data that's being read and accessed. But this might catch the bugs that we were running into. So let's see if we go to a different location. Hopefully we'll find something with the crystals or the symbionts. Also, I'm streaming, which makes my computer even slower. The water is looking good. Check it out. I just like the way it looks. I like the way the game now looks. It's just so realistic. Whoa, check it out. It's so good. Okay, here in the void, there are definitely ultraviolet and red, infrared. Look at me, I'm between the stars. Oh. Is anything actually going to load in? Hello? Hello, I'm in the water, check it out. Where am I? everything is busted. Alright, okay, so once more in the render light data thing, let's remove this star. I don't want to have too many stars here. And let's open up client chunk light data renderer. There we go. And let's make this a pointer. And it's an array. That's cool. And let's const this. We can const that. At least I think we can. Boop. Boop. Sure. What? Why don't you like this? Okay, yeah, so maybe not const up this one because we are probably going to write to that or not, light values artificial, get. Oh, we can const it. One moment here, we will get there. No, like this. It's a constant pointer to a constant data thing. Okay, and now get is not const. Okay, OB, you were absolutely right. We're not consting this. We're just fixing the bugs and then we're out of here. Sounds like the most viable plan. This is left as an exercise for Firefly after the stream. So let's not try to get fancy with that either. Otherwise we're just doing const dances all day long and that's not fun for anyone to watch, I think. Unless you're into that thing, then my next live stream will be const all the things. I think it was actually an empty part of the world indeed. It was not the void, it was just an empty part of the world where I ended up.
Time to waste, let's go.
Pretty weird, if you ask me. Okay, here we go. Crash me, baby. Crash me harder. This should look interesting. This ice, as you can see, is very glossy. See, we get reflections from the crystals. It looks pretty interesting, like a sort of subsurface scattering. Do you see this? Let's see if we can get like next to one. There's definitely some like specular highlights, like if you place it in your back or so. It's really nice. It's also very directional. You can really see that the crystal is like radiating this light instead of something else. Here you can see this in the shadow here. Here's a specular, another specular light on the grass even here. See it? It's almost in the shape of the crystal even. So take a look before we crash. Take a look before we crash on this. And that's the sun. Of course, this is the sun that's coming in. And this is a combination of what? Oh, this is a shadow. The sun is over there. That's actually a long shadow. Okay, I can dig it. Let's see if we can find a violet area. It's a bit random where you end up, but we can always try to end up someplace good. We could also just place a random lantern here, see what happens. But as you can see, this is like the reflection from the sun, the specular highlight. So looking good still. And maybe we do end up in the void and we have all 3 types of lighting. Okay, so here we have, I think, purple. I think I saw some purple dots. Here we go. So can we see some specular going on? The thing itself looks pretty good. It looks very blobby, which is what it should look like. And again, like here, you see the specular lighting coming off. So that's good. That's good. On this side, it's a little more subtle, or it's totally absent. So why don't we see like specularity going on this side? That's something to investigate later. It might have something to do with like the sampling. Maybe the sampling is off. Maybe something is wrong. Also, this blob is moving. Like on this side we have the specularity. And here it is completely absent. Well, like while you would expect it to like radiate equally here. So parts of it are working, or I consider parts of it working, and parts of it are not working as intended. That's something to investigate, and maybe it will actually uncover the bugs. Maybe there's a coordinate system mismatch where we use the wrong set of coordinates. Like for instance here, I would expect it to be way brighter. Yeah, there's a tree shadow from the sun, but still the lighting, the light from this thing should still like radiate all over the place. So get my pointy stick. You would expect like this is at least the bottom part. I'm not sure about the top parts, but this bottom part at least for sure is a light source. So you would expect like some light here. And maybe that is the problem, that only the bottom part is the light source. That like this, like these top parts should actually also be a light source for this to work. And that's why the crystals do look good. Maybe that's the idea, but these blobs, I'm pretty sure that the entire blob is a light source. And still it doesn't really seem to be like transpiring to the ground here. So there's a bit of a specular highlight there in the water. And here too, but that might be the sun. Where's the sun? Yeah, the sun is, I think, in that location. So that just might be the sun. So definitely something fishy going on. While our calculations are probably correct, because there's no code crashing or asserting at the moment, there is something to investigate still. Like this one is, check out, this one is actually casting the specular. And okay, that it doesn't like reach all the way, I can kind of get into that, even though you would expect it to be a bit nicer than this. But there's actually, you can't really see it, but there's actually a difference in height here, so maybe it just stops like at that height difference. I can dig it, okay. Sure. But then still, you would expect this to radiate a bit further and also a little bit like closer. And on this side you actually don't see it that well. Here it's back again. So it sort of works and it sort of doesn't. It's blocking the local light. Does this man have a point? That shadows always block the light? If that's the case, things are going to look even better once we fix that. I don't think it is. It's going to be a wild goose chase here, but you might be onto something. Like here in the sun, we already subtract the shadow value. And I'm pretty sure if I remove that the sunlight will shine through shadows.
Oh, no time to waste, let's go.
I'm stuck. See, so the sunlight is now everywhere. even if it supposedly is shadowed. So I don't think that the shadow plays any part in what we were looking at. Because this is for the sun and this is for the local lights. And we just say local light color from sources. It doesn't say anything about shadow. I think the whole shadow thing doesn't come up anymore. But we can check, let's just search for shadow. Shadow map. Okay, so here's where we sample the shadow map. Here's where we calculate the shadow factor. Okay, this might get interesting. Normal based shadowing. Combine the shadow factors. Okay, so if the normal is turned away from the sun, we also shadow it, which is pretty... That's like logical. And we end up with local factor shadow. It's the max of the normal and of the vertex and the shadow map factor. Okay, and we mix the shadow map with the shadow. Yeah, okay. This is all good. This is all well and good, and we end up with local factor shadow. We subtract that from the sun radiance, so that's cool because where there is no sun, where everything is shadowed, the sunlight doesn't shine, and that's all of the shadow code we have. Yeah, and we did see the reflection of the lamp in the sun shadow. That's a good point, Obi. You're absolutely right.
Oh, no time to waste. Let's go.
This point that you see reflected in the golden bars here, the big one is the sun, and the small one is the lamp. And as you can see, there is a shadow being cast by the sun, and the sun is actually disappearing behind the shadow, but the lamp reflection is always in the sun shadow. So there's no way that this is that it's actually because of the shadow. What it is, we don't know, but we can check online. Maybe if we go into the online mode, we had lots of crashes here right before we switched over to the simpler pointer model. So let's see what happens here. I definitely love the look of this, so you can definitely see that there's directionality to the red lights now. We might need to fix the fast path, so we can add the same code to that, so that actually things reflect as well. Okay, here we have a pretty nice test case with the skull being made out of metal, and there are lamps inside. You definitely see lamp reflections in the eye sockets there. And there's definitely light coming in, like on the bottom of this. I have no idea what material this is. It's pretty dark right now. It's probably some kind of metal. Metal. These are probably lanterns, I think. It's pretty dark. Yeah, it might be the lack of texturing. Maybe there's something else going on with these. Because the water is also just pitch black. Like, this is pitch black. Why? Let's go into the City of Heroes. Let's see what happens here. See if we can get some lighting effects to show up or not. I'm pretty sure that there's lamps reflecting in the copper over there. I'm pretty sure there's lamps reflecting in that green dome over there. I'm pretty sure there's lamps reflecting in the marble over here. Check it out. I'm not sure about the propagation of the lights just yet, but we expect like this light to start reflecting just around there. It's black. Yeah, the metals being metals, that's like a good answer. Let's see if we can get some more lighting going on.
And now
hey Angelio, have fun.
Loot and we're happy.
So let's see if we have some convincing... Like, what's happening here? What's happening here? This is marble, but it's entirely washed out at the moment. That's a big sun, son. Son. Alright, but I feel we're close. I feel we're like this close to making this work. There might be some bugs. What? Is your coin UI reflecting when you picked up the coin and it was spinning? Yeah, there's actually a metal effect on the coin as well. That's how it goes, baby. Like, this is just a matter of not propagating between chunks, so that's why there's this hard border there. Apparently we still need to fix that, and there's probably also a chunk transition here, I'm not sure. But hey, what I said, we want to see that lamp reflect in the foot over here, and this lamp in the other foot. I think that's happening at the moment. I think there's definitely something to be said that these lamps are reflecting in that lion. Also, we're not crashing at the moment, at least, so that's cool. Let's see if we can open up a wonder. Here we go. It's the Violet Castle. Hopefully we'll have some light sources here. Oh, we have plenty of light sources. Where shall we go? This will be a good one. Yeah, unfortunately we're running in a slow mode, so maybe I should disable slow mode for a moment. Like, that part is a little bit blown out. It's very white. Not sure why. Yeah, I see all kinds of reflections here, internally, inside. I see some... Here, check this out. There's reflections to the left and to the right. I think that those are the lamps in the distance. Pointy stick. I think these lamps are reflecting there, and these lamps are reflecting there. That looks pretty sick. I feel this is reflecting that or so, or maybe on the other side of the hallway. Yeah, it's a bit too slow to kind of like interactively judge what we're looking at here. This is the sun. Yeah, okay, this is the sun. This is the lamp. So I'm pretty happy with the way that looks. This is the sun on the marble. That's cool. Do we have any lamps in the vicinity here? There's a lamp. Like, this is very bright. And I'm not sure why it is like super bright all of a sudden. Here, there's the lamp on the tablecloth. Check it out. Woo! So in all, it looks pretty good. It's already pretty good. There's definitely like a way to make this better. There's definitely a few bugs left and right that need to be ironed out. On the other hand, I'm really happy with what it looks like already. Like, this is a bit sus. This is a bit... It looks like it stops at the shadow here, but maybe it's just the chunk boundary or something. Are we near a chunk boundary? I'm not sure. But in all, I think it's pretty nice. Yeah, I agree. Just a bit better and things will be looking really amazing. Let's try another wonder. So, I'm not sure. Maybe there's like a super obvious thing that we did wrong. It's almost possible. Always possible, of course. Here we have this knight. Let's see. Oh, he's sitting. And I'm pretty sure that we see more than one reflection here. At least the metal is looking sick as it is. So you can definitely see that this is a knight wearing metal. And I'm pretty sure it's actually reflecting something. It's also lagging my computer way much. What's up with you, dude? Do you have any additional lighting on you? Don't worry about it, Obi. I think we kind of achieved what we wanted to achieve in this live stream. There's a bit of debugging that I want to do offline because let's not bother with that on the live stream. But like I think the idea holds water. I think it looks pretty good already, and with a bit of perfecting and refinement, it will be absolutely amazing. This is electrode again. Okay, so here we see some cool lighting effects come in, I think. There's a lantern over there, and it's reflecting... It's reflecting in the marble here, so that's cool.
And now we found the loot, and we're happy.
And maybe it's just like hard to see. Yeah, the more dudes are around, the slower my computer gets right now. So all of these NPCs are slowing it down. If I switch to hand-painted style, things will be going a lot smoother like this. But we don't get the dudes. So let's just enjoy the sights then. Yeah, this is just so good. The directionality of this light, it's really good. I'm not sure if it's like 100% perfect right yet. I'm inclined to say no, it's not perfect just yet, but we've definitely made some progress in making like lights everywhere look good. And I'm pretty sure once the like the little kinks are wrinkled out, everything will be amazing. I'm not sure where I end up now. It's a personal location, but where is it? It's rainy. It's rainy. Oh, this looks like Galdus' castle. Okay, it's a test case. Don't worry about it. Light inside. Okay, so let's kind of like get a feel for what this looks like. Like, I'm pretty sure that this kind of like diamond that you see, this diamond shape, is an artifact of the way we sample the lighting. And I think there's like wins to be had. Because it's really weird that it's to the top and to the left. Why is it not centered behind this lantern, for instance? But let's not worry too much. Let's see if we can find some cool vistas. Here on the wood. I think the marble works best for seeing the reflections. Anyway. Overall it looks pretty good. I mean, if you see the rendering of this, it's pretty convincing. We could, for a moment, enable texturing, just to get a feel for what that looks like. And I can also enable fast mode again. Maybe our programming wasn't as bad as we thought. But I'm used to running with address sanitizer on all the time. Let's see. Let's enable texturing then, see what it looks like. And we'll switch to the 3D dudes. Let's see, cartoon. 3D.
Oh, no time to waste, let's go.
Okay, with the textures it might be a bit more convincing in a way, because you can now see that this is actually a metal. On the other hand, things look a little bit ragged because the albedo of the materials gets changed now. Overall, it's a bit of a different look. We were in this untextured world for almost the entire live stream. Being back in the textured world with some textures applied is also pretty fun to see again, but we can do better than this, and we will be doing better than this on the future live streams. I think that the lighting effect is a little bit like subtler if you like see the results right now, because a lot of color and a lot of vibrance and lightness gets drawn away by these textures. On the other hand, there's some cool cool shapes and sights to enjoy with textures. And these trees look pretty good. Let's teleport around a bit more. Let's see if we can find one more magical area with lighting. Okay, here we go. So any way of getting a reflection from these crystals, that's like the hardest part. I mean, they look good, there's definitely lighting effects all around them, but maybe we should spawn a dude here. I'm not sure if we actually do reflections for dudes already. We could add that as well. Yeah, so I don't think that this this light is actually reflecting in the fighter, so let's add that as well. And that's in the light client light color provider. And then instead of just doing the nice thing, we do the same thing in the fast path. We only get like two. The nice path interpolates between 8 values, and the fast path interpolates between 2 values. But this code is just looking up 1, and we already have the sample position. We already know our coordinate, so we can just copy over that code. And hopefully this will be fast enough to still run in real time.
Oh, no time to waste, let's go.
And hopefully we'll now see like lanterns reflect in the buttons. And yes, already you can see, I'm not sure if you can get the camera close. Let's stand right next to this. Okay, it's hard to see on my own dude, but I'll spawn a knight right next to this lamp. Like this. And here you can see this is actually the lantern right next to him. And just look at the way that the light falls on him. Check it out, it looks like he's actually standing there. Like the shading on his face, it's so good. So multi lighting thingamajigs, that's pretty cool. That's all I ever wanted. I mean, take a look at the shading on this dude. Whoa. And let's go inside here and let's spawn another dude and let's see what that looks like. So here we'll spawn a... Oh, we can't spawn inside because of reasons. So let's get a scout over here, right next to this lantern. Scout is class number 3. There we go. And as you can see, like there's 2 separate lights going on. We've got the sun. I think the sun is a bit more to the... it's coincidentally at the same angle as the light, but hey, you can see that it's a bit more yellowish. And maybe if we enable the time lapse, you can actually see the sun moving around. Let's see, time lapse mode. Yeah, so I think you can definitely now see 2 light sources independently. The one to the left of her face is from the lantern, and you will see the other one, it's in the back now. It's nighttime, and now it's rising again on the right side of the screen. See, there's 2 lights now. I only see 4 lights. Okay, cool. Anyway, it works. Check it out, we're hanging in the lamp. That's just how we do it. And even with the sun in our back, check this out. There's still light falling on our face. And we're like, oh yeah, 5-hour live stream, eh, Fadi? That's how we do it. Check it out. So as you can see, the builder is having a good time, we're having a good time, and I'm really happy with this change. I think it needs a bit more refinement, so there's a few things that I need to debug. I will do that off stream, and because I don't think that makes for the best experience. At least in this video we did the entire process of going from the... Check out the reflection on that shield. Can you move it one more time, dude? Yeah. Whoa, so good. So we went from having just one like specular light source to having infinite specular light sources. There's a few problems that we still need to solve, but we did everything. Going from the game to the geometry generation, from calculating light data to a render buffer generation with render vertices, the OpenGL interface where we added attributes to have light direction, or at least like sampled light directions inside of the world. We did the vertex shader where we added like light directional lighting information. And eventually we also use it in the fragment shader, where we push the pixels to the screen. And it's really nice now. Yeah, that's what I was thinking. So check out the light here. There's infinite light sources now. How cool is that? Like every light source that you see is there, and just the haziness of the world and the way that the light reflects, it's so good. And I promise you what, it's going to get even better, because there's some big plans for this, and like for this visual style that I have, and it's going to be amazing. There's a few things that you don't know. We talked about it just real quickly, I kind of skimmed over it. skimmed over it, but it's going to be amazing. You will see. But this was the first step, and this was also a very recent discovery that I did. I thought like, okay, we already have lighting information, color information, so why not add directionality to it, and it will be amazing, it will be awesome. And it turns out it is pretty awesome if you have directional light information. So I want to check one more time now that the dudes have shadowing and so on and so forth going on.
Let's go.
How does this look in the real world with real lighting? I think this looks really moody and really cool. Oh, here we are again. See you later, alligator. So this looks really moody. I love this kind of lighting, and I believe it's also much better than what we had before. Just check out the way that the light falls onto these wings of this drakeling, instead of like being statically like lit. It's now actually directionally lit. Here's some purple light, so check that out. Maybe we can even, like in this build, check out how the light falls onto the wings. Whoa. Maybe we can get one like red light on one wing and a purple light on the other wing. I'm not sure. There's also yellow lights here, of course. These builds are pretty colorful. Very colorful. There's just lights everywhere. Okay, there's these horns, they give off light, so that's pretty cool. Let's take a look at those. It's definitely looking good. I'm enjoying this very much. Hey, you can see the red lanterns reflect in this thing. See this? There's lanterns reflecting in this thing. It's metal. Metal. Okay, so anyway, tweaking these materials and like the way everything looks, that's for a future episode. This was about what I wanted to achieve today, so there are things that we can still improve on this, of course. But I'm happy so far. Hey, and this is a picture from the live stream, check it out. So this is actually the place where I took my PBR hacking thumbnail picture. Maybe I can, like this one, see this? It's actually the building, over here. So check this out. This is pretty much the screenshot, check it out. Woo! If I move a little bit to the left, like this. See? I'm keeping it real. You never expected anything else, of course, but still keeping it real. And let's see what this interior looks like with the lighting. Oh, this is pretty good. You can definitely see that the lamp is right above the table there. And just everything looks pretty well lit. It's perfect, yeah, it's perfect. It's a perfect ending to the live stream as well, I think. Or at least close to ending. This is the upper portion of this house. So here I think there's definitely something going on, which is a bit weird. Like, why are these dark spots here? There's no reason that those are that those would be shadowed. So maybe I made a mistake in some of the calculations. That's entirely possible. I will double check those. On the other hand, like the parts that are lit and that are like looking good, it's so much better. Right now I don't really have the brain power anymore to really dive into that, but that's for another time. Do it do that on cartoon too? They don't think it be like it is, but it do. This is basically a new renderer for a new visual style, Gaston. So we can of course try to backport this to platforms and styles, but I want to make a completely new visual style out of this for the game. If you don't mind. I like it. It looks so good. It's so moody. Check out the lighting here. And it's not that the rest of the world is dark or anything. It's just like the lighting really makes your grabs your interest. So this is the City of Heroes. One more time. Here we are at the main plaza. Check out the directionality of these lights. You can see a bit of sunlight going on in the distance.
Hey, sweet haul.
We haven't tested the photon blocks just yet, so I'm not sure what's up with those. I hope they work. I hope they work. What is this thing? What are you? Why do you look like this? Here's another one. Why do you look like this? More bugs to fix. Here's the drawing of the harbor. Yeah, so the water doesn't reflect at the moment, which is a pity, because the water would look pretty nice with reflections. But what can you do? We just try our best. Yes, sir. And here's Valesi. So this is for Ruan. Tell Ruan to visit
Now
one
we
more time.
found the loot and we're happy.
Yeah, we're happy. Check out this shadow dragging across the. Or it's actually not shadow, it's actually light that lit up the box over there. So nighttime is actually now fun to walk around in all of these builds. It's dark where it should be dark, and it's light where it should be light. Like, I love how these windowsills, for instance, or yeah, like the sides of this window are lit up. And that you can actually tell where the light is coming from. Just looking inside of these houses. We should make a button where you see the old version, the old style, and the new style. So, there's definitely something to be said that these metals are a bit darkish at times. I mean, this is... Especially, I really hate the soldiers. Valesi Citizen, this was added before NPCs. But it's looking very good. I like it. And I'm pretty sure that we can get like all kinds of effects going with this. Alright, so let's exit the game. Like I said, we reviewed things, we kind of modified everything from the game engine all the way up to the fragment shaders. We were at 27 different changed files, we're still at 27 changed files. The code is running, so we are actually running without any crashes now, because I think I messed up with the pointer logic. We were probably pointing it to the start of the array of arrays and then going into the... and then like moving on to the next array of arrays, but that one wasn't there, so that crashes immediately. But we fixed it all, that's cool. There are no leaks, or at least no leaks that I am really interested in fixing right now. And make the water barrel reflect light. Yeah, I have big plans for the water barrel. It's going to be amazing. Also for the water, I'm not exactly sure why the water is rendering the way it is at the moment, because it should reflect and it would be absolutely amazing. But at the moment it doesn't reflect, but it's not a problem. Like my best guess is, and let's open up the PBR fragment shader here. My best guess is that it's too rough or too smooth. So roughness is blah blah blah. Maybe say like it's the max of 001 and the vertex material. I'm not sure if this actually fixes the water shading, or at least it's still unshaded, of course. But
Oh, no time to waste. Let's go.
let's see if we can find some water. Chaos jungle sounds like water. Oh, sounds like lava. Oops. Personal location. Give me water. Grasslands, no water here. What are you doing? I'm looking for water. But we'll fix the water, seriously. The water barrel and the water and the ice, they're going to look fantastic. They already look pretty fantastic in the intermediate version that I made with the shader pipeline but without physically based rendering. So the water is only going to look even more amazing. Is this the void proper? Okay, this is the void proper. Now we can see some light coming off this thing. That's good. And we can see light coming off this thing, and it's even directional. So that's good. That's good. I like it. And we can see some light coming off of the crystals there in the distance, so that's good. I'm happy with that. But still, we need water. And it's probably not going to render well, but hey, I want some water. I won't stop until I've seen water. Desert. Chance of water, very low. Here we'll have some water. Magical water. Except we're up in the mountains, so no water. Well, forget about the water then. Don't worry about the water. It's all good. I don't know where the water is. The water is gone. I'll click 2 more times. If you don't see any water in 2 times, it's too bad. But don't worry about it. No water. Last chance. Looking like a desert. No water. Okay, 1 more time. The void, no, that doesn't count. Okay, we're in the swamp. There's water in the swamp. Always has been. Here we go. Swamp water. And where's the sun? There. Okay, yeah. This is not the actual water reflection that I wanted to show you. But it's all good. Let's remove this line of code. And let's just say like, okay, this is it for today. Just give me 1 moment. And we're back. Okay, so 27 files changed. We can quickly just like skim the changes that we did and kind of like talk about those, and then the stream will be done. A lot of shader hacking, a lot of game engine hacking. We did like the entirety of the entire stack from game engine to like the actual game, by the way, to the fragment shader. So like we touched every level of complexity and of like abstraction. So these cell coordinates, we changed these because we wanted to have an is0 convenience method for making sure that we don't get empty light origin values. This is a chunk light data renderer. This is what converts the light values that we calculated. It stores those in the chunks that we actually persist and use in the engine. So what we do here is we make sure to now actually use the raw, the undithered data, and use that for our comparison. We select the brightest light that we can find and we store its origin. We actually track the origin in the light value tracker. We'll see that in a moment. So we store the origins now for all of the light sources. And that's what this part of the code does. Here's the chunk light value renderer. So this is what kind of like starts with a unlit chunk, an unlit world, and then says, okay, here are lamps, and we assign these lamps into the world, and then we flood out the light into the surrounding areas. Here we had to add like the origin, the light origin tracking as well, and that's mostly done in this function here. So light value tracker update, instead of having just the coordinate and the propagated light value, we now also propagate the light origin. So that's cool. Next up, this is the chunk rendering thread. So this is what actually takes the chunks and renders them to the like render buffers that we can show on screen. So this is done in the background. We render the chunks in the background. We display them interactively. We made, let's see, so we made here data structures here for the light origins array. I'm not exactly fond of this layout. I feel like having to assign this on the heap every time is a bit inelegant. This should probably be like a static initializer. I'm not sure if we have a static initializer for the chunk rendering thread, but I'm probably going to make this static so that we create these buffers only once and we clear them instead of having to recreate them every time we render a chunk. In the cell data provider, this is like the interface that a lot of parts of the game engine use. A lot of parts use this to like query light information, and we added, of course, the possibility to query light origin information, and that's what we added to the cached provider and to the lookup provider. That's these 4 files. And the client chunks themselves, so these are like the representations of the game world areas in the entire world. We added storage for the light hull origins, so there's a light hull around each chunk, like it's only the planes on the sides of the chunk, so that we can leak, kind of leak this data outwards. And I'm pretty sure that we might actually remove this light hole origins thing, because I'm pretty sure that the same data is stored in this light data origins thing. So that's something that I need to investigate. I think we can remove the hole and we can just instead use the light data origins thing, because we're already storing this data. And maybe this will prevent a lot of bugs, because we have to like assign these values in a second pass. Like, I'm pretty sure if we do this right now, right here, right now, it would actually work if we remove the light hole origins, because in the light data renderer, let's see, it's this class. Like, we store the same data in the light data origins as we do in the light hole origins. And it's actually completely dumb, a dumb way to store this in the light hole origins thing. Why would you want to do this? You don't. So why do it? I'm not sure. Shall we just remove it right now, right here? So that's a kind of an optimization we can do. And then we can kind of like, if we rename this back to light values, and we rename this light origins, we're Gucci. So let's rename this light values, and let's remove the const. So this is actually the same function again. So we're now trying to reduce the diff here. Get light origins, okay. I'm now trying to optimize and reduce the diff here a bit, because I think having a smaller diff makes things more easy. So this entire file now disappears from the version history thing, because it's actually the same as it was on disk. Client chunk, okay, this is good, and light origins is what we added. Now let the compilation errors begin. Here we go. I think there's always value. Like, you may try to make the code do what you want, and then you just reduce the entire diff based on what you've learned. For instance, this const, this is in the chunk light value renderer. I'm not sure if we can just revert that line to what it was. Probably already is. Where are we? Yeah, like this. Just not, let's keep it like that. Here we have the data hull. Okay, so we're not going to do the data hull anymore. And the light data origins, we're going to remove that, and we'll call it light data origins, like this. Press Ctrl C, yeah, maybe later, Max. Trying to make the most of this. A light origins set, and then the hull gone. Like, everything is like getting simpler now, so I like that. This was called get light values, like this. Let's see. Okay, that's back to the way it was on disk. Get light origin, that's cool. And this is now called get light origins. Okay, so it's always good to revise your patch at a later moment, or after you've done a lot of changes. Of course, we still need to check that it works. That's also pretty important, but I think this will work, and I think it will be good.
Oh, no time to waste, let's go.
Okay, we still have the reflection of the lamp in here, so that's good. We probably still have the same bug, yeah, with this kind of like whoop. But hey, maybe that's just what it is. Maybe that's just what it is. I mean, this is sort of a reflection of that lamp, so that's, I can entirely understand that it's reflecting the way it is. Otherwise, it's looking good. And let's see if the online mode still works. And if the light data is being propagated amongst chunks. And if that works, we're pretty good. So there's a bit of a line here, and that line should disappear once the data propagates. There we go, there we go. You see it fade out in the 2 or 3 times. Where's Obi? I think Obi had to go and do some school stuff now, so don't worry about that. Looking good, let's check one wonder. San Valentin, okay, this is a very special wonder. With a very special guard, as you can see. And the guard is even reflecting, check it out, there's a red reflection in him. He already looked pretty good, but now he looks absolutely good. Check him out, sitting on the throne or whatever. He's just having a good time. Yeah, Firefly, I'm just reflecting an infinite amount of lights now. That's cool. Here, and these coins are also reflecting an infinite amount of lights. And this
divine.
this MOA, check it out, it's being lit from the bottom. Check it out, it looks so good, it looks menacing. Pay close attention to its beak, like the beak and its head. Check it out, it looks like a horror movie. Dun dun dun, lit from below. Dun dun dun. It's pretty hot, it's pretty hot. Okay, here we are at Angelio's build, yeah. So the way my game is built at the moment, the optimizations that I have enabled. Check it out, the light from below, check it out, woohoo! And I feel heavy metal! But check out the pants, like check out the lighting on this dude. That's looking good. And here we have some lights at the face level, so these are more beauty lights. And check it out, it's just a way different light on the jacket and on the hat. Definitely looking good. Like this light from below, it just looks a bit like a horror movie. But it's pretty cool, it's pretty cool. Alright, so let's review the diff some more, because it's easy to get lost in the visuals. So we're now down to 26 changed files, which is less than 27, that's good. We were at the client chunk, so we only added the light origins. It is a bit of a hefty data structure. We do have to track a lot of data here. Maybe we can optimize that a bit, but I'm not sure, because we do need the actual light origins to be able to calculate the light vectors. But maybe we can, instead of using a cell coordinate, we can use a truncated version of that, because a light half the map away will never affect nearby cells. So maybe we should make a short coordinate kind of thing if this turns out to be a bottleneck during execution. Okay, we can revert this change. We don't need to have the red and violet lanterns in our inventory anymore. Let's reduce that diff here. So set up the light origin. We sample that just once, and we also sample it just once for the other thing. Vertex shader, we added the lighting direction. That's cool, lighting direction. And here the buffer lighting direction, we just pass it over to the fragment shader. That's entirely correct. In the light value tracker, we now track the light origins. And this, yeah, I'm not sure. I think these two variables are semantically grouped, sort of. And this is just a different kind of data. So I don't really want to remove this line in between, because I think then we jumble things together. So I think this looks a bit better. And now we take 2 arguments in the constructor, and we can't stop this, and we have a new light origin. So that's cool. In the light value tracker, this is basically what we did. This is actually what we wanted to do today. So if we are updating the light value for a certain grid point or a cell in the grid, we now assign an origin for that as well, where the light is coming from. So that's looking good. And model vertices, so this is what gets rendered by the game engine. Model vertices now have the lighting direction as well. We clear it automatically because of the constructor, and we have to check if vertices are the same with the same lighting direction. So I'm pretty sure that this is a correct way of doing this. It looks a bit weird. It's a very large structure that we're comparing. This is just the way that the code is laid out at the moment. I have no interest in changing this anytime soon. The fragment shader, we did change the name of the radiance scalar, because we now have 2 types of scalar. So we should actually introduce one here. PBR scale PBR sun ambient. Okay, we can leave that at 1.0, and we scale the PBR of the lights, and we actually set that to 32. because that's what we're using, if I'm not mistaken. Let's see. Where is the radiance for the lights? It's over here. Oh, we use 16 now. Okay, so we scale the PBR lights and then we use the constant of 16 for that. I'm not exactly sure why, because in my experience the sunlight is kind of similar to in value range as the lights themselves. So I'm not exactly sure why we need this huge 16 constant in there. But like,
Oh, no time to waste. Let's
compile,
go.
yeah, it compiles and it runs. Okay, so I'm not exactly sure why we have that. And then still the sun has got the bigger spot. So there's probably something that I'm missing here that I need to like find out. Maybe something here in this like normalize V plus L. I'm not sure if that's what we want to do. Like V is the view direction. Yeah, it's the direction towards Y plus L. We don't know. Oh yeah, so you end up with the vector of incidence. Yeah, maybe it's entirely correct. Maybe it's entirely correct. But anyway, we scale the lights now that way, and we also have the ambient term somewhere around here. Yeah, scale ambient. So we have scalars, and we can actually like make things look good. In the render buffer, we now set the lighting direction from the model vertices to the render vertices. So that's kind of like our in-between shuffling stage. The OpenGL render engine now has one more attribute because it has to pass the lighting direction. We do that in attribute number 5. It's actually index number 5. And the other ones just like move one down. So that's cool. In the state manager, the OpenGL state manager, we now fill the buffer lighting direction vertex properties. So that's going to the vertex program, the vertex shader. And we add like the lighting direction in our checks as well. And then in the render vertices here, you can see that our data layout has changed. We now add a like int ranged vertex or a vector for lighting direction. We had to update the vertex size, and we have a new setter for setting up that lighting direction. And like the other bytes just shuffle a little bit downwards. So this is also, the diff looks good. The diff looks pretty good, and like it works. There's probably like maybe an error or two in the algorithm, or maybe we're doing like something suboptimal in the sampling of things. But other than that, I'm really happy with the result. Like so far, I wasn't really expecting this to work first try, but it did. And there might be bugs that we still have to figure out. I mean, that's always a possibility. Like, why is this black? We have no idea, but it is black. I think this is some like issue that we have to fix. Yeah, it is an issue, of course. But other than that, I'm really happy with what we were able to achieve today. And let's disable texturing one more time so that we can actually see the light in effect, and we might visit some real game or real world wonder again to close out. So let's go into the online mode. I just think that everything looks a bit more vibrant this way. I mean, check out the lighting on this. It's never looked this good. The directionality of the lighting is always what has been hampering the visual quality of the game. This is the City X Bronx. I'm pretty sure there are lights over here. Yeah, so check it out. We're being lit from the underside here. And it's just exactly what you would expect from it. And like all of the dudes, they just look so in place now. Hey sir, how are you doing? Like the shading on everything is just so good. I mean, check out the light here. See this on this copper? I think it's copper at least. See the reflection on that bench? That's hot. And there's, like, these are metal things, I think. Hey, Angelio, welcome back. I'm just closing up shop. But like the lighting is so much improved now, especially on those metallics. I mean, check out the way my dude looks. He's pretty cool. So maybe we have to dial down the shading of the purple lights a little bit. But other than that, like, all of the lights are now giving off light and they're reflecting. It's so good. So we have infinite dynamic lights now. Hey builder, what's up? What's up? Show off your colors, man. Maybe it's best to watch the live stream, Angelio. It's a little bit hard to like summarize. But what we did today, and it's can you see the lantern over there, and can you see the reflection in the table? So this lantern is now actually reflecting in that table. That's what we did today. We now support an infinite amount of lights, like the lights that are placed by players, and they will be used in calculating like the appearance of things. So every light that you see now affects other materials. Check out the reflection of that light in my hat, for instance. See that? So it's not the sun, it's not the moon that's reflecting, it's actually like the lantern, and it's going into the direction of where my dude is. And this is for the new visual style that I'm working on, and it's just so nice to see. I wasn't sure if I was able to make it like this, but check it out, even internally, like if you are inside, the light is now directional. So for instance, you can see that the light is coming through this window, through this door, and it's like not affecting the top of the table. So you now have like way better directionality in here. You can also see some light reflecting on that over there. Check this out. There's lights reflecting here on in the floor. So not many games have this. There's like, not everyone has this. It's just such an insane optimization or addition to have. Like this lamp, this is a floor light, you can't really tell, but it's actually reflecting in that pillar over there, and it's actually reflecting in this. So, like, it's not perfect, but it's so good. Check it out, these metals, like the way that they are reflecting, and all of the shading that's going on. And if you add a dude, so I can add a dude. So I'm not sure if I can get under this. Okay, so let's add a dude. Oh, I can't add a dude under it. Maybe if I had it here. Let's add a dude. Whoop. So check it out. This is... You can see... You've got pretty sharp eyes, right? You can see that he's now got two lights reflecting. One from the lamp and one from the sun. I want to see with the texture. You don't. I showed it a few moments ago. The textures don't work with this visual style at the moment. But wait, we're going to retexture the entire game on this live stream. Well, not this one, but in future versions or incarnations of this live stream. And I will show you what the future looks like. It's going to be so good. It's going to even blow my mind. I was really amazed that this worked first try. Like, I just pressed the button and it worked. And it's beautiful. I mean, check it out. Here's a lantern reflecting, and we can almost tell that the lantern is... Oh, it's over there. Right. And it's a bit laggy right now because I'm playing on a unoptimized build, and I'm playing on a older computer. But check this out. See the directionality of the lighting? So this is actually a waterish statue, so you can see directionality in the lighting. So it's really a circle that's it's really like a circle or a sphere of light now, instead of like lighting everything. Now I do wonder, oh, okay, so this light is actually the knee reflecting downwards, which is also looking very good. This is a statue something. How often will you be streaming the development? As soon as or as often as I want, as often as I can. If I wasn't streaming today, I would still have been doing this work, so I would have been going through the exact same steps, exact same debugging. But I thought it would be really fun to show this live on the stream because it's very visual, and you get really great results instantly if it works. It was an insane idea, and it actually works. So instead of having to wait like weeks to show you, I can now show you immediately, and I like it. I'm really impressed with what we did today. Even though it was a long journey, I mean, I've been streaming for quite a while now. Here we are at the spaceport, so let's see if we can get some reflections going on here.
Oh,
there's already like these headlights. The headlights of the robot are reflecting in the robot itself. That's pretty fun. Here we have the UFO. I think this is mostly like environmental lighting that's being reflected, so the sun. Here you see some reflections of this lamp over here. So it's not textured right now. So how are you doing? Pretty good, thank you. I like the idea of showing how you work. Keep going. Yeah, this is I think. Here, check it out. These coins, 2 light sources, baby. Check it out. Just the shading on this is
nothing like that.
Wow.
New treasure smell.
It's so good. Here you can see the lamp reflecting in the marble, or yeah, I think this is marble. Check it out, super cool. Just super cool. Let's see if we can go inside somewhere. I'm not entirely sure what the layout of this building is, so we don't have Rob with us. Oh, this is a hole. I fell in the hole. Oh yeah, I remember this dude from the live stream. But check it out, once he's near the lamp... Oh, he's not... Is he coming this way? Yeah, check it out. Check out the light on the dude. Check it out. Whoa. So good. So good. It's so good.
Oh, divine.
So yeah, I'm definitely very happy with what we achieved today. Here's a golden spaceship. I can't really read the names at the moment because the textures aren't loaded. But here you can see, like this dude, let's see. He looks like a robot. But check out the difference in the shading between the red arms, they are metallic, and the breastplate. Like one is definitely more glossy than the other. And like his face is entirely golden. I love gold. And we can go inside here. Yeah, so see the light? These are ceiling lights. So see the light reflecting in the marble there, in the back. And it's just coming onto the table, and it's not like on the sides of the table. Here's a bit of a red reflection. I'm not sure where this light is. It should be somewhere close. That? I'm not sure. But there's definitely something red light. Check out the ceiling here. Whoa, check out the ceiling. How metallic and how... It's just lights reflecting off of lights. Check it out. Check the ceiling. Are you gonna make it so you can turn it off in the settings? I have some big plans for this. But check out the ceiling. Whoa, it's so good, it's so good, it's so good. This thing gives off light. Check out the... Here, see the reflection on the surface at the bottom? Wow. Firefly, how did you do this? I have no idea, but we did. And it's cool. And I'm going to enjoy every minute of it. Like here's another hallway, just... It was pointless. Well, Obi, check it out. Check out the fidelity of the screen. It's not pointless. Okay, so see here. So this way is looking good and the other way is a bit muffled. So what's up with that? And what's up with you, man? Blue man. It's horror lighting. Had a meeting about the finals and the end of the semester. Okay, okay. And then what? And then... So Angelo, that's what we've been doing. So this is entirely in the shadow because we're inside, but still you can see that we now have reflections from the lanterns here. So you can definitely see that this dude still has like lighting going on. And you can even see it on my shovel. Like here, this is my shovel. Near the lights. See this? So you can actually see the reflection of the lights in my shovel now. Oh, if you want answers, you have to ask other people. That's the best kind of answers. So anyway, I'm a happy camper. I'm really amazed at what we've been able to achieve here. Oh, here we have some kind of like hidden thing. Okay, that's not bad. That's a nice spaceship you've got there. So anyway, there's a few bugs that I need to iron out, and maybe there's something going on with like the sampling that's suboptimal. We can improve that, but like for now, I'm really happy with what this looks like. There are not many games like this that have this kind of fidelity in the lighting system. Nefarsby, you all know this, you all love this. So here we go, Nefarsby. This is actually going to be... I have to cook dinner in a few moments. And I've been streaming for quite some time now. But check it out, there's lights on the ground here. So the light is actually coming in from the ground. And now he's just... It looks like leather. So this is more of a leather look instead of like metallic.
We found the loot and we're happy.
Check this out. See this? So there you go.
By your command.
So it's more of a leathery armor that he has now. But he does have a golden shield, which is cool. I know, but what if it's on the 2D hero? I want to see how his abs glow up considering there are lights hidden by mimics. I have no idea what it's going to look like. But just check out the detail and the shading here.
And now we found the
Is it this way, Obi? I think it's this way, right? So this is a bit of fan service. But we can do that. We can do fan service here. I hope it's as good as we think it will be. So check out some of the light falling onto this bridge. I mean, this looks so good. I'm bopping. This is so good. Here we have the shopkeeper. Hello, shopkeeper. I'm still going the right way, yeah? Yeah. Let's take a quick peek at the market stalls here. Hello, market stalls. Hello. Looking good. No worries, mate. Another awesome vista here. And the cool thing is, again, just a quick detour here because we can. Time-lapse mode, check it out. Like, I'm pretty sure that other games are much better than this, but it does look amazing now. Check it out. Whoa. Also, we have a hailstorm at the moment, but don't worry about it. Lighting coming in from above. Okay, so now I'm a bit lost. This looks a bit less finished, but I think we're still going the right way. I love these arches, by the way. We're going to visit the Lord of Destruction.
Hey, sweetheart.
Also something that players of the game might know, I disabled the vertex displacer, so flat surfaces are now fully flat. In the current version of the game it has a bit of a cartoony displacement going on, but in this style it looks a bit better if everything is everything is just a bit like a more straight. You can definitely see the difference in materials here, so we have some marble mixed in between these other colors, and the marble is definitely more reflective here. I removed the random thing because it's way prettier with this lighting style and this style to have a flat surface everywhere. Maybe I'll put it back. So you can see some reflections of the lights already. See them? This is the sunlight. That's the sun, the big one. But you do see some reflections already, especially on the more shiny blocks. I think it's mostly marble. Interesting.
Been looking for this.
Looks pretty good already. Yeah, so this hailstorm is pretty Halley's Comet. I want to go inside. It feels like a cathedral of sorts. And this is also a reason why I wanted to update the lighting to this model, because once you're inside, you're mostly in the shadow, and then it's really important to still have like good lighting going on. And I believe that we have it with these changes. Here, check out some of the reflections on this carpet. I hope the big dude is streaming in now. Let's hope. Let's see what happens. It takes a bit of time to render. Like I said, the code is unoptimized. Here we go. Here we go. Some pretty nice reflections on the metals. Very nice. And let's see if we can get the backside of the cathedral streamed in as well. Here's some more reflections. Check out these marble columns. And this is why it's so cool to have like these straight shapes. Then the reflections are much nicer. Check it out. Whoa. I also love the look of that red anodized metal. So let's see if we can go up. Hidden lights don't really mess things up. No, but remember, the lighting model is kind of similar to what's already in the current game, right? So it's not like we have a completely different lighting model. Here you can see the shadow just moving around inside of the cathedral. It's subtle, but you can still see it. You can still kind of tell the time of day by where the shadow is falling. Looking good. Let's move up a little bit. Yeah, and here in the darkness you get these very nice reddish reflections from the red lights. There's one on this side as well. So how about that? How about that? Infinite reflections and infinite light sources. And directionally perfect. It looks spectacular. Let's go to the wide angle view for a moment. Impressive young Jedi. And all the way from wide angle we can zoom in. To really show off the shading details here. Also I'm running at 32 times anti-aliasing, so that's why you don't see any jaggies or anything. Also my screen is a little bit downsampled. But still, check it out. Alright, I'm really happy with this change. I'm pretty sure like if we disable this, everyone's immediately like, ooh, what? Here as well. See this light? This light, pointy stick. This light is actually reflecting in that block, I believe. And again, lots of work to do still, but this is a really good beginning and a really good extension to the PBR graphic style. So we hacked some shaders and we did it well. We did it really well. For a real comparison, add a way to disable while the game runs. How do we do that? I get what you're saying, and it would be a very nice demonstration, of course. But how do we do it? I don't have a concept of time here. Oh, what we can do? No. We, yeah, it's really outside of what I wanted to stream, but we can kind of do this. If we just assume that the, yeah, I don't want to do with bools or anything. So what I want to do is this, fragment, shader, pixel location. We can do half of the screen with and half of the screen without, and then we can just compare. It's something like frag coordinate or something, text coordinate. GL frag coord, this one. So sun radiance, artificial light radiance. So if GL frag coord dot x is smaller than 960, we do it. Will this work? I have no idea.
Oh, no time
So
to waste.
basically we should see, okay, so we don't see the light reflection now, but we do see it. See it? It's at the halfway point of the screen. And you can actually see that, see it? See how much it adds? So we can kind of like walk over here as well, and then you just skim like this. See the difference? Here. That's what I meant. This is what I'm talking about. You're actually seeing it, yeah. See, woo! So that's why I wanted to add it. This is crazy! It is crazy, it is pretty crazy, I'll admit that. So let's go to a wonder. Dragon Throat Valley. Sure. Ruwan, did you add any lights to this build? Are there any lights here? At all, anywhere? It's super slow though. I mean, checking the frag chord is not what you want. An if in a shader is not a good idea. Check it out, check the difference. But here again, you can see like the offset. It's to the top and to the left. There's definitely something fishy going on with the offset here. Definitely something that needs to be addressed or fixed. And I'm pretty sure I can fix it. So that's cool, but like indoors... What? See this? And it's actually coming from this light here at the ceiling. You had no clue it was this much? Yeah, okay, but this is like with no lighting at all, right? So it is a bit of a dramatic change. But you can definitely see that the left side of the screen is way warmer and way more accurate in lighting than the right side. On the right side I could potentially like do a bit of old style rendering, but I'm not going to do that at the moment. So one more wonder. San Valentin. Okay, so you can probably also see the difference on the dudes. See the difference in lighting? The directionality? Check it out on this man. Check this out. On the metallics, it's just another layer of like reflection going on. And his face, check out his face. It's not really old versus new, it's more of what we did today versus what we didn't do today. I have no idea if Hum is still here. It doesn't really matter. We have a nice demonstration of what we actually did, so I'm going to remove the demonstration now, and it just looks it's looking so good. So mission accomplished. This is exactly what I wanted to achieve. There, like I said, there are a few bugs, and with the sampling itself, there's probably a way to do this a bit better than what we're doing right now. And like it's mostly a matter of this one, the client light color provider, this class. So we just sample this this lighting information once here. We need to check propagation between chunks. That's something that we need to do. And I'm pretty sure that we want to interpolate like we do here, because otherwise you get these artifacts that you saw like left and right. Yeah, I have my own pi constant. Don't worry about it. I have all of the constants. That's how I do it, man. AD pi. I never rely on any platform definitions because I can do better. It's not 4. But again, like, we should probably sample the origin at different locations, see if any of them are null, and then remove those, and then just make sure that we interpolate between those, those, because it will make the lighting look even better in the game world, especially. But that's something for another day, I believe. I'm already very impressed with what we were able to achieve today, and that it actually works. So what I said earlier, like, let's first get it working now, see what it looks like, and if it still crashes and it looks bad, then we just throw it away. But I think it doesn't look bad. I think it's actually pretty good. The only thing that I'm wondering about is, like, why is the sun so big compared to the lights that we simulate? I'm not sure if it's purely a matter of, like, intensity. Like, that's the only thing that I'm a little bit concerned about. Like, why is this? Because we're already multiplying by 16 instead of 4, so why? Oh, whoa, wait a moment. Suppose our normals aren't normalized as well as we think we can normalize them. Suppose we are wrong. So what happens if we normalize this here? I'm not sure if we use L anywhere, like, separately.
Oh, no time to waste, let's go.
Okay, I'm going to say like, it looks even better. But I have no clue if we just changed anything. Did anything even change? Or did it already look this good? I have no idea. Time for GL frag chord, here we go. If GL frag chord is smaller than 960, we normalize. Yeah, so let's do the unnormalized version on the left, and we normalize if we're unnormalized on the left, normalized on the right. Does it make any difference? This is a good way to determine if we actually have placebos going on or not. It's the same. We already look this good. It's the same. It just already looked this good. That's the trick. It already looked this good. Okay. So we don't have to normalize the vector, but if that's not a problem, then what is? Like, why is the sun so much more powerful than what we have? Yeah, but still, like, suppose it's a placebo, but then why is the sun so much brighter? We don't have to normalize, because we already supplied normalized. I'm really happy with that. I understand. You're the problem. Thank you. Normal and world roughness. V and L. V is okay. L is changing. We have an F0 here, and we use it. Okay, F0 is not changing at all. Denominator NDF GF. Okay, that's cool. Denominator 4.0. I'm pretty sure this is all cool. This is all no problem. Energy conservation, metallic, the max, okay. Yeah, I can't see a problem. I don't see the problem. And this is sRGB to linear. It's all in linear color space. The sun color. Yeah, it's just. I don't know why we need to use this huge factor. I think 16 is a huge factor for multiplying this this lighting stuff. What if we also use 4? What does it look like?
Oh, no time to waste. Let's go.
Is it because the light is supposedly closer by? No, that doesn't make sense because we use unit vectors. There's no reason at all that it's a unit vector. There's no reason why this lamp is smaller. Oh, there is though. The lighting intensity is never 1, of course, here. We use the fall off of the lamp. Yeah, it's tiny, and we use a fall off calculated in the engine as well. So, but I do think that the 4 or the 16 looked pretty good. We can run with 8. What does 8 look like? Because some parts were getting overblown, no time to waste. Let's go. Felt with the 16. I mean, this also looks pretty credible, right? 8. It's 2 times as low. I think this looks credible. Changed it back to 16 though. I feel this is a bit more subdued, so let's check out midnight. 8.5 it is. It can be... Yeah, what do you... 16 was definitely better. 16 was better. Boom, fire it up, all the numbers.
Oh, no time to waste, let's go.
It's bright, but it's a lamp. Come on, it's a lamp. For now we're sticking with 16. I like it. Maybe do 12, you're 12. This was it for today. We made something amazing, we made something awesome. It's really cool to see. I'm really happy with the way this turned out. Just amazing shading all around. I already tweaked some of the factors, so before live streaming or even before like attempting to live stream, I tweaked some of these factors already. This was 4 and 2 for instance. And I tweaked some of the light colors and as well. But I never knew that it could turn out like this. And it's just an amazing experience. Just seeing the way the shading now works and the directionality. And maybe there's bugs in there. Maybe there's something to still fix. But check out the red lighting on the jacket. Dude. I mean, it just looks so convincingly real. This is my game, come on, and it looks convincingly real. Yeah, write a genetic algorithm that tries different, yeah, whatever. Because this is my United States of whatever. I'm happy with this. I'm really happy with this. Psychedelia, okay, this is psychedelia. Let's see, we've got lights here as well. Like one last tour here. Let's see. Check out the marble stairs. Lights are reflecting. Here we have this huge, trust me, it's huge thing. So as you can see, there is actually light coming from the bottom. So the lava pool right next to the knights is actually reflecting in their armor. Check this out. So the light is coming from the bottom and to the right for this dude. That's looking good. And the mushroom houses are looking good. Like, it's full of light, it's full of color here, and that's just the way it's built. I can't really like do anything about that. But in all, it just looks so colorful and vibrant. And that's what I wanted to go for. Colorful and vibrant. Here we have someone waiting. Hello, person waiting. Can we go inside of the house? May we enter? Oh, check it out. Even inside, like, this is what I meant. This is a little bit bright. And I'm not sure why. So this is why I would say, like, okay, 16 is maybe a bit too much. But who knows, who knows. Maybe there will be more rendering changes and this is actually the way to go. Yeah, I do have some changes, Obi, that will make you go, what? It's going to be amazing. Like, this is why I'm live streaming, because it's like every step of the way is going to be an amazing improvement. I mean, check out the lighting here on these bricks. Whoa. And check out like this organic look on this thing with the tendrils or with whatevers. It looks spooky. Oh, and there's just a dude chilling here. Do you have a light above your face? Yeah, there's a light above your face, isn't it? Yeah. And it's reflecting in your armor. It's a purple lamp. Yeah, nice, bro. It looks really realistic. I never imagined that the game would look like this. Hey, release this. It's something I've been thinking about, so maybe I should start up a Patreon where you can play these in development versions of the game yourself, if you already want to check out the greatness. And they will run much better than they do on my MacBook, I will promise you that. I think there's something to be said for that model. Here, check it out. We have some light reflecting on the grass here. Woohoo! Oh, check it out, check it out. Screenshot, screenshot. Screenshot this. Whoop, there we go. Screenshot has been saved. Two lights reflecting in my eyes. It's very nice. Can we take a look inside? Oh, why does this look like an actual building? Come on. It is an actual building. Whoa. Let's go inside. So, yeah, the programming part took a lot of time today, but the just looking around part also takes a lot of time today because we just have so many cool vistas to explore. I should run this version on my game computer that I usually use for streaming. It's going to look amazing and be fluid. And like I said, this is using anti-aliasing as well, so there's almost no jaggies. Captain moves like jaggies. Hey Infamous, how do we actually enter this building? Any idea? Check out the lights reflecting in the ceiling there. I mean, this looks like, check out the plant pot. Whoa! Do you, what? See, did you see the lights turn on there? What? What? Did you, what? Oh man, this is so good. This is so good. Let's keep on moving. Let's see what we find inside, if we can go inside. I have no idea, like, what inside even is anymore.
And now we found the loot, and we're happy.
So many thumbnails for the next episode. There's no door. How do we get in?
Been looking for this.
Here's the door. There we go, finally. And now we are inside. And there are tanks. It's a tank museum. Seriously, I wouldn't have... Like, there's these metallic plaques here. Oh, check out the... Check out the tank. Check out the tanks. The door is in the front, yeah. Thanks for the help, buddy. Thanks for the free parking. Looking good, looking good. I'm liking what I see. Yeah, what happens if you re-enable the vertex displacer? So this entire floor would then be chaos. It's just chaos. It's not what you want. It's... In fact, I'm not going to go there. Where is that? This was psychedelia, Gaston. The reflections, they break up because like all of the like pavement tiles, they get these facets to them, and you don't get these very nice reflections anymore. So that's why I disabled them. It's the best way, trust me. Okay, so we're going to leave it at this for today. 25 changed files. In the end, that's pretty good. We learned about GL-frag coordinates a bit more. It would be interesting with the specular, yeah, but interesting is not what you want. So, interesting is not what you want. 7-hour GG, yeah, 7-hour stream. But I took a few minutes off for lunch and for getting some more water. It was definitely a pretty hefty effort today, though. It's almost a full working day, which is good. I mean, I enjoyed it. We really had a goal. We had a clear goal, and we worked towards it. So no problems there. I hope everyone enjoyed the stream. I hope it's also some nice material to watch after it's been broadcast live, because like I'm trying to build an audience here, and it's kind of hard to get an audience these days because everyone thinks their projects are like the most important thing ever. And I fully agree. I mean, my project is the most important one ever. So definitely like subscribe and follow if you want more of this content. We're going to take this in different places that will look great and will be great. I'm amazed at that we actually implemented this in a single day, like going from no dynamic light sort of specularity to implementing it and it looking this good. It's just amazing. I'm really happy with the way it turned out. And on future live streams, I will be working on different areas of this game engine, on this game, different games, different techniques, different things. Like this was mostly coding and like a little bit of tweaking left and right of the visuals. But there will be streams that focus heavily on graphic design and like designing stuff instead of programming. So, oh, your project is the most important ever, Obi. I can imagine. I can only imagine. Some great content today, some great like progress made. There's probably a few bugs that I need to pick out, but other than that, I think this looks amazing. So the way I would debug this, I can at least share that with you. Let me show you. The way I would debug this is by using the normals in the world. So I have a few debug modes lined up here. So if you say like I want to debug the world normals like this, I have shown screenshots like from this mode. You see the like the normals. We're going to do a bit more, so get used to this world, get used to what you're seeing here, because this is actually the way we're going to be doing a lot of debugging.
Let's go.
Every direction in the world has got a different color associated with it. So Z+, so things that are pointing upwards, are like, kind of like this bluish, and the opposite, yellow, is for things that are pointing Z down. And as you can see, like this green is for Y+, and then the opposite of this green is kind of reddish, I think. Let's see. Yeah, so reddish purplish is Y-, and X+ has got this red associated with it, and X- is this kind of cyanish color. So here you can see like the normals in the world of all of the materials. These are used for how light is calculated. And the smoother they look, the more smoother they are, and the smoother the lighting is. So as you can see, we have hard transitions between materials, but like natural materials. Let me see if I can open the telecharger here to just randomly teleport around. Like natural hills and mountains, they have this very smooth shading, and even this crease will be removed in a few seconds when a second pass is done to smooth out the normals. There you go. So it's entirely smooth, and that just makes the lighting and the world feel so much better than a blocky world. And the models themselves, they have vertex smoothing going on as well. So, and these are oriented along the world, so you will see my model like change colors depending on the direction it's facing. So that's how I debug the world normals. But of course you don't have to stop there. You can just say vertex lighting direction, and like parts will be black now, I think. That's where no light is
No
stored.
time to waste. Let's go.
And this is like lighting direction. So you can see it's only in the place, it's very psychedelic. So this is basically psychedelia. It's very psychedelic, but this is like what the game thinks the direction of the light is. And as you can see, there's a dark spot here, while you would kind of expect the light to be pointing towards that lantern over there. So there's definitely an issue with like sampling and the way that we do this. On the other hand, like the colors around this lantern otherwise are looking pretty good, except for this dark spot over here. So why is this spot dark? It's something that we can like try to figure out for the future. Like the smoother this looks, and the less like here are some weird discolorations going on, and inside, like here we also have like parts are very nice. Like the parts of the lighting that look good are very nicely like gradients, very nice gradients here. But there's like this weird blue spot that you wouldn't expect there. So this is probably the way I will be like debugging this. It looks very psychedelic. I like the look of this. I mean, we worked hard to get this far. Yeah, you can access the shader files. That's how you do it. Again, here's a dark spot next to the lantern. There's kind of like a pattern emerging here. But this is the way I would start to debug this. I'm also not sure what's up with this like intermediate bluish color. Like why is it blue? I have no idea. And here you can see that this information isn't being passed across chunks, or at least not in a way that is useful to the engine. See, because there's this like very obvious gap between the chunks, so something is up with that. We are probably passing some information along between the chunks, because this, like in this part, it looks good. But there's also places where it doesn't look good, so... You could use it for an evil sorcerer's effect. Yeah. Like something is up here. You would expect this to be like a gradual change instead of having this hard transition. Oh, boom. Just give the engine some time to propagate the values, actually, because it's rendering chunks a little bit more slowly. Okay, so I take that back. I take that back. Anyway, so this is kind of like what we've been working on today, and I really enjoy it. So maybe you could also say, maybe the trick here is to improve the sampling, but also to make sure that we store directionality even if light is blocked. Because we still need direction, light direction, if we have a modest amount of light. So we could check for that, if there's any spots where we have light without the direction. Again, here's a dark spot in this wall. It's probably like a sampling error, and it's probably because we're not sampling correctly. Like I said, I just quickly hacked it in there, and maybe just fixing the sampling fixes everything. Here you can see that the light is offset by half a block or so. On the left side you do kind of like have lighting, and on the right side you don't. So those are like sampling artifacts that we could find and fix. So anyway, this is how I would debug this, and probably will be debugging this. Other than that, I'm really happy, or in all, I'm happy what we achieved. This was this live stream for today. It was a very long hacking session. Hopefully you are able to like pick and choose parts that are to your liking. I'm sorry these are not like very tiny features that we add to the game. It's like a major rewrite of the game engine and a major rewrite of the rendering path. Still, I hope it was interesting to see and that you learned some things. In the future, definitely feel free to ask me like, how do you do this, or why are you coding it up like that? And just feel free to hop into the channel or the live stream at any time, even if no one is watching. I mean, you can still ask questions about the source code or the code base or the way that things are structured, and I can probably help you out. So that's pretty cool. It was very interesting. Okay, cool. You also saw me share the first source code of Angelus, sort of. It's all copyrighted by me, so don't copy parts of this. It's just like you can get a feel for what the code base is structured like. It's not meant to be open sourced or anything at this moment, but I do give a glimpse into the development of the engine right now. So if you like that, there's more to come, and there's more cool stuff that I want to work on. Very visual stuff, mostly on this development front, because like having one like number change somewhere in a screen isn't like the most interesting thing, but this is like all pixels, like everything, the entire game experience is changing by changing these things. So I'm really I think it makes for a very good streaming content, this. You're going to rebuild the game from these videos. I'm looking forward to it, and once you have improvements, let me know. I want to share them, or I want to get them back as well. So this was a stream. I hope you enjoyed it. I will be streaming Angelus Live, which is my usual live stream format, tomorrow evening. At least this evening in my time zone. It's at 1700 hours UTC. I don't think I will be doing a development stream tomorrow, because I'm probably going to like see what I can tweak and change and optimize about the version that I've been showing you today. See where the bugs are and try to work them out. The chunk propagation does seem to work, so I'm happy about that. But there's a few other things that I can change and optimize. But we got the entire chain of changes working from the game to the fragment shader. Everything worked almost first try, which was really great to see. And like I'm going to perfect this, commit this to the code base, and then we're going to work on other changes that are even more radical, and you will enjoy it. I'm pretty sure it's going to look amazing. Thanks for watching, and thanks for like all of your feedback and comments. It was like the first time I did this. I hope to build an audience. Like I said, I think especially with these visual things, it's very satisfying to see the changes happen and kind of the process that you have to go through. The diagram that I made at the start of the stream, I probably should have saved it so that we could revisit it later on and like show all the steps and the things that we have done. But that's a lesson for the next time. The stream format itself worked pretty well for me. I even had lunch. I mean, that was about 25 minutes or so that I was gone, or 20 minutes even. It worked pretty well. But like I said, it's a full working day, give or take. It's been 7 hours setting up the stream. But it's definitely a new way of working on the game, and I enjoy this. Even if people don't like join the stream live, that's no problem, because you can always rewatch and comment on YouTube later on. But I definitely think that I will be doing more of these streams and more frequently than the Angelus live show. But that's coming up. The next one is tomorrow evening. I will definitely link people to this live stream and show things that we've been doing. And hopefully people will get excited and we'll get more people in there. Because I think the whole world needs to see what we're doing here. It looks amazing. There are not many game engines, and I promise you this, there are not many game engines that have this kind of lighting system going on, where you can have an infinite number of lights affect the game world. At least I think we're doing like sort of state-of-the-art-ish stuff here with the PBR-Shader and infinite lights. Also, we're running on a very low-end MacBook, so performance is going to be better if you're playing on a better computer. Like streaming itself, the streaming of this is already taking up about like a quarter of my resources. So come on, give me a break. I'm streaming from macOS again, which feels good as well. So thanks for watching. I hope you enjoyed the live stream. If you have ideas for new future stream content, let me know on YouTube or on Twitch. I'm not sure if Twitch has got whispers, so you can whisper me there if you want. And on YouTube, you can just send me like a comment on a video or a channel comment, and it's all going to be great. So yeah, I enjoyed it, and even though, like I said, I'm trying to build an audience. If that doesn't work out, no problem. We still have this awesome new technology coming to the game, and that's worth a lot. So this was the stream for today. Hope you enjoyed it, and I hope to see you all tomorrow on Angelus Live. So check out playangelus.com if you want to see more of this game and what it currently looks like. And this was like the development stream for today. It was fun to do, and I will definitely be doing some of these in like next week or so. So I'm going to mute my microphone, going back to the starting slide, and then I will end the stream. Thanks for watching, and I hope to see you again in the near future. Have a nice weekend in the fonts. See you later, bye!